Hello and welcome. My name is Zaid. I'm an ethical hacker, a computer scientist, and I'll be your instructor in this course. In this course, I'm going to teach you ethical hacking from scratch. So I'm going to assume that you have no prior knowledge, and by the end of it, you'll be at a high intermediate level. So we'll start by teaching you how to set up a penetration testing lab and how to install the needed software so you can practice hacking safely. Once done, the course is divided into 4 main penetration testing sections. The first is the network hacking section, where you'll learn how networks work, how devices communicate with each other, and how to exploit this method of communication to control all the connections around you, crack Wi-Fi keys, and gain access to Wi-Fi networks, whether they use web, WPA, or WPA2, and intercept data to capture usernames, passwords, chat messages, or anything that anybody does on the same network. Once done with this, we'll move to the gaining access section, where you'll learn how to gain access to servers and personal computers. So first, you'll learn how to gather comprehensive information about your target, discover vulnerabilities, and exploit them to gain full control over the target system. Not only that, but you'll also learn how to generate undetectable backdoors and use social engineering to deliver them to your target as a fake update or as a PDF or an image or any other file that they might be interested in. You'll also learn how to spoof emails so when they're delivered to your target, they appear as if they're sent from a friend, from their boss, or from any address that they're likely to interact with. Once done with all of this, we'll move to the post-exploitation section, where you'll learn what can you do with the access that you gained in the previous sections. So you'll learn how to interact with the file system, how to execute system commands, record keystrokes, open the webcam, and even use the hacked computer as a pivot to hack into other computers. Once done with all of this, we'll move to the website hacking section, where you'll learn how websites work, how to gather comprehensive information about a target website, and how to discover and exploit a number of dangerous vulnerabilities that allow you to gain full control over the target website. At the end of each section, you'll learn how to secure systems and secure yourself from the discussed attacks. Now, as I promised you, this course is going to be highly practical, but I also promised that I will not neglect the theory. Now, what we mean by hacking is being able to gain access to a system that you're not supposed to have access to. So, for example, logging into an email account that you're not supposed to have access to is considered hacking that account. Gaining access to a remote computer that you're not supposed to have access to is hacking that computer. Reading information that you're not supposed to be able to read, again, is considered hacking. So you can see that there is a large number of ways to hack into a system, and the word hacking can refer to a number of things, but the main concept is the same. Gaining access or being able to do things that you're not supposed to be able to do is considered hacking. Now, there are 3 main types of hackers. We have the black hat hackers. These are the bad people that hack systems illegally in order to steal money or to achieve their own illegal goals. The second part of hackers are the white hat hackers. So this is us. These people use the same techniques used by the black hat hackers, and they also hack into systems, but they only hack into systems that they have permission to hack in order to test the security of these systems. And finally, we have the gray hat hackers. These are a mixture of the two. So they'll hack into any system, even if they don't have permission to test the security of the system, but they will never steal money or damage that system, and in most cases they'll go ahead and tell the administrator of that system. But what they do is still illegal because they test the security of systems that they do not own or do not have permission to test. Now, one big question that people always ask is, why hacking? Why teach or learn hacking? Well, hacking is an existing industry. There are lots of job opportunities for ethical hackers, for people like us who would go ahead and test the security of systems to make sure that these systems are secure and not vulnerable to black hat hackers. There is actually a huge demand for ethical hackers these days because of the increased amount of hacking attacks. So we hear on the daily, big systems and big companies are getting hacked. Not so long ago, Uber got hacked and information of more than 56 million users were exposed. So companies like Uber, Facebook, and Google, they hire hackers in order to try and hack into their systems and tell them where the weaknesses are so that they can fix it. They also have bug bounty programs where they literally ask all the hackers around the world to go ahead and try to hack into their websites and with their web applications. And if they could, they will pay them a bounty for the bugs that they find. As I mentioned, this course is going to be highly practical. Therefore, you will need a lab, a place where you can practice and experiment with the things that you're going to learn in the course. Not only that, but having a lab is essential for hackers or pen testers, because let's say you discovered a new attack or you want to experiment with a new attack, or you learned something new online and you want to test it, then the perfect place for you to test this and practice hacking is a hacking or a testing lab. Now, to create a lab, you just need a number of computers with different operating systems, and you'll need a number of networks if you're testing network attacks, and if you're testing website attacks, then you will need to install websites on these computers. Or you can do all of this inside your computer, inside one machine, and install everything else as virtual machines. And this is what we're going to do. So let's say you have your computer right here. This is your main computer that you use every day to check your emails or even to watch this course. This computer might be running Windows, OS X, or Linux. It doesn't really matter. It can run any operating system. You can keep all the programs that you love and like, and install a virtualization software such as VirtualBox. A virtualization software allows us to create a number of virtual computers inside your main computer. So we can have 3 or 4 or 5 or 10 computers all installed inside your main operating system, inside your main computer. The really cool thing about this is you will not need a number of computers. You can do everything inside a single computer. So what we're going to do is we're going to have a hacking machine. This is going to be the machine that we will use in order to hack into other machines. We're going to install Kali Linux on it, and we'll talk about what that is later on. And we're going to have 2 target machines. These are machines that we're going to try to hack into and practice hacking against. One of them is going to be running Windows, and the other one is going to be running an operating system called Metasploitable, and we will talk about that once we get to it. Now, it is very important to understand that you will not lose any functionality when you install an operating system as a virtual machine. You can use that machine exactly as if it's a real physical machine. So the really cool thing about using virtual machines, first of all, you're not going to lose any functionality. Second, all the machines are going to be isolated. So as we go through the course, we're going to be trying to hack into these machines, and we might actually break one of them. But that's fine. It will not affect your host machine. You will be able to easily fix this and go back to a snapshot of when the machine was working without affecting your main computer. The other cool thing is that you'll be able to have a number of different versions of each of these machines, and you'll be able to change the configuration easily, change the network settings, or switch between different states of these machines, and so on. So, by using virtualization, you will not lose any functionality, but you will gain so many cool features. And the main thing to keep in mind is your host machine, your main computer, will never be affected. It's completely isolated. And if we break any of these machines, nothing will happen to your precious computer that you use every day. And this way, you can always use your host machine for daily use, for checking emails, watching the videos, doing whatever you do normally, and then use your virtual machines for hacking and practicing the attacks. And this is what I actually do. So you can see I have my host machine running OS X, and I never use this for hacking. But right here I have VirtualBox, and as you can see I have a number of operating systems installed on it, and I can literally start any of them by selecting the one I want and just click on start. Now don't worry about this, I will show you how to install these virtual machines as we go through the course. But what you need to do right now is download and install VirtualBox, this program. So you can download it from this page. I'm going to include its link in the resources. And like I said, you can install VirtualBox on Windows, OS X or Linux, so it supports all operating systems. Just pick your operating system from here, download the relevant installer and install it. Installing it is very, very simple. All you have to do is literally double click the installer, click next, 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 and it'll install it for you. Once you start it, you'll see a program similar to this, but you will not have any virtual machines here, so it will be empty. And I will show you how to install all of these machines as we go through the course. One more thing to do as soon as you install VirtualBox is to download and install the extension pack. This will give you better compatibility, and it'll allow you to use USB devices on the virtual machines. So you'll be able to use a USB mouse, USB keyboard, and USB wireless adapters. Again, downloading and installing the extension pack is very, very simple. There is only one file. It's always the same file for all operating systems. It's the same for Windows, for Linux, for OS X. You just have to click on the download link in here. Once you download that, I already have it downloaded, so I have it right here. And this file will only work if VirtualBox is installed successfully. So first of all, install VirtualBox from these links right here, like I said. Once you download it and install it and can see a window similar to this without these machines right here, we'll see how to install these later. Then download the extension pack from here. You'll have its file similar to this file, and only then you can double click this file and it will automatically open in VirtualBox. As you can see, it's telling me that I want to install the extension pack. It's giving me the version, which is the same version as the version of the VirtualBox that I downloaded. It has to be the same version, otherwise it will not work. I'm going to click on install. We're going to agree to this license. I'm going to put my password. And as you can see, it's telling us that the extension pack is installed successfully. So now we can go ahead and install virtual machines in VirtualBox. Throughout the course, we're going to use a number of hacking tools. You can install each of these tools manually, or you can do what most hackers do, including myself, and save time and effort and use an operating system designed for hacking. We're going to use an operating system called Kali Linux. It's a Linux distro based on Debian, and the only difference between Kali and the actual original Debian Linux distro is the fact that Kali has a lot of hacking and penetration testing tools pre-installed and pre-configured in it. Therefore, once you install Kali, you will have access to so many hacking tools without the need to install or configure any of them, which will save you a lot of time and a lot of effort. Now, just like any other operating system, you can install it as a main machine or as a virtual machine. Now I'm going to install it as a virtual machine because, like I explained in the previous lecture, we will not lose any functionality by using operating systems as virtual machines, and it comes with a lot of benefits because it's completely isolated from our computer that we always use. So if we break the virtual machine or if we want to delete it and reset it, it will not affect our main operating system. Now, as mentioned in the previous lecture, before creating and using virtual machines, you will have to install VirtualBox, and I showed you how to install it on Windows, Linux, and OS X. So once you have VirtualBox installed, you can go ahead and follow the steps that I'm going to show you right now to install Kali Linux. Now keep in mind, I'm doing these steps from an OS X computer, but you can follow the exact same steps on any operating system you have, whether you have Linux or Windows, as long as you have installed VirtualBox on your system as shown in the previous lecture. Now the first thing that you want to do is download the VirtualBox image of Kali Linux. So you can download it from the resources of this lecture. To access the resources of the current lecture, we're going to scroll down to the lecture. We're going to click on the resources icon, and then we're going to click on the resource that we want. And in this case, we want the Kali 2020 download page. So we're going to click on it. Now, before going ahead with this, I want to highlight something that is very, very, very important. So please pay attention. This is a custom Kali image that I made for my courses. It is smoother and faster than the original one. It fixes a number of bugs, and it contains a number of extra programs that we need for this course and are not included in the original release. So you do not have to use this custom image. You can use the original one. You can even use just a normal Linux distribution, as long as you know how to manually install all of the missing programs and apply the fixes that I did myself. And you can see a full list of them here on the left. Therefore, if you ask us a question in the Q&A section and you're not using the custom image, the first thing that we will ask you is to use the custom Kali image that we made for you, because we know the original one is broken and we will not know the changes you made in order to fix it. So, if you have a 64-bit computer, download it from one of these links. Or if you have a 32-bit computer, then download the 32-bits version from here. Now this is a big operating system, so I've actually already downloaded this before recording this lecture, and I already have it right here. So as you can see, you should get a file with a .ova extension. So you have the file name followed by .ova. To import this in VirtualBox, all we have to do is literally double-click the file. As you can see, this will automatically run the file in VirtualBox, and you'll get a window which you can use to modify the settings of this virtual machine. For now, I'm going to keep everything the same, and I'm just going to click on Import. Give it some time. And as you can see now, this is imported into my VirtualBox, and we can go ahead and try to start it. But before doing that, I want to modify some settings. So we're going to click on the virtual machine that we want to modify its settings, which is Kali Linux in this case, and then I'm going to click on the settings icon. Now, depending on the host operating system that you're using, the layout of the settings menu in here might be slightly different, but using it is exactly the same. So make sure you follow the steps that I'm going to show you right now, and it should work on all operating systems, whether you're using Windows, Linux, or OS X. So the first thing that I want to modify is the system settings. So I'm going to click on System, and in here you can first of all modify the amount of RAM or memory that will be allocated for the virtual machine. Now, depending on how much RAM you have in total, you can give this more or less. 2 GB is enough. You can get away with 1 GB, but it might be a little bit slow. So I'm going to leave it at 2. I have 16 gigs, so 2 will not cause any pressure on my host operating system. Next, I'm going to click on the processors. And as you can see, by default, it's only given 2 cores. Again, you can give it more or less. You can get away with 1 core. It'll be too slow. 2 is good enough. The more the better. Again, it all depends on how much resources you have and can afford to give to virtual machines. I have 8 CPUs, so giving it 2 will not put too much pressure on my operating system. Next, I'm going to go to the network settings, and I'm going to set this to use a NAT network. Now, sometimes when you select a NAT network, you will not see a network name in here. If you don't, then don't worry about it. This is a common issue, and I have the solution for you in the resources of this lecture. Just click on it, follow it, and you'll see how to fix this issue. Now for me, as you can see, I already have a NAT network in here, so I'm going to keep it on this one. And this setting will basically create a virtual network where my host machine, which is my Mac OS X computer, is going to be the router for this network, and then all the virtual machines are going to be clients connected to this network. So they're going to get internet connection from my host machine. And at the same time, all of my virtual machines will be connected to the same virtual network. This is very handy because my virtual machines will be able to communicate with each other, and therefore will be able to use the Kali machine to hack into the others, will be able to test network attacks, and do much more. So this setting will first allow my virtual machines to have internet connection, and it will also allow them to communicate with each other through this virtual NAT network. Now this virtual network will rely on the connection of your host computer. So it will not need any extra interfaces, it will not need any extra adapters, and as far as the virtual machines are concerned, they are connected to an Ethernet network, but in reality, they are connected through the host machine. Now, if you're on VirtualBox 6 and have a screen with high resolution, you'll need to go to Display and set the scale factor to 200%. Otherwise, the virtual machine screen will be too small, but only do this if you have a screen with a high resolution and if you're using VirtualBox 6. Otherwise, do not modify this option. Now I'm done here, so I'm going to click on OK, and we can start the virtual machine like any other virtual machine. We're just going to click it and then click on Start. Now, if you followed everything that I did so far and faced a black screen or got an error, please check out the links in the resources of this lecture, as they cover the most common issues that you could face when starting Kali. If you got an issue that is not covered there, don't worry, please ask us in the Q&A section and we will respond to you within 15 hours and help you fix this issue. Now I'm going to click inside the virtual machine and hit enter. And as you can see, we have the login screen for Kali Linux. So right now it's asking me for the username, and the default username is root, R-O-O-T. I'm going to hit enter, and then it's asking us for the password, which is the reverse of the username, so it is T-O-O-R. Hit enter, and that's it. Now we're inside the virtual installation of Kali Linux. Now don't worry about how this operating system looks different, and if you don't know how to use it, we will cover all of that and we'll cover its basics as we go through the course. But for now, if you just look at the top right in here, you'll see that this virtual machine thinks that it is connected using a wire. So you can see wire connected. So Kali thinks that it is connected to an Ethernet network. And that's because, like I said, we set it to use a NAT network. So if I just go to my web browser, as you can see, we have internet access in Kali Linux, and this is provided from the host computer. So Kali is connected to the internet through the host computer, and as far as Kali is concerned, the host computer is a router, and it is connected to this router through an Ethernet cable. If Kali feels a little bit too slow or laggy, please give it a few minutes if this is the first time you run it, because when you start it for the first time, it will automatically check for updates. Once this process is done, the system will start running a little bit smoother. Also, it goes without saying, if your computer is not powerful enough, then close any unused applications before starting Kali to free up resources. But as you'll see throughout the course, 2 GB of RAM and 2 CPUs are enough to run Kali smoothly. Now that we created our virtual machines, it's a really good idea to take snapshots of them. A snapshot allows you to store the state of the current virtual machine. So it allows you to go back in time or go forward to a certain state after you go back. So you can think of it as bookmarks. For example, now we can take snapshots of our fresh installation of the operating systems, and in the future, if we update or configure something or break something, you can literally just go back to the fresh install or go back to factory settings if you want to call it. Then, if you did something there and then you wanted to go back to your updated system, then you can go back to the updated system as well. So you can literally take a snapshot whenever you want to store the state of the machine, and then you can go back and forth between these states. Now I'll show you how to do that. I have Kali Linux right here, the one that we installed, and it's very easy to create a snapshot for it. All you have to do is just go on the snapshots here and click on the camera icon. Then it's going to ask you to call this snapshot something. So I'm just going to call it fresh install. And I'm just going to give it a description saying it's a fresh snapshot with no updates. It's always a good idea to give a good name and good description so that in the future you can actually remember what the snapshots stand for. So now that I'm done, I'm just going to click on OK. And now you can see that we have the current state. So whatever you do in here, you can update, you can install programs, you can install libraries, and then if you break something or if you ever wanted to go back to the fresh install, you can just come back, click on the fresh install and restore. So let's see now. I'm just going to go back to the details as normal, and then we're going to start our virtual machine. I'll just show you an example now. So let me just create a new directory in here. So let's imagine that you actually updated the system. Now in the future, we're going to talk about updating the system. And I'm going to tell you that when you update, there is a good chance that some libraries, some programs will not be as up to date as the libraries that will be installed. And then these programs might start giving you issues. Now, if you had the issues, you can put them into discussion and then I'll help you with them. But some cases, I'll tell you that you need to go back or downgrade to the older version without the update. So all you'll have to do is just get back to the fresh installation to your fresh snapshot. So now I've just created a new file just to show you that once you actually go back, everything will go back to the way it was before the changes that you made. So I'm just going to turn off Kali. And now if we go back to the snapshots, you'll see that we have our current state. This state has been changed, so it's a changed state. Now let's say that you updated and the update was successful, so nothing was broken and you are happy with it. So what you should do is you should just come in and click on the camera icon again to create another snapshot. And we're going to call this one updated system. And then you can just put the date if you want to. And then I'm just going to put the description updated with no problems. So I'm going to click OK. And you can see that we have two snapshots. We have the first one, which is our fresh install. And then we updated our system and we have an updated snapshot of an updated system. So now let's say that after you updated and you thought everything is okay, you are using the machine and you have problems, so you wanted to go back to the fresh installation. All you have to do is just click on the fresh install. And you can see that the restore icon right here, just click that. And now it restored me to the fresh installation. So now if I start the Kali machine, you'll see that the new directory that we created will disappear. Now, as you can see, we're back to where we were without the new directory, without anything. So we are actually back to the fresh installation of Kali, to when we actually took the snapshot. So now I'm going to show you another example. So let's say you went back in time and you went back to your fresh installation, and then For some reason, you wanted to go back to your updated state to see if you can fix the issue, if I suggested the solution, or if you read the solution online and you want to go back and fix the issue that you had after the update. Or for any other reason, maybe you just wanted to go back to a different state. It wasn't an updated state. I'm just giving an example with the update. So if you want to go back to a future state, you can still do that. So all you have to do is just, again, click on the updated, click on the restore. And we don't want to create a new snapshot from the current state because the current state is the updated state. So we're going to restore this, start the machine, and you'll see that we'll be back to the updated state to where we had the new directory created. So we're actually going to go back in the future now. And as you can see now, we have our test directory. So we're back to the state where we updated the system. So again, as you can see, the snapshots can be really useful. They can allow you to store bookmarks or states of the operating system. So you can actually have different configurations and you can switch between them as you want. Okay, now that we have Kali Linux installed, I want to give you a basic overview of this operating system in this lecture so that you're comfortable with it. And we're going to be using it throughout the whole course. So everything is going to become easier for you as we go through the course. Now, the first thing that I want to talk about is the status bar in here. So you can see we have an applications menu in here, and inside it, you can see all the applications are categorized. So we have information gathering applications, vulnerability analysis, web application analysis, reverse engineering, and so on. So you can go on each one of these entries and just select any program that you want to run. And the next menu that we have is the places, which shows you the most common places in the file system. So we have home, we have the desktop, we have the documents, downloads, and so on. So you can access the places from here and then you click on home, or you can just click on the files icon in here on the left, and both of these will bring you to the home directory, which is actually the root directory. So it says home in here, but the actual location of this, if I do Control L, you'll see it is /root. So inside this, you can see we have our downloads, music, pictures, similar to the way that you'd have it in Windows and OS X. We also have the time in here. And in here on the right, we have more controls. So the first thing that we have in here is the workspaces. So Linux comes with multiple workspaces by default. Basically, what this allows us to do is we can have this desktop in here. For example, we can open the places and we can, for example, navigate to downloads and do some work in here. But if we go here to workplaces and go to the second one, you can see that I have an empty desktop that I can do whatever I want. And for example, I can launch Firefox in here. And then again, if I want to go back to the first workspace, all I have to do is click on here, click on number 1, and I'm back in here. And because I've already used up 2 spaces, the system is already creating a third empty space. So I can click on that. And as you can see, I'm in the third space where I can do more stuff. Now you can also navigate between the spaces by pressing Ctrl Alt up or down to go up and down in the spaces. The next part of the status bar is this last part in here. And if you click on it, basically the first thing it'll allow you to do is control the sound. Next, you'll see your connections. So as you can see right now, and as I showed you before, this is showing up as if we're connected to a wired network because I configured this network to use a NAT network. If you have a wireless adapter connected to this computer, you should be able to see it here. If you don't see it, then follow the link in the resources of this lecture to see how to properly connect your wireless adapter or any USB device to a virtual machine. Now, I should note, you can only use external USB adapters in order to access Wi-Fi networks from Kali. You cannot use the built-in Wi-Fi card. But Kali should have internet connection anyway because it is configured to use a NAT network, and as you can see in here, it's telling me my wired is connected. So if I actually go down to Firefox, I'll close this. And if I just go to google.com, you can see it is connected to the internet. So let's go back to where we were. And if we click here, we also have the battery settings, the user settings. You have this button to turn off the machine. This is to lock the machine, and this will show the preferences where you can modify the preferences of the machine. So you have Bluetooth, Wi-Fi, change the background, change the languages, and so on. So you can spend some time getting familiar with this. It's very easy and very intuitive. Same goes to the file manager in here, very intuitive. Double click to go in. You can right click and archive and extract here to uncompress it. You can navigate throughout these files by clicking them, and then you have the trash here, which contains the deleted files. Now we also have the dock in here, which contains the favorite applications, and you can also access all the other applications by clicking on this icon right here, the show applications, and this will show you a menu with the most frequent applications, and then if you click on all, it will show you all the available applications. Okay, now that we had a quick overview of Kali Linux, I want to spend some time talking about the Linux terminal. So you can access the terminal through this application right here. So if we click on that, it will open the terminal window for us. And as you can see, all it is a black screen where you can type commands. Now, the Linux terminal is actually very, very powerful because it can be used to do anything that you can think of, really. A lot of the applications in Linux that have a graphical interface were command prompt programs first, and then people made a graphical interface for it. So a lot of the time, maybe the graphical interface will be buggy or crash, and the terminal program will still work. Also, a lot of the penetration testing tools do not even have a graphical interface. A lot of them can only be used throughout the terminal. Not only that, but in many scenarios, you might only have an SSH or a command prompt access to a machine. So you need to know how to use this command prompt in order to achieve your goals. So throughout the course, we're going to be using the terminal a lot, and that's why I want to spend some time just showing you the basics of it and making sure that you're going to be comfortable using it. Now, the basic idea is you type a command and the result will be displayed for you on screen. So let's have a look on a very, very simple command, which is pwd. Now this command prints the current working directory, hence the name pwd. So if I hit enter, you can see it's printing /root, which means right now I am in the root directory. So basically I am in here. This is the root, it's home. So if I do ls, which is a command to list all the directories and files in the current working directory, we should get all of these directories that we see in here. So if I hit enter, as you can see, I can see all these directories in the current working directory. Now, another very useful command is the cd command. This command allows us to navigate into another directory. So for example, let's say I want to navigate into the downloads. All we have to do is type cd, followed by the name of the directory that I want to navigate to. So I'm going to type downloads. Now if I hit enter, I should be inside the downloads now. So if I do pwd to see my current working directory, you'll see that it's saying I'm in root /downloads. So if I do ls here, it should show me all the directories and files inside downloads. So if I do enter, as you can see, I have a directory and a file in here, and these are the exact same files that you'll see if you double click the downloads here. Now, if you want to go back one directory, so similar to pressing the back button in here, all you have to do is do cd, again the command to change the working directory, followed by ... And now if I do pwd, you'll see I'm back in root. And if I do ls, you'll see all the directories and files in root. So that's all good. And there's actually a huge number of commands that you can use. So I'm going to include a link in the resources of this lecture of all the Linux commands that you can use. You don't need to know them by heart. We're actually going to be using a lot of them throughout the course. So you're going to naturally learn them as you go through the course. Now, if you are using a command and you're not sure about how this command works, you can just use the man command to display the manual of this command. For example, we've used the ls command here to list the files and directories in the current working directory. But if I do man followed by ls, this basically means I'm requesting the manual of ls. So I'm asking, how can I use the ls command? So if I hit enter, you'll see I'll get a screen similar to a text file. And basically, it's given me a lot of information on how to use the ls command. So you can see that it's telling us that this command will list the directory contents. You can see the way it works by typing ls, followed by the options, followed by a file if you want to run it on a file. You can see a longer description of the command. And then you can see all the options and the arguments that we can use with this command. Now, in Linux, most of the time, the options will always follow the same syntax. So you either use -letter or -- a word to specify the argument. For example, in here, the -a and -- will ignore entries starting with dot. So if you keep going down in here, you'll see all the options and arguments you can use with the ls command. And we have another example here. We have the -l, which means it's going to use a long listing format, which will display more information about the files in the current working directory. So let's have a look on that. I'm going to press Q to exit this, and then we're going to do ls as usual. And since we read the manual, we know we can do -l to see more information about the files. And if I hit enter now, you can see I'm still getting the same directories, but it's also showing me the permissions, the users, the date created, and so on. So you can use the man command on any command you want, not only on the ls. So you can use it on the pwd, you can use it on the cd, or any other command, and it'll show you full description or the manual page of how to use this command. Now, I'm going to clear the screen by typing clear. And the next thing that I want to show you is the --help. So this is something that you can use again in almost all commands and all programs in Linux. So you can just type the program name or the command name followed by --help. As you might think, this will show you a help message telling you what this command is or what this program is, the arguments that it takes, how to use these arguments, and examples at the bottom. Now, another useful thing with the terminal, so I'm going to clear this again, is the arrows. So you can press up to go up to see all the commands that we executed before. And again, you can go down to navigate between the commands that you executed previously. You can also use the tab for autocomplete. So again, let's do ls, and you can see all the files. And let's say we want to go into documents. So we can do cd followed by documents. You can type documents, or if you're lazy like me, you can just do doc and press tab. And as you can see, it's automatically completing the rest of the word for me. So this is something that comes very, very handy when you're using the terminal for a long time. Now, what I also want to show you is how to install programs in Kali from the terminal. So first I'm going to clear this. And the first thing that you want to do is update the sources where Kali can search and download programs from. So we're going to do apt-get update. Now, apt-get is the name of the application that allows us to download and install programs. And we're saying update because I'm saying that I want you to update the list of all the programs that I can install. So I'm going to hit enter. And you want to make sure that you have internet connection when running this. And as you can see, it's telling me that it's done. And now we can go ahead and start installing applications. So the first program that I want to install is actually a terminal program, so similar to this one, but it allows us to have multiple terminal windows open in the same window. So in order to install a program through the command line, we're going to do apt-get, which is again the name of the program that allows us to install programs on the system. We're going to say that I want to install, and the program that I want to install is called Terminator. So very, very simple. First of all, we're typing the name of the command, which is apt-get. We're saying that I want to install, and the program name that I want to install is called Terminator. So I'm going to hit enter. And this is going to download and install Terminator for me. So you can use the same command to install any program that you want. You just need to replace Terminator with the name of the program that you want to install. Now I've already downloaded and installed this before, so it didn't ask me to confirm. But if you're running this for the first time, it might ask you to confirm whether or not you actually want to install this program. So all you'd have to do is press Y from the keyboard and hit enter. Now, as you can see, it's done. So if I go to my all applications in here and just type Terminator, you can see that I have it here. So I'm actually going to drag it and put it in my dock so I can access it easily in the future. So now I can just click it in here and that will open Terminator for me. Now this is another application that allows me to run commands. So it's exactly the same as this. So again, I can do ls and pwd. The only difference is with this one, I can actually right click and click on split horizontally, for example. And this will split the same screen into two screens where I can run commands at the same time. So I can have some commands in here and I can run commands in here. And then I can even split this more if I want, again, vertically or horizontally. And as you can see, I can have as many terminal windows as I want. And this will be very helpful in the future when we'll be running a number of programs and a number of commands at the same time. The first penetration testing section in this course is going to be the network hacking section. The reason why I chose to start with this, because everything, if you think of it, is connected to a network. So whether your target is a personal computer, whether it's a server, whether it's a company, or even if it's just a website, all of these systems are actually connected to a network. Literally, when you just connect to the internet, you're connecting to a network because the internet is just a really, really big network. So it is very important that you understand how networks work and how devices communicate with each other before we actually move into the next sections. So this section is actually going to be divided into three subsections. In the first subsection, we're going to talk about all of the attacks that you can do before connecting to a network. So you literally just have a computer with a network interface, possibly a Wi-Fi adapter. And we're going to see what can you do now before even connecting to anything. In the second subsection, I'm going to show you how to crack Wi-Fi keys and gain access to Wi-Fi networks, whether they use WEP, WPA, or WPA2. Once you have the access, you can move to the third section, which will apply for both Wi-Fi and wired networks. All of the attacks that you will learn in the third subsection apply whenever you are able to connect to the network, once you're able to gain access to the network. And here is where the real fun starts, because you're going to learn a number of powerful attacks that will allow you to intercept the connections in the network and capture everything sent in it, including usernames, passwords, URLs, chat messages, and so on. Not only that, but you'll also be able to modify data as it's being sent in the air. So you'll be able to control requests, serve people fake updates, inject evil code into the pages that they load, and so many other cool things. So everything in the third section will apply for both Wi-Fi and wired networks. Now, before we start talking about network hacking, you need to have a basic understanding on how networks work. Now, we all know that a network usually contains a number of clients connected to each other, and clients usually connect to a network in order to share data or share a resource. A really good example of a resource that we all have connected to networks in order to access is the internet. So we connect to Wi-Fi networks and even wired networks all the time just to access the internet. Now, all networks, whether it's Wi-Fi or wired, work on the same principle. They have a device that is considered a server. Now, in many cases, for example, in your home network, this server is your router. This is also referred to as an access point. Now, this router or server or access point is the only device that has access to the resource. So none of these clients have direct access to the resource even after connecting to the network. The only way they can access the resource is through the access point. So let's say, for example, you're client number 1 and you connected to your home network over Wi-Fi or over Ethernet over a cable, and then you opened your browser and you typed google.com. What happens is your computer will send a request to the access point asking for google.com. The access point has access to the resource, which is the internet in this example, so it's going to go and look for google.com. It will receive google.com and it will forward that response to your computer, and as a result, you will see the website loading on your browser. So if you actually go to your router at home and look at it, you'll see at the back it's connected through a cable to the wall, and this is how it's getting its internet access. Therefore, it is the only device in your network that has direct access to the resource, and none of your computers, none of the computers connected to the network can access the resource or can access the internet without the router, without the access point. So the only way for all of the connected clients to access the resource is to go through the router. Now, the data is transferred between the clients and the access point as packets. So you can think of all of these arrows as a series of packets being transmitted between the client and the router as requests and responses. Now, in Wi-Fi networks, these packets are transmitted in the air. Therefore, if you have a wireless card and you're within range, you'll be able to capture all of these requests and responses. So basically, you'll be able to see anything that any computer connected to the same network as you does on the internet. Because they will have to send all of this data to the access point, and because they're sending this data in the air because you're in a Wi-Fi network, you'll basically be able to capture these requests and responses, and you'll be able to see the URLs they visit, the usernames, the passwords they enter, the chat messages, anything they do on the internet will be sent as packets, and therefore you'll be able to capture it and analyze it. We'll talk more about that and more about how networks work as we go through the course. But this is enough to get you going through the next few lectures so that you can sniff data, analyze it, and start launching some cool pre-connection attacks. In this lecture, I'm going to show you how to connect a USB device to a virtual machine. As an example, I'm going to be connecting a wireless adapter to my Kali machine. But the same method can be used to connect any USB device. Now, as mentioned in the course requirements, you need a wireless adapter for the cracking section of this course. So these are the lectures where we're going to show you how to crack the passwords for Wi-Fi networks. Other than that, you can do everything else in the course without a wireless adapter. What I mean by a wireless adapter is a USB device that connects through USB to your computer, and it allows you to communicate with wireless networks. Now, most computers and laptops come with a built-in wireless card. The only problem is, first of all, you can't access built-in wireless cards from a virtual machine. Also, even if you can, so even if you install Kali as a main machine, the built-in wireless cards are not good for hacking because we need a powerful adapter that supports monitor mode and packet injection. And we're going to go into what each of these mean. But basically, the built-in wireless adapter does not support these modes and can't be used for hacking. That's why I recommend powerful wireless adapters. They're listed in the course requirements, and I'm going to list them in the resources of this lecture, and you can connect them to Kali like I'm going to show you right now. So I already have VirtualBox open, and you just want to click the machine that you want to connect the adapter to. We're going to go to its settings. We're going to go to ports. We're going to go to USB and make sure that USB is enabled. And you want to pick the USB option that is used by your adapter. So it's either USB 1, 2, or 3. And for the adapter that I have, it uses USB 2. Then you want to come here to the plus sign and click on it. Now you'll see that I have a number of devices that I can attach to the Kali machine. Now I still haven't connected the adapter. So first of all, I'm just going to have a look on the available devices. Then I'm going to connect the adapter. And I'm going to list the devices again. I did that because we're assuming that I don't know the name of my adapter, because the name that you'll see here is the name of the chipset that's used inside the adapter. So it's not the brand name that you see on the adapter itself. So when I click on it now, you'll see that I have a new entry called Atheros, and this is actually my wireless adapter. It's an Alpha AWS 036NHA. So I'm going to click on it. That's it added here. I'm going to click on OK. And that's the adapter added to Kali. Now, before starting my virtual machine, I'm going to physically disconnect my wireless adapter. And then I'm going to connect the adapter once Kali fully loads. Now I'm going to start it. So I'm going to put my username, which is root, and my password, which is TOOR. Okay, now Kali is fully loaded. I'm going to go and physically connect my wireless adapter. And like I said, I usually do this just to avoid any conflicts. Now, once the adapter is connected, you want to make sure that it's attached to Kali. And to do that, we're going to go to the devices menu. So we're going to go all the way to the top. We're going to go to devices. We're going to go on USB. And we're going to make sure that this adapter right here is checked. Now, sometimes it might not be checked for you, so click on it to check it. For me, it's already checked, so I'm not going to click it. And to confirm that the adapter is connected, we can just go on terminal right here and type ifconfig. This command lists all the interfaces that's connected to the machine. And as you can see now, it's showing an adapter called LAN 0, which is the wireless adapter. So if you have this in here, that means your adapter is connected. If you don't, then ask in the discussions and I'll help you through this. Some adapters are not compatible with Kali, so that could be the issue, or the issue could be something else. Also, now if we go here on the top right, you'll see that I have a Wi-Fi option, which I can use to connect to Wi-Fi networks. Now, we don't need to do this because I showed you how to set up a NAT network, and Kali already has internet access through this NAT network. So we only need the wireless adapter to hack into other networks to crack their passwords. When it comes to networking, you probably heard of the term MAC address a lot. So in this lecture, I'm going to cover what do we mean by MAC address, what it's used for, and how to change it. MAC address stands for Media Access Control. It's a permanent, physical, and unique address assigned to network interfaces by the device manufacturer. So whether you have a wireless card or a wired or Ethernet card, each one of these network cards come with a specific address that is unique to this card. So there is no two devices in the world that would have the same MAC address. And this address will always be the same to this specific device. Even if you unplug it from your computer, connect it to another computer, then this network device will always have the same address. So you might already know that the IP address is used in the internet to identify computers and communicate between devices on the internet. The MAC address is used within the network to identify devices and transfer data between devices. So each piece of data or packet that is sent within the network contains a source MAC and a destination MAC. Therefore, this packet would flow from the source MAC to the destination MAC. So, because this is a physical unique address to each interface, to each network device, and because it is used to identify devices, then changing it will make you anonymous on the network. Not only that, but the MAC address is often used by filters to prevent or allow devices to connect to networks and do specific tasks on the network. So being able to change your MAC address to another device's MAC address will allow you to impersonate this device and allow you to do things that you might not be able to do. So you'd be able to bypass filters or connect to networks that only specific devices with specific MAC addresses can connect to, and you will also be able to hide your identity. Now, changing the MAC address is very simple. So let me show you how to do that. First of all, I'm going to use the ifconfig command to list all the network interfaces available on my Kali machine. What I mean by network interface is any device that allows us to connect to a network. So an example is a Wi-Fi card or an Ethernet card and so on. So you can see, first of all, we have ETH0, and this is a virtual interface created by VirtualBox when we set Kali to use a NAT network. So you can see the interface name is ETH0. You can see it has an IP address because, like I said, it's connected to a network. So if we go here, we can see it's saying wired connected. So this is the interface that represents the wired network that Kali is connected to, which is actually a virtual NAT network. You can also see the net mask, the broadcast, and a really important piece of information, which is the other. This is the MAC address of this virtual interface. Now you can see similar information for my other two interfaces, the LO and the LAN 0. The only thing is, you can see for both of these interfaces, we do not have an IP address. And the main reason for that is because none of these interfaces is connected to a network. Now LO is a default interface created by Linux, and LAN 0 is my real wireless adapter, so I can use it to connect to Wi-Fi networks. But if I go on the network in here, you'll see Wi-Fi is not connected because I actually didn't connect to any network, and that's why it does not have an IP address. Now this doesn't matter because what we want to do is to just change the MAC address, which again is shown here under the other part. So similar to what you're seeing here for ETH0. Now, in order to change any of the values that you see in here, you have to first disable the interface. So in this example, we want to change the MAC address. So that is represented by the other, and the value is right here. So in order to disable an interface, we're going to do ifconfig followed by the interface name, which is LAN 0 in my example, followed by down to disable it. Now, if I hit enter, you'll see the command runs with no errors, so it means that it got executed properly. And the next thing that we need to do is to change the option that we want to change. And in this example, we want to change the other, which is the MAC address. So first we're going to type ifconfig. We're going to type the interface that we want to change one of its options. Then we're going to type the option that we want to change. And what we want to change is the hardware address. So we're going to do HW ether. Then we're going to give it the address that we want to change the MAC address to. So for example, I'm going to use 001122334455. Very simple command. We're doing ifconfig LAN 0 to select the interface that we want to change its option. We want to set the hardware address, and we want to set this address to this specific address. So you can use any address that you want following the same format shown here. Just make sure your address starts with 00. So I'm going to hit enter, and again, we don't see any error messages, so it means the command got executed properly. And finally, we just need to enable the interface because we disabled it by doing ifconfig LAN 0 down. So we just need to do ifconfig LAN 0 up to enable it. Now the interface is enabled, and if we do ifconfig again, and look at the other part in here, you can see that it is changed to the MAC address that we specified. Now this is done and your MAC address is changed. Now you can go ahead and start using the interface, and it will appear to have this MAC address instead of its original MAC address. And like I said, this can be useful in so many scenarios. Now keep in mind, the MAC address will revert back to the original one once you restart the computer, because we're only changing the MAC address in memory. We're not really changing the physical MAC address. But if your MAC address is resetting to the original one without restarting, then something is going wrong, and it's probably happening because your network manager is resetting the MAC address. Not everybody will face this issue, so I'm not going to cover it in this lecture. But if you face this issue, if your MAC address goes back to the original one without restarting the computer, then check out the YouTube video in the resources of this lecture. It will show you how to fix this issue. From the previous lectures, we learned the basics of how networks work. We learned that devices on the same network communicate with each other using packets. So regardless of what you do on the network, whether you're watching a video, whether you're logging into a website, sending chat messages, sending emails, regardless of what you're doing, all the data is sent as packets. Now in the network, devices ensure that these packets go in the right direction using the MAC address. So each packet has a source MAC and a destination MAC, and it flows from the source to the destination. So in this example, we have the client, it has this MAC, we have the access point, which has this MAC. And as an example, if this client wanted to send a packet to the router, it will set the destination MAC to the router's MAC address. Therefore, by default, each device only receives data that has the destination MAC as its own MAC address. But if you remember, I said in wireless networks, if you're within range, then you'll be able to capture all of this communication because these packets are literally sent in the air. So we can just capture them even if they do not have our MAC address as the destination MAC. To do this, we need to change the mode of operation of our wireless interface so that it operates in monitor mode. So let me show you what I mean. if I go to my computer here and run iwconfig this time, so we see an ifconfig which lists all the interfaces, we can use iwconfig to see the wireless interfaces only. And you can see we have LAN 0 right here, which is my external wireless adapter. And you can see the mode of this adapter is set to managed. What this means is basically this is the default mode of all wireless devices, and what it means is this device will only capture packets that has the destination MAC as the MAC address of this device. So basically it will only capture devices that are directed to my Kali machine. But this is not what we want. What we want is to be able to capture all the packets that are within our range, even if they are sent to the router and even if they are set to another device. So to do this, we need to set the mode to monitor mode instead of managed mode. So as usual, before you can change the options of your interface, you have to disable it. And previously we've seen we can do that by doing ifconfig, the device name, which is LAN 0 in my case, down. Then we can enable monitor mode. But before we do that, I'm actually going to run a command to kill any process that could interfere with using my interface in monitor mode. So the command that I'm going to run right now is not mandatory, but running it will actually give you better results when you come to running the attacks that you will learn as we go in the course. So this command is going to be airmon-ng check kill. Now you'll notice when you run this command, it'll actually kill the network manager that usually runs in here. So you'll completely lose your internet connection. But this is no problem because we will only need to be in monitor mode when we are running pre-connection attacks. So attacks that do not require us to connect to any network. So we actually do not need internet connection to run any of the attacks that require monitor mode. Now we're going to enable monitor mode. So we're going to do iwconfig, followed by the interface name that we want to enable monitor mode on, which is LAN 0. We're going to say that I want to change the mode, and I want to change that to monitor. So very, very simple command. We're using iwconfig to change the mode. We're given the name of the interface that we want to change its mode. We're saying I want to change the mode and I want to set it to monitor mode. Now if I hit enter, you'll see the command will run with no errors, which means the command got executed properly. And finally, we'll need to enable the interface, again, similar to what we did when we changed the MAC address. So we just have to do ifconfig LAN 0 up. That's done. Now, if I run iwconfig again, you will see that the mode is set to monitor now. So basically, this interface now can be used to capture any packet that is within our range, not only the packets that are directed to this computer. That's why in the future you'll see how we can use it to sniff packets, to analyze them, and even break into networks. So in the future, if I say use your interface in monitor mode, this is what I mean. You'll basically have to enable monitor mode as shown in here. Now, I've also included a YouTube video in the resources of this lecture to show an alternative method to enable monitor mode. Just in case you got errors with this method or you tried to follow something that I do in the next lectures and it didn't work, then you can come back and try the alternative method. But if this worked and if monitor mode is enabled successfully, then you don't need to watch that video. You can just continue with the course. One more thing to keep in mind, not all wireless adapters support monitor mode. So for this to work, you need to make sure that your actual adapter supports monitor mode. There are a number of adapters that support that, and I've included another video, again in the resources, of me talking about wireless adapters, how to pick the best one, and which ones that I recommend and use when I'm testing the security of networks. Now that we have enabled monitor mode on our wireless interface, we are able to capture all the Wi-Fi packets sent within our range. Even if the packet is not directed to our computer, even if we're not connected to the target network, and even without knowing the key or the password to the target network. So all we need right now is a program that can capture these packets for us. The program that we're going to use is called AeroDump-NG. It's part of the AirCrack-NG suite, and it's a packet sniffer, so it's basically a program designed to capture packets while you're in monitor mode. So it'll allow us to see all the wireless networks around us and show us detailed information about its MAC address, its channel, its encryption, the clients connected to this network, and so on. So let me show you how we're going to use it. First of all, you need to enable monitor mode on your wireless adapter as shown in the previous lectures. So, if I go to my Kali machine and run iwconfig to list all the wireless devices on this computer, you'll see that I have an interface called Mon0, and this interface is in monitor mode. Now, depending on the way that you enabled monitor mode, this can be called LAN 0, it can be called LAN 0 Mon, it doesn't really matter. You just want to make sure you enable monitor mode using one of the methods shown before, and then use the name of the adapter that is in monitor mode when you run AeroDump-NG. Now, to run AeroDump-NG, we're just going to type the name of the program, which is AeroDump-NG, followed by the name of my wireless adapter in monitor mode, which is Mon0, as you can see in here. So the command is very simple. We're typing the program name, which is AeroDump-NG, followed by the name of my interface in monitor mode. If I hit enter, you'll see it'll start working, discovering all the wireless networks around me and displaying useful information about them. This program will continue working unless you quit it, and to quit this program, you have to press Ctrl-C from your keyboard. You can actually use Ctrl-C to quit any running program in your terminal. Now that we stopped the program, let's analyze the output so we understand what it's showing us. So first of all, if we look at this column, the ESSID column, it should be a little bit familiar to you. And basically, this shows us the names of the wireless networks around us. So if I just go to my Mac machine and look for wireless networks, you'll see the same names that we see in here displayed under the ESSID. Now, all of the other columns show us more information about the network name that you see in here, and this information will actually be very useful to us as we go through the course. The first column, the BSSID, shows us the MAC address of the target network. Next, we have the PWR, so this is the signal strength or the power of the network. Now, the higher the number, the better signal we have. So, for example, the network with the best signal right here is this one. Next, we have the beacons. These are frames sent by the network in order to broadcast its existence. So every network, even if it's set to be hidden, always sends these type of frames, basically broadcasting its existence and telling all the wireless devices around it that I exist, I have this BSSID, I work on this channel, I use this encryption, and my name is this. Next, we have the number of data packets or data frames, and these are the useful packets that we'll talk about later on once we get to the cracking section. This column represents the number of data packets that we collected in the past 10 seconds. Next, we have the channel, which is the channel that the network works on. So for example, this network right here, the test AP, works on channel 6. This network works on channel 1, and so on. Next, we have the maximum speed supported by the network. The encryption is a very important column, and it shows us the encryption used by the network. So we can see that the test AP network is using WPA. We can see we have a network that uses web. We can see this network right here is an open network, so it doesn't use encryption. We don't even need a password to connect to it. And we can see we have a WPA2 network right here. Cipher is the cipher used in the network. So we can see here we have CCMP, we have web, and we have CCMP again here. Auth is the authentication used on that network. And in here we can see it's PSK, pre-shared key, and MGT for this network. Now don't worry about the INC, the cipher, and the auth. We will talk about breaking into all these networks into web, WPA, and WPA2 in the gaining access section. And finally, you can see we have the ESSID section, which shows the name of the network. So this is what you see when you look for networks in your network manager. So that's it for this lecture. I just wanted to give you a quick look on how to discover all the networks around us using AeroDumpNG. Don't worry about AeroDumpNG too much now. We're going to be using it a lot in the next lectures, and you'll get very comfortable with using it as we go through the course. In this lecture, I'd like to talk about Wi-Fi bands. The band of a network defines what frequency it can use to broadcast the signal. This means it also defines the frequency that the clients or the computers need to be able to support and use in order to be able to connect to this network. The two main frequencies used in Wi-Fi networks are 2.4 and 5 GHz. Now, previously, when we used AeroDumpNG, we were only sniffing on the 2.4 GHz frequency. You can see, first of all, my wireless adapter is in monitor mode, Mon0 in here. So if I just do AeroDumpNG Mon0, you'll see that I can get the wireless networks around me. But you might have noticed that you won't actually see all the networks around you when you run AeroDumpNG. I'm going to Control-C this, and if I go here to my normal host machine, and it actually has a built-in wireless adapter, so it's not as strong as my alpha adapter. But if I look for networks, you'll see I actually have much more networks in here. And mainly, I have networks ending here in the name by 5G. Now, the network doesn't have to necessarily end in 5G, but here in Ireland, if a network broadcasts over 5 GHz, the service provider adds 5G to the network name. But we also have other networks broadcasting over 5G that don't end in 5G. But basically the main point that I want to talk about is I'm not able to see all the networks around me in here in AeroDumpNG. And the reason for this is because AeroDumpNG is only sniffing on 2.4 GHz frequency. So if you do this and you don't see all the networks around you, or if you're sniffing on your own network, but you don't see all the clients in your network, it's possible that your router is broadcasting over two bands, over 2.4 and 5 GHz. And if you're not seeing the router at all, if you're not seeing the network at all, like what's happening here for me, then the router is probably just broadcasting over 5 GHz. Now, this doesn't mean that your wireless adapter is not good. It just literally means that this adapter is not able to see 5 GHz frequency. It's just outside of its limit, outside of its reach. The main problem with 5 GHz is that there are a lot of wireless adapters that can see it and can communicate with it, but not many of them support monitor mode and packet injection. So you might see me and other people recommending wireless adapters like Alpha AWUS 036NHA. This is my most favorite wireless adapter. I use it all the time, even now. But the problem with that adapter is it doesn't pick up 5 GHz frequency. So it doesn't mean that that adapter is bad. It just means that it can't see 5 GHz frequency. Like I said, there aren't many wireless adapters that support 5 GHz, but I have an adapter here. It's Alpha AWUS036ACH, and this adapter supports both 2.4 GHz and 5 GHz frequencies. It's not as good as the Alpha, but it does the job. Now, if you want more information about wireless adapters, check out the link in the resources. I'm not going to talk a lot about what wireless adapters do, but in this lecture, I want to show you how to sniff and discover 5 GHz frequency networks, and then so that you can use all the attacks that you've learned in my other lecture and in my previous videos with 5 GHz networks. So, the adapter that I'm using right now supports 5 GHz, but as you can see, I still can't pick up these networks. That's because I need to specifically tell AeroDump-NG that I want you to listen on 5 GHz frequencies and 5 GHz channels. To do that, all we have to do is just do AeroDump-NG, like we always do. And then we're going to use a new argument that we haven't seen before, and this argument is called band. And we're going to tell it that I want you to sniff on band A, and that's the band that supports 5 GHz frequency. And then I'm just going to give it the name of my wireless adapter in monitor mode, which is Mon0. So the command is very simple. It's very similar to what we've used before. And all we have to do is just type in AeroDump-NG, followed by the band. And the band that we want to use is A. And we're following that with our wireless interface. So I'm going to hit enter. And as you can see, as soon as we hit this, I'm actually just going to do Control-C now because you can see the results. You can see that we got much more networks right now, and we have the 5 GHz network. So we have this network and this network that we weren't able to see. We have the Jameson Whiskey network as well. And basically we're able to capture all the networks that use the 5 GHz frequency. Now what you can also do, let me clear the screen. You can specify multiple bands using the band argument. So again, using the same command, instead of just saying band A, we can do band A, B, G. And what this will do is it'll tell AeroDump-NG to capture data on both 2.4 and 5 GHz frequencies at the same time. So let me show you. So as you can see right here, we're capturing some 2.4 GHz networks and we're capturing 5 GHz networks as well at the same time. And we'll also be able to discover clients connecting to both bands. The only problem with using AeroDump like this is, first of all, you need a powerful wireless adapter to do this. Also, it'll be slightly slower than only sniffing on one band, because when you're sniffing on two bands, you have a lot of channels that AeroDump-NG has to hop on all of them and discover clients and networks broadcasting on these channels. So, if you want quicker results, then you're better off just specifying the band A when you want to sniff on 5 GHz frequencies and just not specify the band when sniffing on 2.4. But as you can see, you can just run the command like so with band ABG, and this way you'll be able to capture data sent over 2.4 and 5 GHz frequencies. Also keep in mind, in order to sniff data on 5 GHz frequency, like I said, your wireless adapter needs to be able to support this band. So simply adding the band argument will not work unless your wireless adapter can support and can sniff data on this band. One more thing that I want to note, I've actually said this before. If you run AeroDump-NG against a network and you see some devices missing, then there is a high chance that these devices are connected over 5 GHz. So again, use the band A and then you should be able to see these devices. In the last lecture, we've seen how to use AeroDumpNG to list all the networks around us and display useful information about them. Usually, we do this in order to see our target network, see the signal strength, see how far we are from it, and then start targeting this target network. Now, in this example, I'm going to assume that my target network is this one right here. This is actually the network that my host machine is connected to. And now that I have my target network and I have some basic information about it, let's see how we can run AeroDumpNG against this network only, not against all networks. And this way, we'll be able to gather more information about it. So, to do this, first of all, I'm going to have to write the name of my program, which is AeroDumpNG. Then I'm going to specify a specific BSS ID or a specific MAC address for AeroDumpNG to sniff data from. So my target network has a BSS ID of this. We can see it here under the BSS ID. So I'm going to copy it. And then I'm going to do --BSS ID. And I'm going to give it the BSS ID that I just copied. Next, I'm going to specify a channel for AeroDumpNG to sniff on. Again, if we look under the channel column in here, we can see my target network is on channel 2. So I'm going to do --channel 2. So now we're telling AeroDumpNG that I want you to sniff data on channel 2 and only from a network that has this BSS ID. I'm also going to tell AeroDumpNG that I want you to store all the data that you're gonna gather for me in a file. So I'm gonna say --write, and then I'm gonna type a file name, and let's call this test. And at the end, as usual, I need to give it the name of my wireless adapter in monitor mode, which is Mon0 in my case. So, very simple command. Let's go over it one more time. We're doing AeroDumpNG. That's the name of the program that I want to use. I'm telling it that I only want you to sniff data from a specific BSS ID. Then I'm giving it the BSS ID of my target. Then I'm telling it I want you to only sniff data from a specific channel. And I'm giving it the channel that I wanted to sniff data from. Again, we can get it from here. It's number 2. Finally, I'm telling it that I want you to write all the data that you're going to capture in a file that we're going to call it test. And then I'm giving it my wireless adapter in monitor mode, which is Mon0. Now I'm going to hit enter. And as you can see, unlike the last time, AeroDumpNG is only showing me one network in here. This is the network that I wanted it to sniff data on. And we can also see we have a completely new section right now. So when I ran AeroDumpNG in the previous lecture, you seen I only had the networks in here and I had nothing here at the bottom. But now you can see we have more entries in here at the second section of AeroDumpNG. And basically anything that you see here in the second section, these are the clients or the devices connected to this network. So right now we can see this network has 3 devices connected to it, and you can see the MAC addresses of these devices under the station. So you can see all of these devices are connected to the same network. So the BSS ID is still the same. This is the MAC address of the network. And under the station, we have the different clients or different devices connected to this network. We can also see the power. So this is the signal strength of each of these devices. We can see the speed, we can see the amount of data lost, we can see the amount of frames or packets that we have captured, and we can see if any of these devices are still probing for networks. So sometimes when you run AeroDumpNG against all networks, you'd still see this section and you'd see that some devices are not connected and they're literally trying or looking for networks. So you'd see the name of the networks that they're looking for under the probe. Now, if I hit Control-C, AeroDumpNG will quit, it'll stop working, but I should have new files in my current working directory that contain the data that we just captured. Because remember, when we ran the command, we used the right option in here to store the data in a file called test. So if I just do ls to list all the files in my current working directory, you can see I have 4 files. All of them start with test, but they all have different extensions. So we have a CSV, we have a netXML, we have a CAP, and we have a Kismet CSV. Now also notice that AeroDumpNG automatically appended -01 to each of these files. So in the future, when you go and try to use the capture file, make sure you append -01 to the file name that you specify in the command. Now, the main file that we're going to be using is the cap file. Again, this file contains the data that we captured during the period that AeroDumpNG was working on in here. And basically, this file should contain everything that was sent to and from my target network. So it should contain URLs, chat messages, usernames, passwords, or anything that any of these devices did on the internet. Because anything that they have to do will have to be sent to the router, as we've seen before. The only problem is, if you look at the encryption in here, you can see that my target network uses WPA2 encryption. So all of the data sent between the router and the clients is encrypted. So let me show you what I mean. I'm going to use a tool called Wireshark to analyze the data. And don't worry about how to use Wireshark. We will talk about it in details later on. Right now, I just want to make sure that you understand the idea that now we're able to capture all these packets. The only problem is these packets are encrypted. So I'm going to do Wireshark to run Wireshark. And then I'm going to open my capture file. So I'm going to go to File, Open, and it's already in my root directory. So I'm just going to scroll down and select my test1 cap. I'm going to open it, and I'll just put this in full screen. And as you can see, if we click on any of these packets, you can see we really have no useful data. You can see everything looks like gibberish, and we can't read anything, even though these packets might contain usernames, passwords, or URLs. The only useful thing that we can see here is the device manufacturer. So we know one of the devices connected to the network that has this specific MAC address. So it's the one that ends with E8. And if we go up, we can see that it's this specific device. We know now it is an Apple device. So it could be an Apple computer, it could be an iPhone or an iPad. And this is actually my MacBook computer that is the host machine. Again, we can see we also have a device that's using a Huawei chipset. So this can be a phone, or it could be the router. And if you look at the MAC address here and compare it to the MAC addresses that we have here, you can see that this is actually under the BSSID. So this is the MAC address of the router. So now we know that the brand of my router is Huawei. So we can gather more information by opening this file in Wireshark, and we can kind of guess what computers are there and what operating systems they use. But this is not detailed enough. And the main problem with this is the fact that the network is using encryption. Now, in the next section, we're going to be talking about how to break this encryption. And once we do, you'll see how we can see the passwords, the usernames in plain text. And you'll also see how we can map all of the computers on the same network, gather detailed information about them, hack into them, and do some really, really cool stuff. Now, you should guess by everything that I said so far, if this network was an open network, if it was a network that does not use any passwords, then you would have been able to actually see all the URLs and everything that they do in here. But again, if you can't connect to the network without a password, then you'll automatically be at the post connection section. And in that section, like I said, we're going to talk about some really cool attacks that you can do once you have the password or once you can connect to the network. So don't worry about Wireshark for now. I just wanted to make sure that you understand why encryption is useful and why it's used and why we can't see much now because we don't know the key. We will talk about Wireshark and all of that later on in the next section. Now, before leaving this section and moving to the gaining access section, where I'm going to teach you how to break the different encryptions and gain access to networks, I want to spend one more lecture talking about a really useful attack that still falls under the pre-connection attacks under this section. The attack that I want to talk about is the deauthentication attack. This attack allows us to disconnect any device from any network before connecting to any of these networks and without the need to know the password for the network. To do this, we're going to pretend to be the client that we want to disconnect by changing our MAC address to the MAC address of that client and tell the router that I want to disconnect from you. Then we're going to pretend to be the router, again by changing our MAC address to the router's MAC address, and tell the client that you requested to be disconnected, so I'm going to disconnect you. This will allow us to successfully disconnect or deauthenticate any client from any network. Now, we're actually not going to do this manually. We're going to use a tool called AirPlay-NG to do that. From the previous lecture, we know that this MAC address right here belongs to an Apple computer. And like I said, this Apple computer is actually my computer right here. And as you can see, this host machine is connected to this network right here, which is the same as the one that you see in here. And it actually has internet access. So if I just look for test, you'll see that I'm connected and I can look for things. I can use Google. So I have a proper working internet connection. Now, we're going to come back here and we're going to use a tool called AirPlay-NG to launch the deauthentication attack and disconnect this Mac computer from the internet. So we're going to type the name of the program, which is AirPlay-NG. We're going to tell it that I want to run a deauthentication attack. Then I'm going to give it the number of deauthentication packets that I want to send. So I'm going to give it a really large number so that it keeps sending these packets to both the router and the target device. Therefore, I'll disconnect my target device for a very long period of time. And the only way to get it back to connect is to hit Ctrl+C and quit AirPlay-NG. Next, I'm going to give AirPlay-NG the MAC address of my target network. So I'm going to do -A and give it the MAC address, which I'm going to copy from here. Then I'm going to use -C to give it the MAC address of the client that I want to disconnect. And the client that I want to disconnect is this client right here, which is the Apple computer, like we said. So I'm going to copy it and paste it here. And finally, I'm going to give it the name of my wireless adapter in monitor mode. And in my case, it's called Mon0. So a very, very simple command. We're typing AirPlay-NG. This is the name of the program that we're going to use. We're doing --deauth to tell AirPlay-NG that I want to run a deauthentication attack. I'm giving it a really large number of packets so that it keeps sending the deauthentication packets to both the router and the client and keep the client disconnected. I'm using -A to specify the MAC address of the target router or the target access point. Then I'm using -C to specify the MAC address of the client. Finally, I'm giving it Mon0, which is the name of my wireless adapter in monitor mode. Now you can run this command like this, and in most cases it would work. But in very rare cases, this command will fail unless aerodump-ng is running against the target network. So what I'm going to do now is I'm going to go back to my first terminal in here, and I'm going to run aerodump-ng using the command that we've seen before. And I don't want to write anything to a file, so I'm going to remove the write argument. So I'm just doing a normal aerodump-ng command. I'm literally just giving it the BSS ID of my target network, and I'm giving it the target channel. And then I'm just going to hit enter. We've seen how to do this. We spent a full lecture on it. That's why I did it really quick. And then I'm going to go back to the command that we wrote so far, and I'm going to hit enter. Now, as you can see, airplay-ng, it's telling me that it's sending the deauthentication packets. And if we go back here and look up, you can see that I actually lost my connection and I'm trying to connect back. So obviously, if I try to look for anything, so let's say test2, you'll see I'll get stuck and nothing will load for me. So the only way for me to connect back is if I go back here, if I quit this by doing Ctrl+C, quit this again, and now my machine should be able to connect back and restore its connection. This is actually very handy in so many ways. It's very useful in social engineering cases where you could disconnect clients from the target network and then call the user and pretend to be a person from the IT department and ask them to install a virus or a backdoor, telling them that this would fix their issue. You could also create another fake access point and get them to connect to the fake access point and then start spying on them from that access point. And we'll see how to do that later on in the course. And you can also use this to capture the handshake, which is what happened in here actually. And this is vital when it comes to WPA cracking. And we'll talk about this once we get to the WPA cracking section. So, like I said, this is a small attack that can be used as a plugin to other attacks or to make other attacks possible. Everything we've done so far can be done without the need to connect to the target network. Now, once we connect to the network, we can do so many cool things. We'll be able to gather so much more info. We'll be able to intercept the connections and see everything that the people send, whether it's usernames, passwords, URLs, or anything really. We'll also be able to modify the data, and you'll see all of this in the next section of this course. Now, if your target does not use encryption, then you can just connect to it. If your target is a wired network, then you can just use a cable and connect to it and move to the next section. The only problem is if your target is using encryption. So, in this section, I'm going to show you how to break that encryption and gain access to Wi-Fi networks, whether they use WEP, WPA, or WPA2. Once we get the key, we'll be able to connect to the network and you'll be able to do all of the things that you'll learn in the next section, in the post-connection section. The first encryption that we'll learn how to break is called WEP, or Wired Equivalent Privacy. This is an old encryption that can be easily broken. The reason why I'm still covering it in this course is, first of all, because, like I said, it's very simple, so it's a good starting point. Also, it's still used sometimes in some networks. Therefore, you can't really call yourself a hacker, and then if you see a network that uses web, you'll get stuck and you won't even be able to break into it. So, in this lecture, I'm going to explain how web works and what's the weakness that we can use to break it. And in the next lecture, you'll see how we can use this weakness in order to break web and get the key for any network that uses WEP. So basically, WEP uses an algorithm called RC4 to encrypt its data. So the way this works is basically, if a client wants to send something to the router, and let's say it wants to send this text data to send to the router, it'll first encrypt this using a key. Therefore, this normal text will be converted into gibberish, as you can see here. This encrypted packet will be sent into the air. So if a hacker captures this packet, as we've seen before, if we open this packet, we'll see that it's full of gibberish. Even though it actually contains useful information, we won't be able to read it because it's encrypted. The access point will receive this encrypted packet and it'll be able to transform it back to its original form because it has the key. Therefore, it'll actually be able to read the contents, which is data to send to the router. The same happens if the router wants to send something back to the client. It'll first encrypt it using a key, send it to the client. The client will be able to decrypt it because it has the key. So the concept is always the same. The transmitter encrypts the data using a key, sends it to the receiver. The receiver is able to decrypt it because it also has the key. Therefore, anybody who captures the packet in the middle, they will get the packet, but they won't be able to see the contents because they do not have the key. So the algorithm and the way RC4 works is actually fine. The problem is with the way that WEP implements this algorithm. And to understand this, let's zoom in a little bit more on each step. So going back to the first step, we have the client trying to send data to the router, and the data that it wants to send is data to send to the router. So, in order to encrypt this, WEP tries to generate a unique key for each packet. So literally each packet that's sent into the air, it tries to create a new unique key for it. To do that, it generates a random 24-bit initialization vector. The initialization vector is then added to the password of the network, to the actual key that people use to connect to the network. This generates a key stream, and then this key stream is used to encrypt this packet and transform it into gibberish. So basically we have the key stream plus the data that we need to encrypt gives us the gibberish, and then the gibberish is sent into the air. But before sending this into the air, WEP will also append the initialization vector. This is the 24-bit random number that I said it creates in order to make sure that each packet has a unique key. The reason why it adds the initialization vector to the packet is because once the router receives this packet, it needs to be able to decrypt it. And to decrypt it, it needs the key and the IV. But the router already has the key, so there is no need to send that. Therefore, we just need to send it the IV. So, when the router receives the packet, it has the IV, it has the password or the key, so it can generate a key stream and then use that key stream to transform this gibberish into its original form and read the packet. So, if you think about what I said, you can probably guess what the weakness is. Basically, the IV is sent in plain text. So if you look at this, you can see the packet content is encrypted. So if someone captures this packet, they won't be able to read this, but they will be able to read the IV in plain text. Also, the size of the IV is only 24 bits. Now, considering the huge amount of traffic that can be generated on a Wi-Fi network, this number is not big enough, and the IVs will start getting repeated in a busy network. This makes WEP vulnerable to statistical attacks, so we can use a tool called AirCrackNG to determine the key stream once we have enough repeated IVs, and from that it will also be able to crack WEP and give us the key to the network. So from the previous lecture, we know in order to crack WEP, we need to first capture a large number of packets. This means that we'll capture a large number of IVs. The IVs, because they are short, they will be repeated. Therefore, we'll be able to use a tool called AirCrackNG to run statistical attacks and crack the web key. So we're using AeroDumpNG to capture the data, and we've seen how to do this before. Then we're using AirCrackNG to analyze this data and break the key. Let's see how to do this in practice. So I already have my wireless adapter in monitor mode, and it's called Mon0. I've also already run AeroDumpNG to list all the networks around me. And as you can see, I have only one network using WEP. This is called Test AP3. And this is my actual network that I use every day. I've just configured it to use web to make this lecture. The main reason why I'm targeting the network that I use daily, because like I said, for this to work, we need to capture a large number of packets, and therefore we need a busy network, a network that gets used constantly to capture a large number of packets. If the network is idle, then the process is a little bit complex, and I will cover that in the next lecture. So for now, let's focus on the simplest form, which is how to break into a busy network. So I'm going to copy the BSS ID of this network, and I'm going to run AeroDumpNG against this network only. So I showed you how to do this before. I'm going to do AeroDumpNG. I'm going to do --BSS ID to specify the BSS ID of the network. Then I'm going to do --channel to specify the channel of the network, and we can see it's running on number 1. And I'm going to do --write to store everything that we capture into a file, and let's call this file basic web. And then I'm going to specify my wireless adapter in monitor mode, which is Mon0. So we ran this command before in the targeted sniffing lecture. All we're doing is we're running AeroDumpNG against a specific network with this MAC address, with this channel, and we're storing everything in a file called basic web. I'm gonna hit enter, and as you can see, AeroDumpNG is working against my target network. And if you notice, you'll see the data in here is increasing really fast. So this is something that I told you I'll talk about it later when we were talking about AeroDumpNG, because I didn't want to talk about IVs at that early stage. So basically what you see under the data column is the number of useful packets that contain a different IV that we can use in order to crack the key. So the higher this number is, the more likely we will be able to crack the key. As you can see, this number is increasing very fast because, like I said, this is a busy network that is being used at the moment by my own computers and my own devices. If yours isn't increasing fast, then don't worry, we will tackle this problem in the next lectures. So for now, we're capturing a lot of data, and this should actually be enough to crack the key. So what I'm going to do, I'm going to go down to my other terminal in here, and if we actually list the files, you'll see that we have the capture file that we specified in the right argument. And like I said, we're always interested in the .cap file. So all we have to do right now is do step 2 in here, run AirCrackNG against the file that we captured in order to crack the key. So I'm going to do AirCrackNG, followed by the file name, which is basicweb01.cap. I'm going to hit enter. And as you can see, it's telling us that the key is found. So let me cancel this here. And right now, we can connect to the target network, which is called Test AP3, using this ASCII password. So you can literally just copy this and paste it, or you can connect using this key. Now, in some cases, you will not see this ASCII password. That's why I'm going to show you how to connect using this key right here, because you'll always get this. So I'm going to copy this, and I'm just going to paste it here. You can paste it anywhere in a normal text editor or anywhere you want. And all you have to do is remove the columns that we see in here between the numbers. So I'm going to remove this one, going to remove this one, and this. And now we can just copy this. And just to show you, I'm actually going to connect from my host machine. You can connect from Kali, but when we enabled monitor mode, we killed a lot of processes, and sometimes even after you restart these processes, getting connected to your target will be a little bit buggy. So it's best to literally just restart Kali and connect again. So just to save all of this time, I'm going to connect from here. I'm just going to click here. I'm going to connect to test AP3, and I'm going to paste the password. So I'm just going to click on show the password to show it to you. Again, the same password. We just removed the colons. I'm going to click on join. And as you can see, we managed to connect. And we can test this connection by going to Google. And perfect. As you can see, it's working. And we managed to break the WEP encryption. In the previous lecture, we seen how easy it is to crack WEP. All we had to do is capture enough data and then run aircrackng to crack the encryption and give me the key. Now, one problem that we could face is if the network is not busy. If it's not busy, then the number of data will be increasing very, very slowly. Therefore, we're going to have to wait for a while before we have enough data to crack the key. So let me show you an example. I'm just going to run aerodumpng here and list all the networks around me. And you can see I have my test network, my test AP in here. It's using web. And if you look under the data, you'll see that it's at 0 and it's not increasing. And even if it's going to increase very, very slowly. Which means that I'm going to have to be waiting for hours before I can crack this network. So, a solution to this is to force the AP to generate new packets with new IVs. Now, before doing this, we need to associate with this network. So, what I mean by associate is we need to tell this network that we want to communicate with it, because by default, access points ignore any requests they get unless the device has connected to this network or associated with it. So don't get this mixed up with connecting. We're still unable to connect to the network because we need the password to be able to connect to the network. But what we're doing right now is literally just telling the target network, look, I want to communicate with you. Don't ignore my requests. That's all we're doing. So it's something similar to what happens when you just click on the network when you want to connect to it. You still haven't put the password. You're just telling the target network, I want to communicate with you. Please don't ignore me. So in this lecture, I'm going to show you how to associate with the target network so we can communicate with it. And in the next lecture, I'm going to show you how once associated, we can inject packets into the network and force the number of data to increase very, very quickly. First, I'm going to run aerodumpng against my target network, which has this BSS ID. So I'm going to copy it. And we're going to use the exact same command that we've been using so far. So we're going to do aerodumpng -- BSSID, followed by the MAC address of my target, -- channel, followed by the channel which my target is running on, which is 6. And we're going to store all of this. So we're going to do -- write, and we'll call this file ARP replay because that's the name of the attack. And then I'm going to put my wireless adapter in monitor mode, which is mon0. So a very simple command that we've done before. We're using aerodumpng to capture data from a network with this MAC address running on this channel. We're storing everything in a file called ARP replay. I'm going to hit enter. And as you can see, it's running against my target. And notice the data is increasing really, really slow, or it's actually not increasing at all right now. Now, to associate with this network, we're going to use a program called aireplayng. So we're going to type aireplayng, followed by -- fake auth, because we want to do a fake authentication attack. We're gonna put 0 because we only want to do this once. We're gonna do -A to specify the MAC address of the target network. So I'm gonna paste it. I've already copied it. Then we're gonna do -H to specify the MAC address of my wireless adapter. And to get the MAC address of my wireless adapter, I'm gonna do ifconfig. And it's the first 12 digits of the unspec field. Usually, you'd see it after the ether, but when you enable monitor mode, it'll show up like so. So, I'm gonna copy this, and I'm gonna paste it here, and I'm gonna replace the minuses with colons. And that's it, it's done. And finally, I'm just gonna give the name of my wireless adapter in monitor mode. So, a very simple command, we're using areplay-ng, which is a tool that can be used to run a number of attacks, and we've seen using this with the deauthentication attack. We're telling it that we want to run a fake authentication attack. We want to do this once. We're giving it the MAC address of my target network after the A. Then I'm giving it the MAC address of my wireless adapter after the H. And finally, I'm giving it my wireless adapter in monitor mode. Now, before I run this, notice in here under the auth, we have nothing, and we don't have any clients showing up in here at the bottom. Now, if I hit enter, you can see under the auth, it's showing up as open, and you can see we have a new client here associated with the network. If you look in here, you'll see this is the MAC address of my target network, and right here is the MAC address of my wireless adapter. So right now I am associated with the target network, and if I send it anything, it's going to accept it and it's going to communicate with me. Again, I am not connected to the network. I still can't use the internet. I'm literally just associated with the network so I can communicate with it. Now, in the next lecture, I'm going to show you how we can communicate with this network in a way to force it into generating new packets with new IVs, which will allow us to crack the key very, very quickly. Now that we have associated with our target network, we can start communicating with it and it won't ignore us. So now we can go and start injecting packets into the traffic to force the access point to generate new packets with new IVs. This will increase the number of data really quickly, allowing us to crack WEP networks in minutes, even if the network was not busy like the one that we are targeting right now. Now, there are a number of ways to do this, but in this course, I'm going to explain the most reliable method, which is using an ARP request replay attack. I actually explain other methods in my network hacking course, but they are a little bit more complex and have less success rate. So this is the most reliable method, and it should work against most networks if you have a good signal and a good wireless adapter. So the idea behind this method is to wait for an ARP packet, and I'll talk about ARP in more details later on. So for now, just think of it as a special type of a packet that we're going to be waiting on. Once this packet is sent in the network, we're going to capture it and retransmit it. Once we do this, the router is forced to generate a new packet with a new IV. So, by repeating this process, we will be forcing the router to continuously generate new packets with new IVs. Then, once we have enough data, once we have enough IVs, we can run aircrack-ng exactly as we've seen before and crack the key. So let me show you how to do this in practice. Now, as you can see, I'm already running aerodump-ng against my target network, and I have already associated with it as shown in the previous lecture. So the only thing that's left right now is to run the ARP replay attack in order to inject packets into the traffic and force the router to generate new packets and increase the number of data. To do that, we're going to use areplay-ng again, and the command is actually going to be very similar to this command right here. So I'm actually going to copy all of this because I'm lazy, and I'm going to clear this and paste the command here. Now, there are only a few things that I need to modify. First of all, I don't want to run a fake authentication attack, so I'm going to remove all of this. And I want to run an ARP replay attack. Also, this attack does not take a number, so I'm going to remove this number. And I'm also going to replace the A with a B. And we're done. So, if you look at it, you'll see it's actually very similar to this command right here. We're using areplay-ng, but instead of doing a fake authentication attack, we're doing an ARP replay attack. We're giving it the MAC address of my target network after the B instead of the A. Then we're giving it the MAC address of my wireless adapter after the H, which is identical to this. And then we're giving it my wireless adapter in monitor mode. Now, I'm actually going to associate again before I do that. And then I'm going to hit enter here. And what's happening right now is my wireless adapter is waiting for an ARP packet. Once there is an ARP packet transmitted in this network, it's going to capture it and it's going to retransmit it. Once it does that, the access point will be forced to generate a new packet with a new IV, and we'll keep doing this, forcing the access point to continually generate new packets with new IVs. So you should just wait for it right now. We're literally just waiting for an ARP packet to be sent in the air. And as you can see, the number of data is increasing now very, very quickly, which means that we actually managed to capture an ARP packet. This ARP packet got retransmitted, forced the router to generate a new packet with a new IV, and we are continually doing this process, forcing the router to generate new packets with new IVs. So right now we can go ahead and run aircrack-ng to crack this network. And before I do that, I'll actually just associate one more time, and then I'm going to do aircrack-ng and give it the name of the file which we're storing the data in, which is called arpreplay01.cap. So I'm going to hit enter, and you'll notice the cracking process right now will actually require more data packets. The reason for this is I've actually modified the settings of this network so that it uses a 128-bit key, because in web you can either use a 64-bit or a 128-bit key. And obviously the 128 key is longer. Therefore, I actually modified the key length for this lecture to make sure it's the longest key possible. And as you can see, we still managed to get it within about 47,000 packets. We have the key right here in ASCII, and we have the key in here in hex, where we can use after we remove the colons. So perfect, now we managed to crack the target network. It was idle, as you could see, there was no data being sent, and we managed to do this by forcing the target access point to generate new packets with new IVs. In the previous lectures, we've seen how to crack the WEP encryption in minutes, even if the target network is not busy. Now, in the next lectures, we will talk about cracking WPA and WPA2. First of all, before we start talking about how to crack these encryptions, it is very important to understand that both of them are very, very similar. The only difference between them is the encryption used to ensure message integrity. WPA uses TKIP and WPA2 uses an encryption called CCMP. In any case, this does not affect the methods that we're going to use to crack WPA and WPA2. Therefore, all of the methods that I'm going to show you from now on will work on both WPA and WPA2. Now, both of these encryptions came after WEP, and they were designed to address the weaknesses in it. Therefore, both of them are much more secure, and cracking them is more challenging. So, before we start talking about how to crack them, I want to cover a feature that, if enabled and misconfigured, can be exploited to recover the key without having to crack the actual encryption. The feature is called WPS. It allows devices to connect to the network easily without having to enter the key for the network. So it was designed to simplify the process of connecting printers and such devices. You can actually see a WPS button on most wireless enabled printers. If this button is pressed and then you press the WPS button on the router, you'll notice that the printer will connect to the router without you having to enter the key. This way, the authentication is done using an 8-digit PIN. So you can think of this as a password made up of only numbers, and the length of this password is only 8. So this actually gives us a relatively small list of possible passwords, and we can try all of these possible passwords within a relatively short time. Once we get this PIN, it can be used to recover the actual WPA or WPA2 key. So as you can see, with this method, we are not exploiting WPA or WPA2. We are actually exploiting a feature that can be enabled on these encryptions. So for this to work, first of all, we need WPS to be enabled on the network because it can't be disabled. Also, it needs to be misconfigured, so it needs to be configured to use a normal PIN authentication and not a push button authentication. If push button authentication is used, then the router will refuse any pins that we try unless the WPS button is pressed on the router. Therefore, the method will not work if push button or PBC is enabled. So in most modern routers, PBC comes enabled by default or WPS will be disabled by default, so this method might not work. But because WPA and WPA2 are so secure and so challenging, it is always a good idea to check if WPS is enabled and try the method that I'm going to show you to crack the network. If it fails, then you can try the other methods that I'm going to show you after the next lecture. Okay, now that we know what WPS is and how it can be used to recover the password for WPA and WPA2 networks, let's see how to do that in practice. So, right here I have my Kali machine. I've already enabled monitor mode on my wireless adapter on Mon0. Now usually we use AeroDump-ng to see all the networks around us. But right now we want to see the networks that have WPS enabled, but because like I said, it's just a feature and people can turn this feature off. So first of all, I'm going to use a tool called Wash to display all the networks around me that have WPS enabled. So we're going to do wash --interface and give it my interface in monitor mode, which is Mon0. So all we're doing is wash is the name of the tool, interface to give it the interface, and Mon0 is my wireless adapter in monitor mode. If I hit enter now, you'll see it'll list my network straight away. Now I pressed Ctrl C to cancel this, similar to AeroDump-ng, because it'll keep running unless you cancel it. And you can see this is my target network. It's called test AP. It's giving us the vendor of the hardware used in this network, in this access point. The LCK tell us whether WPS is locked or not, because sometimes WPS locks after a number of failed attempts. So right now this says no, which means that we can actually go ahead and try to guess the pin. It's giving us the version of WPS. It's using version 1. The signal strength is in here, the channel, and the BSS ID. Now I explained the meaning of all of these things before in my AeroDump-ng lecture, so I'm not going to talk about them now. If you forgot the meaning of any of these terms, please go back to the AeroDump-ng lecture. Now, this network actually uses WPA2. So just to confirm this to you, if I go here to my host machine and just try to connect to it, you'll see that it's telling me that this uses a WPA2 password. But like I said, we don't care if it's WPA or WPA2 because we're going to be exploiting a feature in these encryptions, which is the WPS feature. So now that we know our target network uses WPS, there is a good chance that this attack will work against it. The only reason it might fail is if the target uses PBC or push button authentication. Like I said, if the target uses PBC, then it will refuse all the pins unless the button is pressed on the router, and therefore this attack will fail. The only way to know is to literally try this attack and see if it works. So I'm going to copy the MAC address of this network or the BSSID. And the first thing that I'm going to do, similar to what we did with WEP, I'm going to associate with the target network using a fake authentication attack. So basically, I'll be saying, I want to communicate with you. Please don't ignore me, so that when I run the attack, the network will start accepting the pins and not ignore me. So to associate, we're going to use the exact same command that we used when we did it with WEP. So we're going to use a reply ng. We're going to tell it I want to run a fake authentication attack. We're going to give it the delay. So this is the time to wait between association attempts. Previously, we set it to 0 and we had to do this manually every now and then. Right now, I'm going to set it to 30 so that we associate with the target network every 30 seconds. Then I'm going to do -A to give it the MAC address of my target, and -H to give it the MAC address of my wireless adapter in monitor mode. And we've seen that we can get this by doing ifconfig and copy it from here. We said it's the first 12 digits. And I'll just replace the minus with the colon. And finally, I'm going to give it the name of my wireless adapter in monitor mode, which is Mon0. So I explained this in details before. That's why I did it quickly. If you don't remember how I did this, please go back to the fake authentication attack lecture. So the command is ready now, but I'm not going to execute it. I'm going to go down to the bottom terminal and run Reaver, which is the program that will brute force the pin for me, and only then I will associate with the target, because otherwise a reply ng will fail to associate with my network. So I'm going to move to this terminal right here. I'm going to clear the screen and we're going to run Reaver, which is the program that's going to brute force the pin. So it's going to try every possible pin until it gets the right pin. Once it has the right pin, it'll use it to compute the actual WPA key. So using Reaver is very, very simple. It's very similar to everything we've been doing so far. So first of all, we have to type the program name, which is Reaver. Then I'm going to do --BSSID to give it the MAC address of my target network. So I'm just going to paste it. Then I'm going to do --channel and give it the channel of the target network, which is 1. Then we're going to do --interface and give it my wireless adapter in monitor mode, which is Mon0. So a very, very simple command. We're using Reaver. This is the name of the program that will do the brute forcing for us and give us the key. We're giving it the BSSID, the MAC address of my target. We're doing --channel to give it the channel that my target is running on. And we're doing --interface to give it the name of my wireless adapter in monitor mode. I'm also going to add 2 more options. I'm going to add -VVV to show us as much information as possible. This is really helpful. If it fails or things go wrong, we'll be able to know what's happening, why things are going wrong. And I'm also going to do --no associate to tell Reaver not to associate with the target network because we're already manually doing that in here. So Reaver can automatically do this step right here for you, but I've seen that it fails a lot. Therefore, it's actually better to do it ourselves manually here and then tell Reaver not to associate. So now I'm going to hit enter to get Reaver to work. And I'm going to go up to the top terminal and I'm going to hit enter to associate with the target network, telling it please don't ignore us, so that Reaver at the bottom here can brute force the pin and try every possible pin until we get the correct pin, which we'll use to get the password. Now, as you can see right now, I'm getting an error, and this is actually a bug with the latest versions of Reaver. So if you get this bug, this means they still haven't fixed it in the latest version, so it's better to go back and use an older version. I'm going to include an older version that works perfectly in the resources of this lecture, so you can access it from the top left of the lecture. If you tried Reaver and got this error right here, then go ahead and download this older version. Right now, I already have it in my downloads right here, so you can see I'm in Home Downloads, and I have it right here called Reaver. So what I'm going to do is I'm going to clear this again and I'm going to navigate to my downloads. So CD downloads, I'm going to list, and you can see we have it right here. Now it's already in green for me, but for you, you'd want to change the permissions of this file to an executable. So you'll have to do chmod +x Reaver. This will make it an executable. Once it is an executable, you can run it by doing ./ followed by its name, so Reaver. Then you can do the exact same command exactly like I just did it with the one that comes pre-installed in Kali. So I'm actually just going to go back to what I had, and I'm just going to go to the start of the command and put ./. So when we put the ./, we're basically running the file that is in the current working directory. We're running this. We're not running the normal Reaver file that is pre-installed in Kali. Then we're using all of the options exactly the same way that we were using it with the built-in one. I'm going to hit enter. And as you can see right now, Reaver is trying the pin 1, 2, 3, 4, 5, 6, 7. And perfect. You can see the pin was actually 1, 2, 3, 4, 5, 6, 7, 0. So it's a simple pin. It actually came with this pin. So I didn't manually set this pin. My router came from the factory with WPS enabled with this pin. So like I said, this still works, but again, not against all routers. From that, it was able to discover the WPA key, which is UAU RWSXR, and the name of the router is TestAP. So I can literally go ahead and connect with this password, and I'll be able to connect to the network and see and decrypt all of the packets sent in the air. Now, if WPS is disabled on your target network, or if it's enabled but configured to use push button or PBC, then the method that I showed you in the previous lecture will not work. Therefore, you will have to go and crack the actual WPA or WPA2 encryption. And like I said, when these encryptions were designed, the developers knew about the weaknesses in WEP, and they made sure that they properly fixed these weaknesses. They actually did a pretty good job at this. Therefore, we cannot use the same method used in WEP to crack WPA and WPA2. So in WPA2, the keys are unique, they're temporary, they're much longer than what they were in WEP. Therefore, the packets sent in the air contain no information that is useful for us. So it doesn't matter, even if we capture 1 million packets, we can't use them to crack the key. The only packets that contain useful information are the handshake packets. These are 4 packets transferred between a client and the router when the client connects to the network. So in this lecture, I'm going to show you how to capture these packets, and in the next lectures, we'll see how to use them to crack the WPA or WPA2 key. First of all, as usual, you'd want to run aerodump ng against all the networks around you. I've already done that. And as you can see, this is my target right here. It's using WPA2. And this is the MAC address. I'm going to copy it. And the first thing we'll do is just run AeroDumpNG on this network and store the data in a file, exactly the same way that we used to do it with WEP. So we're just going to do AeroDumpNG --BSSID and give it the BSSID of my target, -- channel, and give it the channel of my target, which is 1, -- write, to specify a file name to store all the data that we're going to capture in. And let's call this WPA handshake, because we're going to capture the handshake. And finally, we're going to give it my wireless adapter in monitor mode, which is mon0. So very simple command. We've done this multiple times by now. We're using AeroDumpNG. We're giving it the MAC address of my target after the BSSID. I'm giving it -- channel to specify the channel of my target. I'm using -- write to store all the data in a file. This file will contain everything that we capture. So if we capture the handshake, it will be in this file. And finally, I'm giving it the name of my wireless adapter in monitor mode. So now I'm going to hit enter. And as you can see, AeroDumpNG is working against my target network. And right now, all we have to do is literally sit down and wait for the handshake to be captured. Like I said, the handshake is sent when a client connects to the network. So we'll literally have to sit down and wait until a new client connects to the network. Once a new client connects, we will capture the handshake, and you will see in here AeroDump telling us that the handshake has been captured. Alternatively, we can use something that we learned before, which is a deauthentication attack. We know using that attack, we can disconnect a client from the network. So we can do this for a very short period of time. We can disconnect this client from the network. He will automatically connect once we stop the attack. Therefore, when he automatically connects, the handshake will be sent in the air and we will be able to capture it. This way, we will not have to sit down and wait for someone to voluntarily connect to the network. So we've seen how to do this before, and it's going to be exactly the same command as we did it before. We used AirPlayNG. We did --deauth. Then we specified a really large number of packets to keep the client disconnected for a long period of time. This time I'm going to set this to 4 to only send 4 deauthentication packets. This way, my client will be disconnected for a very short period of time. They won't even feel that they got disconnected, but this is enough for the handshake to be sent because they will be disconnected, they will automatically connect, and when they do that, we will capture the handshake. Now, the next argument we want to set is the MAC address of my target. So we're going to do -A followed by the MAC address of my target. Then we're going to do -C followed by the MAC address of the client that we want to disconnect. So it's this client right here. I'm going to copy, paste it here, and finally we're going to give it the name of my wireless adapter in monitor mode, which is mon0. And we are done. Again, I've spent a full lecture on this command explaining what a deauthentication attack is, so if it's a bit confusing, please go back and revise that lecture. Basically, all we're doing is we're using AirPlayNG to run a deauthentication attack to disconnect this device for a very short period of time. That's why I'm setting this to only number 4. Then I'm using -A to specify the MAC address of my target, -C to specify the MAC address of the client connected to this network, and then I'm giving it my wireless adapter in monitor mode. Now I'm going to hit enter and keep an eye on this side right here. You'll see the handshake will be captured in here. So we're going to hit enter. Deauthentication packets are being sent. And perfect. As you can see, once the client connected again, we received the handshake. So now we can quit AeroDumpNG, so Control-C, because we have the handshake now. It is stored in the file that we set after the write option, which is called WPA handshake. And in the next lecture, I'll show you how this handshake can be used to get the key for the network. From the previous lectures, we learned that when it comes to WPA and WPA2, the only packets that contain some information that can help us with cracking the key are the handshake packets. And in the last lecture, we learned how to capture the handshake and store it in a file. Now, the handshake does not contain any information that can help us to recover or recalculate the WPA key. The information in it can only be used to check whether a password is valid or not. Therefore, what we're going to do is to create a word list, which is basically a big text file that contains a large number of passwords. Then go through this file, go through the passwords one by one, and use them with the handshake in order to check whether this password is valid or not. You can actually download ready word lists from the internet, but in this lecture, I want to teach you how to create your own word list, and in the next lecture, I'm going to explain to you how the word list and the handshake are used in order to recover the password, and we'll see how to do that in practice. So in this lecture, we're going to learn how you create your own word list using a tool called Crunch. This is a really handy skill to have under your belt if you want to be a penetration tester, because you're going to face a lot of scenarios where a word list attack can become very handy. So using the tool is very simple. All you have to do is just put the name of the tool, and then you specify the minimum number of characters for the passwords to be generated. Then we're going to specify the maximum number of characters for the password. Then you specify the characters that you want to generate passwords from. For example, you can put all lowercase characters, all uppercase, you can put numbers, digits, or you can just specify a smaller number to make the word list smaller. You can also use the option T, which is an optional, to give a pattern. So for example, let's say that you were looking at the person while they were typing their password, and you've seen that the password will start with an A. So you can tell Crunch that the password will start with an A, and then give me all possible combination of passwords that start with an A. And after that, we use the -O option to specify the file name where the passwords are going to be stored. So we have a small little example here that will generate a list of passwords that start from 6 characters to 8 characters and contain these characters right here. So it's going to create combinations of 1, 2, 3, ABC, and the $sign. And it's going to store it in a file called word list. And these passwords are going to start with an A and end with a B. And it will generate passwords based on all possible combinations between the A and the B. So all of the generated passwords will always start with A and end with B. So let's have an example of the tool. Now the tool actually have a lot of options other than what we've seen so far. So if you just type in man crunch, you'll see all the options that you can set, and you'll see detailed description about all of these options. So it's actually really, really good. You can go ahead and spend some time to get familiar with the tool. Now I'm going to show you the example, and based on the example, you'll be able to run all of these commands. But if you want to run or create some advanced word lists, then I highly recommend that you go over this. One of the really cool options that I want to highlight is the -P option. The -P option tells Crunch to generate passwords that don't have repeating characters. For example, when you specify all lowercase characters, you specify A, B, C, D, it will start by generating passwords made of A, and then A, B, and all of that. So when you do this, Crunch will actually ignore these type of passwords, and it will only create passwords that don't have any repeating characters. And that will reduce the size of the word list from the number of characters to the power of the length to the number of characters factorial. If you scroll down, you'll actually see more examples of commands and the type of word lists that will be created. So again, you can have a look on these and get yourself familiar with. Once you're done looking at the man, you can just press Q and you'll be out of it. And we're gonna run our command here. So we're gonna use crunch. And again, I want to generate passwords of minimum of 6 characters and maximum of 8 characters. And I want them to contain combinations of ABC. And let's say the digits 1, 2. Now in here you can actually keep listing things. You can list characters, you can list uppercase characters, or even symbols if you wanted to. Once you're done with listing the characters, we're going to specify the file to save it to, and we're going to save it in a file called test.txt. So the command is very simple. It's crunch, minimum length of the password, the maximum length of the password, followed by the characters that we want to use to generate passwords from, and then O to the file that the passwords are going to be stored in. I'm going to hit enter. And as you can see now, it's telling us that it generated 448,000 passwords approximately, and they're all stored in a file called test.txt. Now the size of the file is 4 megabytes, and now I can open this file by doing cat test.txt, and as you can see now, we can see all the passwords that have been generated. I'm going to Control C out of it because it's a huge file. And as you can see, it actually contains all possible combinations of ABC 1, 2. I also want to show you an example of using the -t option. So I'm going to set this to only 6 to 6, so it's only 6 characters. And we're going to use the -t option, which is the pattern option. And I'm going to tell it that I want the password to always start with an A. And then I want you to fill all possible combinations of characters between the A and the B. So I want passwords that start with an A and end with a B. And in the middle, at the @ you can fill all possible combinations of ABC 1, 2. Gonna hit enter. As you can see now, the number of passwords is much less. It's only 625 passwords because I've narrowed down the possibilities of passwords. Again, if I do cat test.txt, you'll see that I have all the passwords right here. So this is it. Tool is really useful, can be used in many scenarios. I highly recommend that you spend some time with it, and also have a look on some of the existing word lists out there on the internet. Now, from the previous lectures, we learned in order to crack WPA or WPA2, we need to first capture the handshake, and second, have a word list which contains a number of passwords that we're going to try, and hopefully one of them will be the password for the target network. So right now I have both of these components, and we are ready to go and crack the password. To do this, aircrack-ng is going to unpack the handshake and extract the useful information. The MIC right here, or the message integrity code, is what's used by the access point to verify whether a password is correct or not. So it's going to separate this and put it to the side, and then it's going to use all of the other information right here combined with the first password from the word list to generate an MIC, another message integrity code. And then it's going to compare this MIC to the one that's already in the handshake. If the MIC generated using this information plus the first password is the same, then the password used to generate this MIC is the password for the network. Otherwise, this password is wrong and it'll move to the next password. Again, it'll do the same. It'll use all of this information combined with this password, generate a new MIC, compare this new MIC to the one that's already in the handshake. If it's correct, then this is the password. If it's not, then it's going to move on to the next password. And it'll keep doing this through all of the passwords in my word list. If any of them generates the right MIC, then this is the password for the network. Otherwise, we won't be able to get the password. That's why the success of this attack really depends on your word list. So let's see how to do this in practice. Right now I have my word list right here. It's called test.txt, and I've actually manually added my password to the end of the list right here, just so that when I run the word list against the handshake, I will actually find the password, because the word list did not contain my password by default. I also have the handshake file right here, as you can see, and all of this is in my home directory, which is my root directory. So if I do ls in here, you'll see I have the word list and the handshake file. So we're ready to run aircrack-ng. So we're going to type the name of the program as usual, followed by the name of my capture file, which is wpa-handshake01.cap. So far it's identical to the way that we used to use it with WEP. The only difference right now, because this is a WPA2 network, we have to specify a word list with the -w option. And the name of my word list is test.txt. So very simple. Aircrack is the name of my program. wpa-handshake01.cap is the name of the file that contained my handshake, and I'm using -w to specify my word list file. I'm gonna hit enter, and as you can see now, aircrack-ng is running through the word list, testing each word in the word list one by one, as shown in this diagram, calculating an MIC based on this information and the word list, and then if the MIC is correct, it's going to tell me that this is the password. Now, the speed of this depends on your processor and the size of your word list file. So if you have a huge file, obviously it will take you longer time. There are also online services that you can try where you upload the handshake, and they have huge word lists and they have supercomputers to run through these word lists and try to give you the password. Unfortunately, I can't share their links with you, but you can easily find them on Google if you search for them. And perfect, as you can see, we managed to find the key. It's telling us the key is found, and this is the key to the network. And this is the correct key because, as you know, this is the same key that we got when we exploited the WPS feature. So now we can go ahead and connect to the network, and we'll be able to run all of the cool stuff that I'm going to teach you in the post-connection attack section. Now, this is the only practical way known so far to crack WPA and WPA2 keys. There are methods to speed up this process, so you can use the GPU for cracking because it's much faster than the CPU. That's if you have a GPU. You can also use rainbow tables. You can also pipe the word list as it's being created in Crunch to aircrack-ng. This way you can create bigger word lists without using any storage on your computer. There are also methods so that you can pause your cracking process and then come back after a while without losing your progress. But the main idea is the same. The only way right now to crack WPA and WPA2 is through a word list attack. You can use social engineering, however, to get the password using an evil twin attack where you trick one of the users to give you the password. This is actually all covered in my advanced network hacking course. The cracking using the GPU, piping Crunch to aircrack-ng, getting the password using an evil twin attack, and much more advanced network hacking techniques. If you're interested in that, then I highly recommend you have a look on my advanced network hacking course. Check out the bonus lecture of this course, the last lecture of this course. It contains links to all of my other courses and a comparison between them. Okay, so through all the previous lectures, we've seen all the weaknesses that can be used by hackers in order to compromise WIP, WPA, and WPA2 encrypted networks. We've seen how they can use these weaknesses to crack the password and get the actual key to the network. We also seen that attackers are able to de-authenticate or disconnect any device from any network without the need to know the key to that network. And in the previous lecture, we've seen how we can modify the settings of our routers so that we can increase the encryption of our network, increase the security of our networks so that hackers can't use the attacks and get the password. Now, in order to apply the settings that we talked about in the previous lecture, you need to be able to access the settings page for your router. Now, each router has a web page where you can modify the settings for the router, and it's usually at the IP of that router. So first of all, I'm going to check and get the IP of my computer or of my device, and I'm just going to do ifconfig LAN 0. And as you can see, this is the IP of my computer. So I'm going to open my browser, and I'm going to navigate to 192.168.0, and the IP of my computer was 25. Usually the IP of the router is the first IP in the subnet, so this is the subnet. At the moment it's 192.168.0, and I'm just going to add number 1 because that's the first IP in the subnet, and that will take me to the router settings page. And as you can see, it's asking me to enter a username and a password. Now, routers come in with a pre-specified username and password. You can check what's the default username and password, and then I highly recommend you change them after that. So usually it's written in the manual. So check the manual, see what's the default username and password, and then you can log in. Now, in some cases, the attacker might be doing a deauthentication attack against you, so he might be preventing you from connecting to your network wirelessly. So what you can do is you can connect to your router using a cable, using an Ethernet cable, and when you do that, then the attacker cannot use a deauthentication attack to deauthenticate you or disconnect you. So you'll be able to access your router settings using the wire, and then you can modify your security settings and change the encryption, change the password, do all the things that I recommended in the previous lecture in order to increase the security so that the attacker will not be able to attack your network and get the key. Now, the settings of each router are different. They depend on the manufacturer and even the model of the router. But usually the settings, the way that you change the settings is the same. And like 90% of the cases, the router is always at the first IP of the subnet. So all you have to do is you get your IP using ifconfig command like we did here when we got it, and it was 192.168.0.25. That's the IP of my device. And then I changed the last 25 to number 1 to the first IP, and that is the IP of my router. Now, I'm going to navigate to the wireless settings. Now, as you can see, there's a lot of settings that you can change for your network, and we're concerned with the wireless settings at the moment. So, as you can see, my wireless is enabled. You can change the name of the network. You can change the channel and the bandwidth and all that. So I'm going to go to the security. And as you can see now, I'm using WPA encryption with WPA or WPA2 authentication, and the encryption using AES and TKIP. And if I go on WPS, you can see that the WPS is disabled. As we said now, so basically I'm not using web, so they cannot use any of the attacks that we spoke about that allow you to crack WEP encryption. I'm using WPA, which is much more secure, and I disabled WPS, so they cannot use Reaver to determine my WPS pin and then reverse engineer my password. The only way that the hacker can access or get my password is by obtaining the handshake first and then use a word list to find my password. Now, my password is very random, even though it actually doesn't use numbers or digits, just letters, but it's very random, so there is a really small chance of someone being able to guess that password. Now, there is another thing that I'd like to show you here is the access control. And using this, you can add policies. So you can add an allow policy or a deny policy. And using that is based on the MAC address. You can specify MAC addresses that you want to allow to connect to your network. You can also specify MAC addresses that you can deny from your network. So for example, you can just, if you don't have many visitors coming to the house, or if you're in a company with a specified number of computers and you want to only to allow a number of computers to connect to that network, then you can just ask the people, get their MAC addresses, the people that you want to allow, and add them in an allow list. Now, even if someone has the actual key, the right key for your network, and they don't exist in the whitelist or in the allow list, they will not be able to access the network. You can also add a deny list, which is if you you want to deny a certain computer or a certain person that you think are suspicious, you can just add their MAC address in the deny list and they will not be able to connect to your network. So this is about it. As I said, the settings page usually look different. The names might be called different names, as in the names for each of these tabs. But usually the main thing is you should be able to access the router settings using the subnet IP and add the number 1, which is the first IP at the end. And if you're being attacked, if you can't connect to your network at all, then just use a cable and modify the settings like we discussed in the previous lectures. In this section, we're going to talk about post-connection attacks, so attacks that you can do after connecting to your target network. Now, it doesn't matter whether the target network is a Wi-Fi network or a wired or an Ethernet network. It really doesn't matter. As long as you gained access to this network, as long as you're able to connect to it, you'll be able to do all of the attacks that I'm going to show you in this section. Now, you'll notice once connected, you can do so many cool things. So you'll be able to gather detailed information about all of the clients connected to the same network. You'll also be able to intercept data and see any usernames, passwords, or any information they use on the internet. You'll be able to modify data as it's being sent in the air. So you'll be able to inject evil code and do so many cool things on the network. Now, to do all of the attacks that I'm going to show you in here, you have two options. The first option is to run the attacks against the virtual NAT network against the Windows machine. You just need to make sure that the virtual Windows machine is connected to the same NAT network as the Kali machine. Or you can run the attacks against real computers connected to your real Wi-Fi network, and you need to make sure that you have a wireless interface connected to the Kali machine, and the Kali machine needs to be connected to your target Wi-Fi network. Now, throughout this section, I'm actually going to be using both options. So I'm going to be running some attacks against the Wi-Fi network, and I'll be running some against my virtual NAT network, just to make sure that you're comfortable with running all of these attacks in different environments and in different networks. Because like I said, it doesn't really matter how you gained your access to the network. The network type doesn't really matter either, as long as you are able to connect to the target network. Now, to practice some of the attacks that we're going to learn in the future lectures, you need to have a target machine or a victim machine. So this is a computer that you're going to target and try to hack and test the attacks that we're going to learn against. So you can do this against any machine, but I highly recommend installing target machines as virtual machines. This is great because it won't break a real computer for you if you actually break something. It's also very easy to fix. Even if you have a computer that you don't care about, it's very easy to fix virtual machines. You can just remove it and reinstall it, or store a snapshot and go back to it. Now, as we all know, Windows is a very common operating system. It's used by a lot of people. So in this lecture, I'm going to show you how to install Windows 10 as a virtual machine so that we can test some of the attacks that we're going to learn in the future against it. So we'll use this machine with scenarios that mimic a normal user that is just using their Windows to browse the internet or do whatever normal people do with their machines. So Microsoft has actually released a free versions or free virtual machines of Windows that you can download and use. These are free and you're allowed to download them, and we're downloading them from Microsoft's website. So you need to go into this link to download it. As you can see here, this is the same link. So make sure you select what host operating system you have. So if you have Windows, you click on the Windows tab. If you have Mac, on the Mac, and if you have Linux, on the Linux. I have a Mac, so I clicked on the Mac tab. And from here, make sure you select Windows 10 Stable. And make sure you select the VirtualBox image. So these are all applications that allow you to install virtual machines. At the moment, we're using VirtualBox for everything. So just make sure you use the VirtualBox image. Once you do that, you will have a zip file like this one, uncompress it, and you will get this file right here. Now this is a virtual machine, a VirtualBox virtual machine file. So I'm gonna double click it. And as you can see now, VirtualBox is asking me to import this machine, and it's already set up the settings for it right here. Now we can import it the way it is and then modify the settings. Now, as you can see here, I have my Windows installed right here, and I'm just gonna boot into it by, actually, I'm gonna modify the settings first, because I remember I think it gave it 4 gigs of RAM, and I think that's too much. So I'm gonna go in to here, and I'll set this to 2 gigs. And yeah, and set that, okay. And I'll start it. And as you can see, Windows starting straight away, no need to install it. It's already installed and ready and given to us by Microsoft. Now, if you get asked for a password, then the password is literally password with a capital P and a 0 instead of the O, followed by an exclamation mark. Now, as you can see, we have a fully working Windows machine right here, Windows 10. So it's our second victim or target machine. Information gathering is one of the most important steps when it comes to hacking or penetration testing. If you think of it, you can't really gain access to a system if you don't have enough information about it. So for example, let's say you're connected to a network and one of the devices connected to this network is your target. Now, for you to hack into that target, first you need to discover all of the connected clients to this network, get their MAC address, their IP address, and then from there try to maybe gather more information or run some attacks in order to gain access to your target. Now, there are a number of programs that will do this for you. Examples are NetDiscover and Nmap, which do this job really well. So in this lecture, we'll start with the simpler one, which is NetDiscover, and see how to use it to quickly map the network we're connected to. And in the next lecture, I'm going to show you how to use Nmap to gather detailed information about all of the clients connected to the same network. So I have my Kali terminal in here, and if I do ifconfig, you'll see I have ETH0, it has an IP address, and like I said, this is the virtual interface created by VirtualBox when we set the Kali machine to use a NAT network. Now, I also said that this NAT network behaves exactly like an Ethernet network, and as far as the Kali machine is concerned, it thinks that it is connected to a real wired network, and as you can see in here, it's telling me that wired connected. Now, I have my virtual Windows machine right here. It is configured to use the same NAT network as the Kali machine. Remember, we're still in the network hacking section, so both you and the target machine need to be connected to the same network. So as far as these two computers are concerned, they think that they are connected to the same network. So what I want to do right now is use NetDiscover and see how we can use it to discover all devices connected to the same network. Now, the method that I'm going to show you will work exactly the same whether you're using it against a virtual network like I'm doing right now, or against real network, and even if your target is a Wi-Fi or a wireless network. So all you have to do is type the name of the program, which is NetDiscover, and then type -R to specify an IP range to search for. This needs to be a range that can be accessed by you. So right now you can see that my IP is 10.0.2.16, and I can only access IPs on the same subnet. So IPs on the same subnet start at 10.0.2.0 and they would end at 10.0.2.254 because 254 is the last IP that a client can have. So my range is going to be 10.0.2.1, and I want to search for clients that might have an IP of 10.0.2.1, 10.0.2.2, 10.0.2.3, all the way up to 10.0.2.254. So instead of manually typing all of these IPs, I can just type over 24 and NetDiscover will automatically know that I'm trying to search for all of the IPs that start at 10.0.2.1 and end at 10.0.2.254. So this is a way of specifying an IP range for the whole subnet. So if I hit enter now, you'll see that NetDiscover will show me all the IPs of the devices connected to the same network, and note that the first three parts of the IPs are always the same because they are on the same subnet. And I also have the MAC addresses of these clients, and NetDiscover is also attempting to guess the device vendor. Now if I press Q, this will quit the program, and right now we have a list of all the connected clients to the same network. Now, like I said, you can also use this method to discover clients connected to the same Wi-Fi network. The only thing is, right now, if I do ifconfig, you can see that my Kali machine does not have a wireless adapter. It's not connected to a Wi-Fi network. And like I said before, you cannot access the built-in wireless card from a virtual machine. Therefore, if you want to do this or run any of the wireless attacks that we're going to see in the future against a real computer and a real wireless network, you're going to need to use a wireless adapter. Now, I'm going to include links in the description that will help you pick a good adapter that works with Kali Linux. But right now I actually have one, and I'm just going to connect it and use it just to prove to you if things work on the virtual machines connected to the virtual network, they will work exactly the same against a real network with real machines. So I'm going to connect my adapter now, and if I do ifconfig, it's still not showing up. So I'm going to connect it from my devices, USB, and click on the adapter name, and let's see if it shows up now. Perfect. As you can see, I have an adapter now called LAN 0, and what I'm gonna do is I need to connect this adapter to a Wi-Fi network first before I can discover all the connected clients to this network. So I'm gonna go to my network manager, I'm gonna click in here, and you want to click on select network, and as you can see, automatically now it actually connected to a network. But in your case, you'd want to select a network and click on connect, and then it will ask you for the password. So now I'm actually connected, and you'll see if I do ifconfig again, right now LAN 0 has an IP address. So this means that it is connected to a network, and this means that we can use it now with NetDiscover. So again, I'm going to use the exact same command that I used before just to show you and prove to you that if this works against virtual machines, it will work against real machines. And the only difference is going to be the IP. So I'm going to remove this IP, and as you can see right now, my IP is 192.168.1.8. So therefore, the range that I'm going to look for is going to start at 192.168.1.1. And I'm going to leave the over 24 here because this will tell NetDiscover that I want to start at 192.168.1.1 and finish at 192.168.254. So if I hit enter now this did not work, and I know why. In order for this to work, you actually have to disable the NAT network. So to disable the NAT network, we're going to go on devices, we're going to go on network, and we're going to uncheck the connect network adapter. So now once done with this, if we just run the exact same command again, as you can see, it's discovering all the connected clients, all their IP addresses, all their MAC addresses, and it's guessing the manufacturer. And you can see it's also discovering some Apple devices here. So as you can see, it's working perfectly using the exact same command. Now, I only did this just to show you that if things work against virtual machines and against virtual networks, then they will work against real machines, because these virtual machines and virtual networks are modeled over real machines. And as far as the machines are concerned, they actually think they are real computers and real machines. The second program that we'll use for network mapping is Nmap. Now, in the previous lecture, we used NetDiscover, and we've seen how nice it is to quickly discover all the devices connected to our network, see their MAC address, and maybe get the vendor. Nmap takes scanning to a whole new level. It might be a little bit slower than NetDiscover, but it will show you much more information about the target. So you'll be able to see the open ports, you'll be able to see the running programs or the running services on these open ports. You'll be able to determine the computer name, the operating system running on that computer. If you're in a network, you'll be able to discover all of the connected clients. You'll be able to bypass security, bypass firewalls, and so much more. Nmap is actually a huge tool, and there are books and complete courses done just to teach Nmap. The Nmap book would actually be a really good read once you're done with this course. Now, because this tool is huge, we're not going to be able to cover all of its uses, but in this lecture, I'm going to show you the basics of this tool, how to use it to discover all the connected clients and see useful information about them, and we'll actually use it more when we get to the gaining access section. We're actually going to be using ZenMap, which is the graphical user interface of Nmap. So to run it in terminal, you just have to type ZenMap, or you can find it under your applications menu. Now, as you can see, it has a very simple interface. The first thing that we see is the target input box. In here, you can put your target. You can scan any IP that you can reach, whether it's a personal computer, whether it's a server, whether it's an IP for a web server, for a website, for example, that you want to discover all the open ports and all the running services on it. Or, like what we're going to do right now, we can put a range similar to what we did with NetDiscover, and it'll scan this whole range, discover all the live IPs, all the IPs of the connected machines on the same network, and display information about them. Now we'll have a look on how to scan servers in the gaining access section. So for now, since we are still in the network hacking section, we're gonna put a range to discover all the connected clients and see useful information about them. So right now I'm actually connected to my wireless network. That's why I'm gonna specify the whole range on that network, and we've seen how to get that in the previous lecture. So it's 192.168.1.1 over 24. At the bottom, you can see the command. This is actually the Nmap command that will be executed when I hit the scan button. So like I said, ZenMap, what we're using right now, is just a graphical interface that will run this Nmap command in the background and show me the results. So if you know a custom Nmap command, you can put it here, or if you just want to see Nmap in terminal, you can literally copy this command, paste it in terminal, and it'll give you the same results that you would get if you run it here. Alternatively, if you don't really know much about Nmap and its commands, you can use one of the ready profiles in here. So in this lecture, we're actually going to be using a number of these profiles, and we'll see the difference between them in terms of speed and the information gathered. So I'm going to start with the ping scan. This is a very quick scan. It literally just pings every possible IP in the range, and if it gets a response, it'll record this response and it'll show me the devices that gave me a response, which means that these are the devices connected to the network. Now, a lot of devices do not respond to ping requests even if they are alive, so the list that you'll get in this scan might not include all the devices connected to your network. Now, once the scan is done, as you can see, we can see the list of all the connected devices in here, and in here we can also see the MAC addresses for each of these devices. We also can see the vendor. So for example, we can see that the device at 192.168.1.1 is a Cisco device. This is actually my router. and it is made by Cisco, so this is correct. So we can go ahead and start looking for exploits in this device. We can also see the 192.168.110 is a HTC device, and again, this is a HTC phone. This is correct. And since it's HTC, then we know that it's probably running on Android. So as you can see, we're getting more information about the connected clients. Again, we can see the 192.168.112 is an Apple device. So it could be a phone, a tablet, or a Mac. We can see the next device is a Dell. So again, it was a very quick scan, but as you can see, it still gave us much more information than what we got from NetDiscover. The next scan that I want to show you is the quick scan. Now this is going to be slightly slower than the pink scan, but it's going to show us more information. So right now you can see that the scan is showing us the same information that we seen before with the pink scan, but it's also showing us the open ports on each one of the discovered devices. So it's able to discover the following ports in the router, and we can see that port 80 is open. This is actually the port used for the router settings page because it runs on a web server, so this is correct. Again, we have our Apple device here that we said it might be a phone or a computer or a tablet, but we can see now it has port 22 open. So this is a port for a service called SSH, which is designed to allow remote access to the system it's running on. Again, if you go on all the other devices, you can see all the open ports and the services running on each one of these ports. Now, in the next lecture, we'll build up on this. We'll see how to gather even more information, and you'll see how important information gathering is, because we're going to use the gathered information to hack into an iPhone that is connected to the same network. Now, in the previous lecture, we had a quick look on ZenMap and how it can be used to gather information. So in this lecture, we'll build up on that. And the main scan that I want to show you right now is the Quick Scan Plus. This scan takes the Quick Scan one step further. So first of all, it'll be slower, but it's going to show us even more information. So first, we're going to be able to see the operating system running on the discovered devices. We will also be able to see the device type, whether it's a phone or a laptop or a router. And we'll be able to discover the program and the program version running on the discovered ports. So before, for example, we were able to discover port 80 is open, but we didn't know what program is running on this port or what version of this program. Getting the exact program version is really helpful when we get to the gaining access section, and you'll see then how we can use that to exploit vulnerable services and gain full control over the computers that have these services installed. Now, straight away, when you look at the results, you'll see that we got much more information than all of the scans we ran so far. So the first thing you'll notice is the icons beside the IPs of the discovered devices. These icons represent the operating system running on these devices. So right now we have the operating system for all of the connected devices. And now it's showing us the programs running on each of the discovered ports and the versions of these programs. So for example, if we look at the 192.168.112, the Apple device, on the last scan, we knew that port 22 open and we knew that SSH is running on it, but we didn't know what version of SSH was running. Right now we can see that it's running Open SSH version 6.1. So we can go on Google and look for exploits and vulnerabilities in this specific version, and we might actually find something. We'll actually talk more about that in the gaining access section. Now, if you look at the device type, you can see that it's a media device, it's a phone. So before, we knew this is an Apple device, but we didn't know whether it's a tablet, a phone, or a MacBook. Right now, we know that it is a phone. It's also discovering that it's running Apple iOS 4, 5, or 6. Now it's actually running a newer version of iOS. I'm not entirely sure. I think 9 or 10, but still it's close enough. It's telling me that it's an Apple. It's telling me that it's a phone, it's running iOS, so this is really, really good. Now, if we go to the next device here, the 192.168.120, this is a Linux device, and when we ran the quick scan, we were able to identify port 80 and port 49152 open, but again, we didn't know the program running or the service version running on this port. So right now we know it's Apache HTTPD 2.2.22. It's running on Ubuntu. So again, now we have the operating system, the exact version of the service running, so we can go and look for weaknesses and exploits in this specific version. And this port, we didn't even know what service was running on it. Right now we know it's a UPnP service, and the server is Mediatomb UPnP. We have the exact version again. So again, we can go ahead and look for exploits in these specific versions, and if we discover any, we'll be able to gain full control on this computer. Again, if we go down to the 192.168.122 machine, we can see that it's running a Microsoft HTTP API on port 5357. You can also browse by the services. So from here on the left, if you click on services, you'll be able to categorize the discovered clients based on the services. So if we click on HTTP, we'll see all the clients that have a HTTP service running. If you click on SSH, we can see the Apple device here. It's the only device that has a SSH service running. So let me actually show you a quick and fun example. If we go back here to the hosts and go back to the Apple device, the 192.168.112, as I said, we know it's a phone, we know it's an Apple phone, we know that it has an SSH service installed on it, running on port 22, and we know that SSH is a service that allows you to remotely execute system commands on the computer that has the SSH service installed. Now, obviously, before you can use this service, you have to use a username and a password. Once you authenticate, it'll allow you to execute system commands remotely on that computer or on that phone. Now, by default, iOS devices do not have an SSH server. Usually, when you jailbreak the phone or the device, it'll automatically install an SSH server, and the password for that server is set to Alpine by default. That's ALPINE. Now, since we know that this is an iPhone and it has port 22 open with Open SSH server, we know that this phone has been jailbroken. Now, since the phone is jailbroken, we know the password to log into SSH is Alpine unless the user changed it. Now, most users do not even know about this, and even the ones that know about this, like myself, are too lazy to change it. So it's always worth a try. If you discover a phone like this in the same network, it's always worth a try to go and try to connect to it with the default password. So I'm just going to go to my terminal, and I'm going to try to connect to this phone using SSH. So I'm going to type SSH root, which is the username for the admin in Linux, at 192.168.112. This is the IP of the phone. I'm going to hit enter. It's asking me if I should trust this connection. I'm going to say yes. And now it's asking me for the password. And like I said, when the phone is jailbroken, the password is set to Alpine. So I'm going to type ALPINE. I'm going to hit enter. And as you can see, I logged in as root. So right now I have the highest privileges on the phone, and I can do whatever I want on the system. And now we can use system commands to completely control the phone. Now, this is a little bit ahead of time. We are still in the network hacking section, so don't worry too much about this. We'll talk more about it in the gaining access section, but it's just a quick example that I wanted to show you of how powerful information gathering is, because we literally did not exploit anything right here. We just relied on the information we gathered, and we were able to hack an iPhone that is connected to the same network as us. Now, like I said, Nmap is a huge tool. I highly recommend you go ahead and try the other profiles in here. And like I said, once done with the course, I think the Nmap book would be a really, really good read. We'll also use Nmap much more in the gaining access section, and we'll see how we can use this information to gain full control over the computers using code execution vulnerabilities and so on. But in this lecture, I just wanted to give you a quick overview, and we'll build up on this as we go through the course. Now, in this lecture and the next few lectures, I want to start talking about man-in-the-middle attacks. These are attacks that we can launch only if we are able to intercept the communication between two devices. Hence the name man-in-the-middle attacks. So a normal communication would look like this, where the device is directly communicating with the entity that they want to communicate with. In a man-in-the-middle attack, the hacker would be able to place themselves in the middle of the connection, allowing them to intercept and see anything that is being transferred between the two devices. Now, there are a number of ways to achieve this. The first method that we'll cover in this course is using an ARP spoofing attack. ARP spoofing allows us to redirect the flow of packets, so instead of it flowing as shown in this diagram, it would flow through my own computer. So any requests sent and any responses received by the target computer will have to flow through the hacker computer. This means that any messages, any websites, any images, any usernames, any passwords entered by the target will have to flow through my computer. This allows me to read this information, modify it, or drop it. So as you can see, this is a very serious and very powerful attack. And the reason why it is possible is because ARP is not very secure. Now, for us to understand how this works, you need to have a basic understanding of what ARP is. ARP stands for Address Resolution Protocol, and it's a very simple protocol that allows us to link IP addresses to MAC addresses. So, for example, let's say we have a network here. We have devices A, B, C, and D. They are all connected to the same network. And we have the router here for this network. We can see that each device has an IP and a MAC address. And let's assume that device A needs to communicate with device C. Now we're also going to assume that device A knows the IP of device C, but as we know so far, in order for these devices to communicate within the same network, device A needs to know the MAC address of device C, because like we said before, the communication inside the network is carried out using the MAC address and not using the IP address. So this is a perfectly normal situation where we have a client that needs to know the MAC address of another client so that it can communicate with this client. So what this client does, it uses the ARP protocol. What do I mean by that? Basically, it sends a broadcast message. So it sends an ARP request to all the clients on the network saying, who has 10026? Now, all of these devices will ignore this packet except the one that has this IP address, which is 10026, which is device C. So all devices will not do anything, and the only device that will respond is device C, sending an ARP response. In this response, device C is gonna say, I have 10026, my MAC address is this MAC address. This way, device A will have the MAC address of device C, and now it will be able to communicate with device C and do whatever task that it wanted to do initially. So all of this communication is facilitated using the ARP protocol. Like I said, the ARP protocol is a very simple protocol. As you can see, all it has is requests and responses, and the whole point of it is so that we can link IP addresses to MAC addresses or translate IP addresses to MAC addresses. So a device can send a request asking for a MAC address, and then the device that has the MAC address would respond with its MAC address. So each computer have an ARP table which links IP addresses on the same network to their MAC addresses. So if I go on the Kali machine and do ARPA, you can see my ARP table here, and as you can see, it's linking the router's IP to the router's MAC address. Now same if I go to the Windows machine and run my CMD and do ARPA, you'll see again it's linking the router's IP to its MAC address. So this machine, anytime it needs to send any request to the internet, it will direct that request to this MAC address, to the MAC address that's associated with the IP of the router, which is 10.0.2.1. Now, this value in here can be easily modified by exploiting the ARP protocol. So let me go back to my diagrams, and right here we have a diagram of a typical network, and you can see that normally any device that's connected to the network, if it wants to send requests, it will send them to the router will go and send that request to the internet, wait for the response, and then forward the response to the device that requested it. So if the hacker or the victim or any other computer on the network wanted to send a request, they will send that request directly to the router. Now what we can do is we can exploit the ARP protocol and send two ARP responses, one to the gateway and one to the victim. We're gonna tell the gateway that I am at the IP of the victim, so the access point will update its ARP table and it'll associate the IP of the target with my MAC address. We'll do the same with the victim, so we'll send it an ARP response. We're gonna tell it that I am at 10.0.2.1. So it's going to update its ARP table and associate the IP of 10.0.2.1 with my own MAC address. So the result of this, the victim is gonna think that I am the router, and the router is gonna think that I am the victim. So anytime the victim wants to send any requests, the requests will have to flow through my computer, and I'm gonna forward them to the router. And then anytime the access point or the router wants to send responses, they're gonna go to my machine because it thinks that I am the victim, and then I'm going to forward it to the victim. So as you can see, this puts me in the middle of the connection and it gives me so much power, and we'll see all the things that we can do once we become the man in the middle. Now, the main reason why we can do all of this is because ARP is not secure. Because first of all, clients can accept responses even if they did not send a request. So, as I said before, we're gonna send a response to the access point and a response to the victim, telling them that I am at a specific IP. Without them asking who am I, or without them asking for this IP, I'm just gonna send a response and they're gonna accept that response anyway. Not only that, but they're also not going to verify who I am. So when I say that I am at 10.0.2.7, I am clearly not at that IP because this computer is at this IP. But the access point will trust this and it'll actually update its ARP table based on the information that I send. Same goes to the victim. I'm gonna tell it that I am at 10.0.2.1. It's gonna trust and believe this even though I am clearly not at this IP because the access point is at this IP. So these are the two main weaknesses with ARP protocol that allow us to run ARP spoofing attacks. Now that we know how ARP spoofing works, let's see how we can run this attack and redirect the flow of data so it flows through our device. This will allow us to intercept data and see everything sent to and from a target computer, including usernames, passwords, and so on. Now, there are a number of tools that can be used to run an ARP spoofing attack. You can even build your own tool, and I cover this in my Python programming course. But in this lecture, I want to show you how to use a very simple yet reliable tool called ARP Spoof. Then, in the next lectures, we'll use a tool called BetterCap because it has more features. Basically, the main reason why I want to cover ARP Spoof in this lecture because it is a very simple tool, but it's very reliable. It's also ported to many operating systems, including iOS and Android. Therefore, if you learn how to use it here, you'll be able to use this tool on all of the other operating systems. So, you can only use this tool to redirect the flow of data and make it flow through your computer, and then you'll have to use another tool like a packet sniffer like Wireshark to analyze this data and do more stuff with it. And we'll cover all of this later on in the course. Now, using ARP Spoof is very simple. First, we're going to have to type its name, so it's ARP Spoof. Then, we're going to do -I to specify the interface that is connected to the target network. And in my case, it's ETH0 because that's the interface that's connected to the network. So if I do ifconfig, you'll see ETH0 is the interface that's connected. Now, as you can see, I'm going to be running this attack against my virtual NAT network. You can run this attack against any type of network, even Wi-Fi networks, and I will cover that later on in the course. But for now, just until you properly understand how this works, I highly recommend you do like I'm doing right now and test the attack against the virtual NAT network. So all you'll have to do is make sure the Kali machine and the target Windows machine are both configured to use the same NAT network. So we're going to do -T to specify the target, and my target is at 10.0.2.7. As you can see in here, that's the IP of my target. And I'm going to have to give it the IP of the gateway, which is at 10.0.2.1, as you can see in here. Now this will spoof the target, telling him that I am the router. We'll also need to run this command once more in here. So I'm going to clear the screen. And again, I'm going to do ARP spoof IETH0. And the target this time is going to be 10.0.2.1 and 10.0.2.7. So right now we're going to be telling the router that I am the victim. So the first one will fool the victim, the second one will fool the router. Now keep in mind, this attack will work against both Ethernet and Wi-Fi or wireless networks. I'm running it right now against the virtual network, which acts as an Ethernet or a wired network, but the attack can be executed exactly the same against wireless networks. All you have to do is connect a wireless adapter to the Kali machine, connect the adapter to the target network, and use it. So the same concept as the network scanner applies. You need to have a wireless adapter that works well with Kali, and you need to have that adapter connected to Kali and connected to the target network. So I'm going to hit enter here, and I'm going to hit enter here. And now, if we go to the target machine and run the same command, ARPA, you're going to see that the MAC address now for the router is different than what it was. And this is actually the MAC address of the Kali machine. So right now, this Windows machine thinks the router is at this MAC address, and every time it needs to send requests, it will send it to this MAC address, which means that they will be sent to this computer right here. Now, this computer is not a router, so when it gets requests, it's actually going to stop them from flowing and going to the router. This is a security feature in Linux. So you need to enable port forwarding so that this computer would allow packets to flow through it just like a router. Now to enable port forwarding, we're going to do echo 1 to proc sys net IP version 4 IP forward. And as you can see, this command gets executed with no issues. And right now, this computer will still have its internet access, so we can go and browse any website we want. But all these requests are not going directly to the router, but they are going to this computer first, and then this computer is forwarding them to the router as shown in this diagram, and then when the responses come back, they're gonna go to the hacker first, and then they go to the victim. So, as you can see, a very simple tool. It allows us to redirect the flow of data so it flows through our computer, allowing us to become the man in the middle. And once we're the man in the middle, we can inject code in the browser of the target. We can steal usernames, passwords, see all the information that the person sends and receives, replace downloaded files with Trojans, and much more. Previously, we learned what ARP spoofing is and how to use it to intercept connections in our network using a tool called ARP Spoof. I covered this tool because it is simple, reliable, and available for a number of operating systems. Therefore, learning how to use this tool can be useful in so many scenarios. However, in this lecture and in the next lectures, we're going to be using a tool called BetterCap. BetterCap can be used to do exactly what we did with ARP Spoof. So we can use it to run an ARP spoofing attack to intercept connections. And it can be used to do so much more. So we can use it to capture data and analyze it and see usernames and passwords. We can use it to bypass HTTPS and potentially bypass HSTS. We can use it to do DNS spoofing, inject code in the loaded pages, and so much more. For now though, I'm going to show you how to install the tool and give you a quick overview on how to use it. And we'll go over all of that in the next lectures. So I'm going to go to my Kali machine here, and to run BetterCap, all I have to do now is just type its name, BetterCap. Now, as usual, if you want to get more information on this command and how to use it, you can do --help, and this will give you a complete help menu. But you don't really need to worry about this now because we will be using the tool a lot throughout the course and you will learn a lot as you use it. So I'm going to clear the screen again. And to run the tool now, I'm going to type BetterCap, the name of the tool, followed by -iface to specify the interface that is connected to the network that I want to run the attacks against. And as you know, to get my interface, we can just do ifconfig. And I'm going to be running this against my NAT network, which is ETH0 is connected to. So I'm going to set my interface to ETH0. I'm going to close this. And I'm going to hit enter to run the tool. And as you can see now, we're inside the tool. We have a different prompt now in which we can use the commands of BetterCap. Now, as you can see here, it's telling us that we can type help to get a list of all of the commands that we can use with BetterCap. And since we don't know how to use it, I'm actually gonna type help. And perfect. As you can see, we get a full list of all of the commands that we can use. Again, I'm going to use it with you now as we go through the course, so you can have a quick look on them, but don't worry too much about them. What's really important and you need to pay attention to right now is the modules. So these are all of the modules that we can use, or all of the things that we can get BetterCap to do. And as you can see right now, none of them is working except for the event stream, which is basically the module that runs in the background to handle all the events. Now, you can type help followed by the name of any module you want. And this will show you a help menu that shows you how to use this specific module. For example, I want to show you in this lecture the net.probe and the net.recon modules. So, since I don't know how to use them, I've typed help and I'm going to follow it by the name of the module, which is net.probe. I'm going to hit enter, and as you can see, you'll get a description of what this module does. So basically, it keeps sending UDP packets to discover devices on the same network. And we can do netprobe on to turn on the module and net.probe off to turn it off. You can also see all the options that you can modify for this module, and I'm gonna talk about options and how to modify them in the next lecture. So for now, I'm gonna keep all these to the default option, and I'm just gonna do net.probe on to turn it on. And as you can see, this will automatically start discovering clients connected to the same network. So the 10027 right here is actually my Windows target machine. So if I go to the target Windows machine right here and do ipconfig, you'll see its IP address is 10027. So this is just another way of discovering connected clients quickly using BetterCap. And what you didn't notice right now is when we started the net.probe, it automatically started the net.recon. To confirm this, so if we go up right here, you can see the only module that was running is the events.stream. And now, if I do help, you'll see I actually have two modules running, the net.probe, which we just saw and we turned on manually, and the net.recon, which got turned on automatically by BetterCap. The reason for this is because the net.probe sends probe requests to all possible IPs, and then if we get a response, the net.recon will be the one detecting this response by monitoring my ARP cache and then adding all of these IPs in a nice list so we can target them. So now, because the net.recon is actually running, we can do net.show to see all of the connected clients. And as you can see, we get a nice list of all of the connected clients. We can see their IPs. We can see the corresponding MAC addresses for these clients. And it can also show you information right here about each one of these IPs. For example, it's telling us that this IP right here is the IP for ETH0. So this is the IP of this computer. It's also telling us that this IP right here is the gateway. This is the IP of the router. And you can also see at the vendor in here, it's attempting to discover the manufacturer of the hardware used in each of these clients. So as you can see for the gateway, it thinks that it uses a Realtek chipset. Now you can also see here the 10.0.2.7 device. Like I said, this is my target Windows device right here. So that's it for this lecture. I just wanted to give you a quick overview on how to get help about a specific module, how to run a specific module, and analyze the results that it returns. And in the next lecture, I'm going to show you how we can run an ARP spoofing attack using BetterCap to intercept the data and read usernames and passwords that flow through the network once we become the man in the middle, once we intercept the connection. Now, in this lecture, I want to show you how to run an ARP spoofing attack using BetterCap. This will allow us to place our computer in the middle of the connection and intercept data. Not only that, but we're also going to see how we can read this data so we can see all the URLs and all the websites that the target visits, and we'll see everything that they post. So anything, any usernames, any passwords they send to any websites, we're going to be able to capture them and see them. So first, we need to become the man in the middle, and we're going to do this using a module called ARP Spoof. So if I scroll up to the help menu, you can see we have a module here called ARP Spoof. So as usual, if we don't know how to use this module, we're going to do help arp.spoof because we want to see how to use this module and see all the options that we can set for it. So as you can see, as usual, we can do ARP spoof on to turn this module on. we can do ARP.ban on, and this will literally just cut the connection of the target. This is very simple. You can try it on your own time. I'm not going to do it here. You can do ARP spoof off to turn it off, and ARP.ban off to turn the ban off. Now, in the previous lecture, I also said anything you see under the parameters are the options that we can set for this specific module, but I didn't show you how to modify that. So in this lecture, we're actually going to be modifying some of these options. Now, as you can see, the tool is actually very helpful because first of all, it's given us the option name in yellow here. So these are the options that we can set, that we can change. And then it's also telling us a description of what this option does and the default value. So for example, we can see we have an option called arp.spoof.fullduplex. You can see the description for this option, and basically what this option will do, if you set it to true, it will spoof both the router and the target. So it's similar to what we did with ARP spoof when we executed the command twice to spoof both the router and the target. So if you set this to true, both the router and the target will be spoofed and you will be in the middle of the connection. If you leave it to the default, which is false, you will only spoof the target machine. Now this can be useful if the router has some sort of protection against ARP spoofing attacks because you won't be interacting with the router at all. But it's also limiting because we won't be able to do what I'm going to do in the next lectures because the router will communicate with the target device directly, so we won't be able to inject stuff in the responses that the router sends to the target device. Now, I actually want to change this to true, and the method I'm going to do this can be used to change any option in any module in BetterCap. So not only in the arp.spoof, if you're using any module, you can do help followed by the module name to get help about that module name. You can see all of the options that you can set in here. And then if you want to modify the value of any of these options, all you have to do is copy the option name, which is what I have right here, and type set followed by the option that you want to modify. And in my case, it's called arp.spoof.fullduplex, and I want to set this to true. So very, very simple. And like I said, you can use this command to change any option in any module in BetterCap. All you have to do is type set, followed by the option name, followed by the value that you want to set. So I'm going to hit enter, and that's done. If you don't see errors, that means it got executed properly. The next option that I want to change is the targets. So again, in the description, it's telling us that these are the targets that I want to run the attack against. And I can use a comma if I wanted to target more than one IP at the same time. So again, just like what I did before, I'm going to do set, followed by the option name, which is arp.spoof.targets, and you can actually use the tab to autocomplete. So if I just type TA tab, it will autocomplete the targets for me. And after this, I'm going to put the value that I want to set this option to, which is the IP of my target. And we can get this using NetDiscover, using ZenMap, or using the result that I got in here. After I run the recon module, I did net.show, and we got all of this, which is the list of all of the computers connected to the same network. And my target right now is this particular device, the 10027. This is my Windows virtual machine right here. So I'm going to put the IP 10027. And again, we don't see any errors, which means that everything got executed as expected. Now we're ready to run the tool. And again, based on the help menu that we got, we can do ARP spoof on to turn this module on. So we're going to do arp.spoof on. And perfect, as you can see, we see no errors. It's telling us that the module is running. And if I do help, again, we're going to get a list of all of the modules that are running right now. And as you can see, we can see that ARP spoofing is on. Also, it is very important that you make sure that the net.probe and the net.recon are running. We did this in the previous lecture. That's why I didn't do it now. So right now, BetterCap should be doing what ARP spoofing was doing, fooling both the router and the target device and putting me in the middle of the connection as shown here. So let's go to the Windows machine right here, and I'm going to do ARPA. And as you can see, the router's MAC address right here is the same as the MAC address for this device, which is the 10.02.15. And if I go back here to the Kali machine and do ifconfig, you'll see this is the same MAC address as the MAC address of the Kali ETH0 interface. So basically what this means is this Windows machine, every time it wants to send something to the router, it'll send it to the Kali machine. And because we set the full duplex option on in BetterCap, the router also thinks that this Kali machine is the target machine. Therefore, anytime it needs to send a response to the Windows machine, it'll actually send it to BetterCap right here. And like I said before, this means every username, password, URL, anything the target computer sends or receives will have to go through the Kali machine, where we're going to be able to read it, modify it, or drop it. And I'm going to walk you through that in the next lectures. In the previous lecture, we learned how to use BetterCap to run an ARP spoofing attack and place ourselves in the middle of the connection between a computer and the access point. And every time I do this, I keep saying this means that all the requests and all the responses will flow through our computer, which means that we'll be able to see anything a user does on the internet. So we should be able to see the URLs, the images, the videos, the passwords they log in with, or anything they send or receive. So right now, we are already in the middle of the connection, and this data is already flowing through our computer. So all we have to do is just use a program to capture this data and analyze it. Now we can use Wireshark to do that, and I will cover this later on in the course, but for now I'm going to use a really nice module that comes with BetterCap that will automatically capture all of this data, analyze it, and show me the interesting stuff. So all we have to do now is to tell BetterCap to capture all of the data that is flowing through this computer and analyze it for me. And to do this, we can use the net.sniff module. So you can do help followed by net.sniff to see all of the options that you can set for this module. But I showed you how to read options and change them. So for now, I actually want to run it without modifying any of the options. So I'm just going to do net.sniff on. So now everything that's going to flow through this computer will be captured and analyzed by the net.sniff module. So I'm going to close this terminal window and let's go to the target Windows computer. I'm going to open my web browser and we're going to generate some traffic and see if that's going to be captured by BetterCap. What we're doing right now will not work against HTTPS. But don't worry, we'll talk about how to bypass HTTPS later on and why this won't work. But for now, for testing, I'm just going to go to a website called VulnWeb. And I'm going to include its link in the resources of this lecture. So as you can see, this is a normal website that doesn't use HTTPS. It also has a number of links here. So if I click, for example, on this link, everything is loading fine, as you can see here. But if we go to the Kali machine, you'll see that every request that we sent was actually captured by this computer. So you can do this to any computer that is connected to the same network as you, whether it's a wired or a wireless network. So you can see there were requests sent to Google. If we scroll down, you'll see we made a request for this website, vulnweb.com. You can also see all of the other files that this website loaded. So you can see we have a logo loaded here. You can see we have a styles file being loaded here. Again, if there were more images, you'll actually see links to all of the images that are being loaded. You can see here, this is the second link that we clicked on, the testphp.vulnweb.com. So this is what we have right here in the top. Now also, let me just go back and maybe click on the first one. And as you can see, this is another website. It has a login functionality in here. And let's try, for example, log in with a username. Let's set the username to my name, Zaid Sabi. And let's put the password as 12345678990. I'm gonna click on log in. Again, as you can see, we got logged in, no issues at all. But if I go back to the Kali computer and scroll up, as you can see, we captured a login that was sent to this website, testhtml5.vulnweb.com. Again, this is exactly the website that we have here. And if you look in here, you can see that the username was Zaid Sabi and the password was 123 all the way up to 90. So basically the idea that I'm trying to get across right now, anything that the target computer sends or receives right now will be captured by the Kali machine. And like I said, we can do this to any computer or any phone that is connected to the same network as us, whether it's a Wi-Fi or a wired network. In the previous lectures, we learned how to use BetterCap to discover all clients on the same network, run an ARP spoofing attack to intercept the data, and then sniff data to see the usernames, passwords, and everything that's getting sent over the network. Now, in order to do this, we actually had to run a number of commands. So first of all, we had to do net.probe on to turn on the probe module. We had to set the settings for the ARP spoof module, turn that on, and then turn the sniffing module on. Now, every time you want to do this, every time you want to intercept data and see it on screen, you're going to have to do all of these steps that I showed you in the previous lecture. Or, if you're lazy like myself, you can use a caplet to do all of that automatically, which is exactly what I want to show you in this lecture. So, what do I mean by a caplet? Well, basically, a caplet is just a text file that contains all of the commands that you want to run. So, I'm going to resize this menu. I'm going to open a text file. And I'm just going to organize this a little bit to make it easier to follow. And I'm going to clear this window here. And I'm going to go to the first command that we had to run in order to do this. So again, scrolling up, the first thing we did was net.probe on. So in my text file here, I'm going to literally type this command, net.probe on. And as we saw, this will automatically start the net.recon module. Again, we enabled both of these modules in order to discover the connected clients and keep automatically discovering any new clients that connect to the network. The next thing that we did was modify the settings for the ARP spoof module. So we did set ARP spoof full duplex to true. I'm going to actually copy this and paste it here. Then we set the target IP. So again, I'm just going to copy this and paste it here. And keep in mind, this is very important. You want to make sure that you change the IP here to the IP of your target all the time. And if you are targeting multiple computers, you can just use the comma and type the next IP after the comma. Next, we turned on the ARP spoof module. So again, this is what I'm going to do here. I'm going to do ARP.spoof on. And finally, we also ran the sniffer by doing net.sniff on. So again, I'm just going to type this in here, net.sniff on. So this is actually a nice summary of what we did in the previous lectures. Again, like I said, every time you want to intercept the connections, you're going to have to start BetterCap and run all of these commands manually. You want to start the probe module. You want to enable the full duplex, so you fool or spoof the target and the router. You want to set your target IP, and you want to turn on the spoof and turn on the sniff. So, to make this very easy, instead of having to type this every time we want to run an ARP spoofing attack and intercept data, I put all of this in a text file. I'm going to save this text file. I'm going to put it in my root directory, and I'm going to call it spoof.cap. So I'm going to save this now, and I can close it because we're done with it. And we can go back here. And what I'm actually going to do, I'm going to exit out of this. So I'm going to quit BetterCap, and I'm going to clear the screen. And if I do ls to list all of the files and directories in the current working directory, because right now I am in root. So if I do ls, you can see we have a new file called spoof.cap. And just to confirm, if I go down to my file manager right here, you can see we have a new file again in the root called spoof.cap. And all we want to do is feed this spoof file to BetterCap before we start BetterCap. Now, we don't know how to do this, so we're going to do BetterCap --help to see all of the options that we can set with BetterCap. And what we want to do is use the -caplet option right here. So we're going to run BetterCap like we used to do. First of all, we do BetterCap, followed by iFace to specify the interface that is connected to the target network. And in my case, this is ETH0. So far, this is identical to what I've been doing in the previous lectures. The only difference now is we're going to use the -caplet option to specify my caplet file that I just created. So I'm going to do -caplet, followed by the file that I just created, which is called spoof.cap. And that's it. Now, before I hit enter, just to confirm to you, I'm going to go back to my Windows machine, and I'm going to do ARPA just to show you. And as you can see right now, the router's IP right here has this MAC address. So after I run this, it should automatically start all of the modules that I just typed, and it should run an ARP spoofing attack. Therefore, the router's MAC address should change to the MAC address of ETH0 that is connected to Kali right here. So I'm going to hit enter. And as you can see, we actually got an error, and the error saying the caplet spoof could not be found. So I'm suspecting I made a spelling mistake, and I did. As you can see, I actually named the caplet soof, not spoof. So I actually make a lot of mistakes like this. So I'm just going to rename this to spoof, and we're going to go back here. I'm going to exit and run the same command again. And perfect. As you can see, we got no errors at all. If I do help, as you can see, automatically we have the spoof is running. We have the probe, the recon, and the sniff all running as soon as we ran BetterCap. If you remember, the first time we ran it, we only had the stream running, and we had to do everything manually and set the options manually. So this is a really, really nice way of doing it. Now, let's confirm that everything is working as expected. So I'm going to go to the Windows machine and we're going to do ARPA again. And perfect. As you can see, the router's MAC address has changed to the same MAC address as the Kali machine. And the original router's MAC address, the correct one, was this. So this means that this Windows machine is now spoofed, thinking that the Kali machine is the router, and the router now thinks that the Kali machine is this machine. This will place Kali in the middle of the connection. And just to confirm this, just real quick, I'm already in VulnWeb. This is the website that we tested the login before. I'm actually even still logged in, so I'm gonna log out, log in again, and I'm going to leave the username to admin, and I'm just going to put a password again, 123490, enter. Let's go back, and perfect. As you can see, we wouldn't be able to get this if we were not in the middle of the connection. So the fact that we're getting all of this information means that we managed to intercept the data and see everything the target user sends or receives. And again, we have the username and the password right here. Like I said, this will only work with HTTP. We will discuss HTTPS in the next lectures. But in this lecture, I just wanted to show you an easy way of scripting the commands that you often run with BetterCap, because in the future, we're going to be doing a number of things that rely on us being the man in the middle. So, because I don't want to waste time enabling all of the modules that we're running here. So again, if I right click this and open with a normal text editor, all you'll have to do is just put your commands in a file, give a file a specific name, and then when you run BetterCap, all you have to do is just use the caplet argument followed by the name of your caplet file. Now, everything that we did so far will only work against HTTP pages. The reason why it works against HTTP because, as we've seen, the data in HTTP is sent as plain text, so it's text that humans like us can read and understand. That's why when we're the man in the middle, we're able to read this text, and if we wanted, we're able to modify this text as we wish. Now, this is obviously a problem, and this problem was fixed in HTTPS. So, as you know, most websites use HTTPS. The reason why, like I said, because it's a more secure version of HTTP, and basically the way it works is it adds an extra layer over HTTP, which is where the S comes from. So it's a secure HTTP protocol, and this extra layer will encrypt the plain text data that HTTP sends. So if a person manages to become the man in the middle, they will be able to read this data, but the data will be gibberish. It will not be readable to the person intercepting the connection. Now, HTTPS relies on TLS or SSL to encrypt the data, and this is very difficult to break. Therefore, in order to bypass this, the easiest method is to downgrade HTTPS connections to HTTP. So, since we're the man in the middle, we can check if the target is requesting a HTTPS website, and instead of giving him the HTTPS version of that website, we will give him the HTTP version. This way, the data will be sent in plain text and we'll be able to read it exactly as I showed you in the previous lecture. To do this, we'll have to manually configure and use a tool called SSL Strip. And I show how to do this in my more advanced courses. But luckily, BetterCap has a caplet that'll do all of this for us. The only problem is, this caplet does not replace all HTTPS links to HTTP in the loaded pages. So I modified this caplet for you to make sure that it's going to work as expected, and I've included it in the resources of this lecture. So all you have to do is download the zip in the resources of this lecture, and I have it downloaded in my Kali machine. So I'm going to go to my files and to my downloads, and I have it right here. It's called hstshijack.zip. I'm going to right click it and extract it here. This is the folder of this caplet, and I'm going to copy it and paste it in the correct location where BetterCap loads caplets from. So to go to that location, you can either press Ctrl and L on your keyboard to open the path bar, or you can press here and press a / again to open the path bar. Once the path bar is open, we want to go to USR, Share, BetterCap, Caplets. So like I said, this is the default location where BetterCap stores all of the caplets. I'm going to hit enter. And as you can see, we already have this caplet in here. But like I said, this caplet is buggy. It doesn't work as expected. So I'm going to delete it. So right click, move to trash. And I'm going to paste the one that I just copied in here. So that's it. We're good to go. We can go ahead and use this caplet from BetterCap. But before we do that, I also want to go to my home directory. This is where I stored the caplet that we created in the previous lecture, the spoof caplet, the one that will run the ARP spoofing command and then run the sniffer. And I just want to modify one thing in this. So I'm going to right click it and open it with LeafPad. And what I want to modify is I want to add an option to the sniff in here. So as you know, this line net.sniff on will turn on my sniffer, but before turning it on, I want to set the net.sniff.local to true. And what this option will do, it'll tell BetterCap to sniff all data, even if it thinks this data is local data. The reason why I set this option to true, because once we use the HTTPS bypass caplet, the data will seem as if it's being sent from our computer. So BetterCap will think these passwords belong to me, to my computer, and it will not display it to me on screen. That's why we're setting it to true, so that we can see all the usernames and the passwords sent on the websites that we will downgrade from HTTPS to HTTP. So I'm going to save this, Ctrl S and quit it, Ctrl Q, and now we are actually ready to go and use this caplet. So in the next lecture, I'm going to show you how to use this caplet to downgrade HTTPS connections to HTTP and therefore be able to sniff the URLs, the login information, and passwords that people enter on websites that use HTTPS by default. Okay, so now that we understand the theory behind bypassing HTTPS and we have the correct caplet placed in the correct path, let's go ahead and use this caplet with BetterCap and see how we can downgrade HTTPS to HTTP and steal passwords from login pages that use HTTPS by default. So I'm going to go to my terminal and I'm going to use BetterCap exactly as I've been using it before. So we're doing BetterCap, the name of the program. We're giving it our interface after the iFace argument. We're using the caplet argument to specify a caplet to run as soon as we run the program. And we're running the spoof caplet, the one that we built in the previous lecture, that will run the ARP spoofing command and run the sniffer for us. So I'm going to hit enter. And as you can see, everything got executed as expected. If we do help, we'll see all the running modules, and we have the ARP spoof and the sniffer running with the recon and with the probe. So this is exactly what we wanted from our caplet. The next thing that we want to do is run the HSTS bypass caplet, the one that we just downloaded and placed in our BetterCap directory. So first of all, The HSTS bypass caplet is one of many caplets that BetterCap comes with. If you want to list all of these caplets, you can do caplets.show, and as you can see, you'll get a list of all of the caplets that you have and their location on the system. Now, the caplet that we want to run is the HSTS hijack caplet, this one right here. And you can see it's stored in here. This is the location where we actually replaced it with the one that we downloaded. And to run any of these caplets, all you have to do is literally just type its name. And as usual, you can use the tab to autocomplete. So to run our caplet right here, all I have to do is literally type HS and press tab. And as you can see, it will automatically autocomplete for me and type the caplet name. Now, if I hit enter, this will load the caplet with all of its options and it will run it for me. So as you can see, because we don't see any errors, this means everything got executed as expected. So let's go to the Windows machine, browse some HTTPS pages and see if we can sniff data, usernames, passwords, and URLs that they enter on their computer. So I have my Windows machine here. I have Chrome installed. This is the latest version of Chrome at the time of recording this lecture, which is in April 2019. Now, a really good idea before trying all of these things is to remove your browsing data, because the websites that we're going to try to access might be cached and they might be just loaded from your cache. This will only happen if you're visiting the same website over and over again, mostly when testing. Therefore, it's a really good idea to Control-Shift-Delete and click on clear browsing data. Make sure all of this is clicked. Make sure it's set to all the time and click on clear to remove all of it. And let's go ahead and go to a website that uses HTTPS. So a good example would be LinkedIn.com. And perfect. If you look here at the top, you'll see the website is loading over HTTP, not over HTTPS. Therefore, we'll be able to see anything the user enters in these boxes. So let's put a username. Let's set it to zaid@zsecurity.org. And I'll put a password as 123456789. It doesn't really matter. You can use any password. And I'm going to hit enter to log in. This is wrong, so obviously we're getting an error message. But if we go back to Kali, as you can see, we're capturing all of this data because it's not being sent over HTTPS anymore. It's being sent over HTTP. And if you look in here, you can see we captured login information. It's sent to linkedin.com, sent to this specific URL, a login URL. And you can see the username is zaid@zsecurity.org. And the password is 123 all the way up to 90. So that's really, really good. Let's go ahead and test another HTTPS website. Let's go to stackoverflow.com. Again, you can see on top, it's loading over HTTP, not HTTPS. So I'm going to click on login. And again, I'm going to put my email, zaid@zsecurity.org, and we'll put a password as 123456789. Hit enter. And let's go to the Kali machine again. Scroll down this time because we're stuck on top. And perfect. You can see we have a post request in here. It's sent to this specific URL. Again, you can see login in the URL. You can see the website itself, stackoverflow.com. And if we scroll down a little bit more, we can see that the username is zaid@zsecurity.org. And the password, again, 123 all the way up to 90. So that is really, really good. Now we can downgrade any HTTPS connection to HTTP as long as the target website uses HTTPS, not HSTS. So this method will work against pretty much all websites that use HTTPS except for the really popular websites such as Facebook, Twitter, and so on. So let me show you a quick example. If I go here and try to go to facebook.com, you'll see that the website got loaded over HTTPS, not over HTTP, even though we configured our caplet correctly, and even though we're able to downgrade HTTPS connections on a lot of websites such as LinkedIn and Stack Overflow. This is happening because Facebook is using HSTS, which is a little bit trickier to bypass. In the next lecture, we'll talk more about what HSTS is, why it's tricky to bypass, and how to partially bypass it and still get usernames and passwords from the websites that implement it, such as Facebook, Twitter, and so on. In the previous lecture, we seen how to downgrade HTTPS websites to HTTP, and this allowed us to basically see anything a user does on these websites because data in HTTP is sent in plain text. Therefore, we were able to see the usernames, the passwords, the URLs, and anything they do on HTTPS websites. At the end of the lecture, I also showed you that the method will not work against Facebook, Twitter, and other websites that use HSTS. The reason why it won't work against these websites because modern web browsers come with a list of websites that they should only load over HTTPS. See, what we were doing in the previous lecture, whenever a browser requests a website, we load that website even if it uses HTTPS, but we always give him back the HTTP version. In HSTS, the browser knows that this website, for example, facebook.com, should always be loaded over HTTPS. So even before sending this request to us, it'll always send it in HTTPS, and it'll always only accept it if it comes back as HTTPS. So there's nothing we can do really once we become the man in the middle, because the browser is doing this check locally. It's checking this against a list that is stored on the computer itself. Therefore, the only practical solution at the moment to bypass HSTS is to make the browser think that it is loading another website. To do this, we're going to replace all HSTS links in loaded pages to similar links, but they're not the same links. For example, we can replace facebook.com with facebook.corn. Now, I know this seems very suspicious, but trust me, when it goes into the URL bar, the RN here at the middle, it'll seem very similar to the M letter. Another way of doing this, you can replace twitter.com with twitter.com, but with a single T here instead of a double T. I know this sounds a little bit confusing right now, but let me go and do it practically and you will see how this is gonna work. So, right here I have my Kali machine, and we're actually going to use the HSTS caplet that we used in the previous lecture. So I've already showed you where to download it and where to place it. Please make sure you use the caplet that I gave you in the resources of this lecture, not the one that comes with BetterCap, because the one that I gave you in the resources of this lecture is modified and it contains code that will actually replace the domain names as shown in here. The original one does not contain that code, so it won't work as I'm gonna show you right now. So, as shown in the previous lecture, I already have my caplet in here, in user share, BetterCap caplets, and this is the name of the caplet. If we go inside it, we have a file called hstshijack.cap. This is the configuration file of the caplet. So I'm gonna right click it. I'm going to open it with other application. I'm going to click on view all applications, and you want to pick any text editor that you have. So I'm going to keep this at LeafPad. You might have to scroll down to find it, but I have it here. I'm going to select. And as you can see, we have a normal text file with all the configurations that we can set. And I've already pre-configured this for you. The main things that you want to understand and maybe change is the targets and the replacements. So the targets are the domains that use HSTS that you want to replace. For example, I have twitter.com in here, and I also have star.twitter.com. Basically, when you use a star, this is a wildcard, and it basically means any subdomain .twitter.com is a target as well. In the replacement, you want to tell the program what to replace this target with. For example, whenever we see twitter.com, we're going to replace it with twitter.corn. Similar goes for Facebook and Apple and a few other domains that I set. You can also play around with the obfuscate and encode options. I've set both of these to false because basically what these will do, they'll obfuscate the code and encode it. But I noticed some browsers like Firefox will block obfuscated or encoded code. That's why I set both of these to false so that the code is left as is. Here in the payloads, you can set any other JavaScript code that you want to inject. Leave this the same. We'll talk about JavaScript injection in a future lecture. Finally, you want to make sure that the DNS spoof domains are set exactly the same as the replacements in here. So I literally copy this line and paste it here. Now I'm actually going to keep all of this the same. I don't need to modify any of it. But like I said, if you're targeting different websites or if you want to use different replacements, for example, if you wanted to use a Twitter with a single T and keep this .com, you can do that here. If you wanted to use a Facebook with a single O and keep this .com again instead of .corn, you can do it here. Once done, make sure you save and quit this file. And we're ready to run the attack. So running this attack is actually going to be identical to what we did in the previous lecture. You just want to make sure you modify this file properly. So going back to BetterCap, I'm going to clear the screen, run BetterCap with the same command, loading the spoof caplet so we can do all of the ARP spoofing commands and run the sniffer all automatically. And perfect, as you can see, everything is running as expected with no errors. If you run this and you get an error, just do exit and run BetterCap again. Next, we want to run the caplet, the HSTS hijack caplet, exactly as shown in the previous lecture. All we have to do is type hstab, it'll autocomplete for us, and hit enter to run it. Again, as you can see, no errors, so everything is working as expected. Let's go to the target machine and see how this is going to work. So I have my Windows machine right here. This is Chrome, the latest version in April 2019. And before I do anything, like I said, it's a good idea to always just remove the browsing data. And before I actually load any websites, it is very important to understand that even with everything that we're doing right now, if you try to go to Facebook and type .com at the end here, it will not work. What we're doing right now will not work because Chrome right here has a list that is stored on this computer that says do not load facebook.com unless it is loaded over HTTPS. So if you type Facebook right here like this, it will not work. The only way we can do this is if the user first goes to a search engine, for example, google.ie for Ireland. And then in Google, as you can see, Google doesn't use HSTS. So we bypass this using the normal HTTPS bypass. And then if the user in here searches for their target website, for example, Facebook, then our script is going to run in the background and it's going to replace all links in this page for facebook.com with facebook.corn. So if I actually hover over this, you'll see in the status bar, the website that will be loaded is facebook.corn, not facebook.com. This is fine here. It still says facebook.com, but only in the code of the HTML page, facebook.com got replaced with facebook.corn. So if I click on this link, again, as you can see, we get a normal Facebook page, but if you look here on top, you'll see there is no HTTPS. And if you look at the domain name, you'll see it says .corn, not .com. Again, like I said, you can actually keep this .com and use Facebook with one O, or you can add an extra O. You can be as creative as you want with this. This is just an example that I'm giving you. Now, if you did not get this, if you got an error page with a dial TCP error like this one, then please have a look on the video in the resources of this lecture. It will show you exactly how to fix this issue. Now, once we're here, we can log in normally with my username, so zaid@zsecurity.org, and put my password 1234567890. Hit enter, and if we go back, scroll up. Perfect. As you can see, we have the username zaid@zsecurity.org and the password all the way up to 90. Now, like I said, the only way for this to work is if the user gets to Facebook through another website that does not use HSTS. If they go on the URL bar and type facebook.com themselves, we will not be able to do this. That's why this is considered as a partial solution and not a full solution. Now, in this lecture, we're going to learn what DNS spoofing is and how to perform it. DNS is a server that converts domain names, such as google.com, to the IP of the server that is hosting this website. So, when you type google.com in your web browser, the request goes to a DNS server. The server responds with the IP where google.com files are stored, and the browser will load the website from this IP. Now, when we are the man in the middle, the request for google.com will pass to us first before it goes to the DNS server. Therefore, instead of giving the IP of the server that is hosting google.com, we can actually give any IP we want. So we can redirect them to a fake website with a backdoor or with evil code, hijack software updates, and so much more. We'll actually have examples on this in future lectures, but for now, let's see how we can run a basic DNS spoofing attack in which we redirect requests from a specific website to our own website or our own web server. Now, before we run BetterCap, let's decide on where to redirect our target to. So we can redirect them to any website we want. For example, when someone requests google.com, we can redirect them to Yahoo. But what I want to do is I want to redirect them to my own website, to a local website that I'm going to start on Kali. So Kali comes with its own web server, so we can actually use it as a website. And to do this, all we have to do is just start the web server. So we're going to do service Apache 2 start. So Apache 2 is the name of the web server, and we're saying that we want to start the service. If I hit enter, we see no errors, which means that the server is working now. And to access this website, to access this server, we have to go to Kali's IP. So as you know, to get our IP, we can do ifconfig, and we can see our IP is 10.02.15. So if I just go to a web browser and go to 10.02.15, you'll see I'll get the default page of this website. Now the pages for this default website is stored in var www HTML. So I'm going to open my file manager and I'm going to click here on the title bar, press / to open it, and we're going to go to var www HTML. And as you can see, these are the files for this website. So if you want to install a fake website or any type of website, all you have to do is just put its files in here. Now, index.html is the file that gets loaded here by default. So this is what you see in here. So I'm actually going to right click it. I'm going to open it with another application. I'm going to select my text editor. And this will open the HTML code for me. And I'm actually just going to remove this. And I'll just put a smiley face. Like I said, we're just doing this for testing. So just showing you which files get loaded by default and where you can actually put a website if you wanted to host a proper website here. So I'm going to go back here, and if I refresh the page, you can see we get the smiley face in here. Now that's perfect. Right now we still haven't executed our DNS spoofing attack, but what I want to do is when my target tries to go to a specific website, I'm going to redirect them to this page that shows this smiley face. So let's go to the target machine first. And let's go to our target website. I'm going to do this against my own website, zsecurity.org. So if you load this website, you'll see we'll get an actual security website with a number of topics and all that kind of stuff. Basically, the website is working as expected. Now, let's go ahead and run this attack. So I'm going to go to BetterCap. I'm going to run it using the exact same command that we've been using so far. So we're just doing BetterCap with the interface, with the spoof caplet, so we can intercept data and modify it as it's flowing through our computer. And as you can see, it's running with no errors, so that's all good. Now, the module that we want to use is called DNS spoof. So if I do help right now, you can see it right here. It's called DNS spoof and it's not running. And as usual, if we don't know how to use a module, all we have to do is do help followed by the module name. And in this case, it's DNS spoof. And as you can see, we get all the options that we can set for this module. First option being the DNS spoof address. This is the address that the user will be redirected to. So if you want to redirect them to another website, you have to put the IP of this other website here. In my case, I want to redirect them to my local website, to the website that we have here, which is running at 10.02.15. Therefore, I'm not going to have to modify this because by default, this is set to the IP of my interface. The next thing that we want to modify is the dns.spoof.all. We want to set this to true so that BetterCap responds to any DNS request. So, just like any other option within BetterCap, to change its value, we have to do set, followed by the option name that we want to modify, and in this case it's dns.spoof.all, and we want to set this to true. Sorry, this is all being produced by the sniffer. The next option that we want to set is the dns.spoof.domains. This will specify the domains that we want to target, that we want to spoof. And as mentioned, we can use a comma to separate more than one domain. And as you know, we want to target zsecurity.org and we want to redirect that to our own website running on Kali. So we need to change this option right here, dns.spoof.domains. And again, we're going to do this by doing set, the option name, which is dns.spoof.domains. And we're going to set this to zsecurity.org. As mentioned in the option, we can use the comma to specify more than one domain. And the other domain that I want to specify is star.zsecurity.org. So the star right here is a wildcard, and it basically means that I want to target any subdomain .zsecurity.org. So I'm going to hit enter and we don't see any errors. So everything is set as expected. And all we need to do now is start the DNS spoof. And to do this, we just need to run dns.spoof on exactly the same way that we start any other module. I'm going to hit enter and this should be running right now. And as you can see, it's telling us that it's going to spoof zsecurity.org to this IP, which is, again, this is our IP. We verified this using the ifconfig command. And keep in mind, we actually did not have to give Bettercap this IP. It got it automatically. It's also telling us that the other target is star.zsecurity.org, and it'll be spoofed to this. Now, let's go to the target machine and test this. And before you test this, please keep in mind, you might need to wait for a minute or two for the changes to propagate. Also, if you just loaded this website, just like I did right now, it's a good idea to remove all your browsing data. You won't have to do this in real life scenarios unless the target person is constantly loading the same page, which doesn't happen a lot. But if the target person goes ahead and browses a few websites, comes back to zsecurity.org, and perfect, as you can see, we got redirected to the smiley face instead of loading zsecurity.org. Now, this will work against all websites, even if they use HTTPS. As you saw earlier, zsecurity uses HTTPS and it loaded over HTTPS by default. The only websites that this will not work against are websites that use HSTS because, again, as I mentioned before, the browser has a list of these websites. The list is stored locally on the target computer, so it doesn't send any requests, and it'll only load these websites over HTTPS. So even though the attack will work, the browser will refuse to load the website that we are spoofing them to. Now, as you can see, what we did so far is not very useful. All we did is just we showed a smiley face. But DNS spoofing is very, very useful in so many scenarios. You can use it, for example, when someone is trying to go to a login page and show them a fake page, or if they're trying to go to zsecurity, for example, and then just show them another zsecurity website with some malware embedded into it. You can also use it to serve fake updates. So whenever they have a software that's going to check for updates, we can DNS spoof that request and send them a fake update with a backdoor. And we'll see that later on in the course. So it's a really, really handy skill that can be used in so many scenarios. So far, we saw a number of things that we can do once we become the man in the middle. So we saw how we can see anything a target computer does on the network. So we were able to see the websites, the usernames, the passwords, the images, anything they load on their browser. We also saw that since we're the man in the middle, we're able to redirect them to other websites. So whenever they request a domain, we can redirect them to somewhere else by doing a DNS spoofing attack. Another really cool thing that we can do is modify the HTML, modify the pages as they load on the target browser. Obviously, this is all possible because we are the man in the middle, because we're able to intercept all this data. So we can wait for the HTML code, which is the code that's responsible for loading web pages. And as it flows through our computer, we can insert any piece of code that we want, and the browser will execute this code. Now, HTML is only responsible for rendering the elements that you see on the web page. So it's responsible for the buttons, for the forms, for the text. It doesn't really allow us to do much. But modern browsers can execute JavaScript code. JavaScript is a powerful programming language that we can use to do so many things. We can actually modify the whole page, remove elements or add elements into the page. We can replace links, and this is actually what I did when I modified the HSTS plugin. So I added code that will replace the HTTPS with HTTP, and I also added code that will replace the actual link, the actual domain name, with the spoofed domain name, with the one with the .corn, or to whatever you set it to in the script. You can even use it to hook the browser to other browser exploitation frameworks, which we can use to further exploit the target and even gain full control over their computer. And we'll see that later on in the course. But for now, I'm going to show you how to inject a very simple JavaScript code into the loaded pages, and then we'll build up on that in future lectures and see how powerful and useful this can be. So, right here I have my Kali machine, and before I run Bettercap and show you how to inject JavaScript, first of all, we need to have some JavaScript code to inject into the target browser. So I'm going to open a text editor and I'm going to write a very simple JavaScript code. Like I said, we will see how we can use this to run more useful codes, but for now we're keeping this simple just to see how we can actually run JavaScript code. So all I'm going to do is alert, open a bracket, quotation mark, and I'm going to say JavaScript test. I'm going to close the quotation mark and close the bracket and add a semicolon. So right here, this code, all it's going to do is it's going to display a warning message, an alert message saying JavaScript code. So since we're going to try to inject this code into all pages, every time we load a web page, we should see a message saying JavaScript test. Now I'm going to save this. So I'm going to go to File, Save, and I'm going to put this in my root directory, and I'm just going to call it alert.js. I'm going to hit enter, and that is saved now in my root. So if I quit it, we can see we have the file right here. So this is the file that contains the code that we want to inject into any web page that loads on the target computer. The next step is to go to our HSTS Hijack plugin. So as I showed you before, this was in User, Share, Bettercap Caplets, HSTS Hijack. Make sure you use the one that I included in the resources, not the one that comes built in with Bettercap, because the built-in one will not work as you want it. So in here we have the HSTS Hijack.cap file. This is the configuration file for the whole plugin. So I'm going to right click this and open it with my text editor. And in here, what we want to modify is the payloads right here. So as you can see in here, it's already injecting a JavaScript file called keylogger.js, but we also want to inject our own code. So I'm going to add a comma here, and I'm going to add star followed by a colon. We added this star right here to say that I want to inject my script into any page that the target loads. If you want to inject your code into specific domains, then you can remove the star and just list the domains that you want to inject this code in right here. But like I said, we want to inject this into all pages, so I'm going to put this as a star, and after the colon, I'm going to put the location of the JavaScript file that I want to inject into the browser. So if we look back in here, this is the file that we just created, which is in root in my home, and it's called alert.js. So I'm going to put in here, I'm just going to say /root followed by alert.js. And that's it. I'm going to save this, Control S, and quit it, Control Q, and we are ready to go. So I'm going to go to my terminal. I'm going to run Bettercap using the exact same command that we've been using. So we're just giving it the interface as ETH0, and we're giving it our spoof file to automatically run the ARP spoofing attack, putting us in the middle of the connection. And as you can see, this is working with no errors, so everything is perfect. What I also want to do right now is run my HSTS Hijack plugin. And as you know, all we have to do is just type HS and tab. This will autocomplete. I'm going to hit enter, and everything is running with no errors at all. So everything is perfect. And as you can see in here, it's saying that the payloads it's loading, the JavaScript payloads, are the keylogger. This is the default one that the file already was loading, and the one that we just specified, which is in root alert.js. So now, anytime our target loads any web page, the whatever code we put in the alert.js should be injected in the loaded page, and it should get executed. The result of that should show us a simple message saying test JavaScript. So let's go to the target. And as usual, a good idea is just to remove the browsing data, just to make sure that nothing is cached. And I always like to first test with the simplest case and then move on to more complex scenarios. So first of all, I'm going to test it against a normal HTTP page so that there is nothing to bypass, no encryption whatsoever. So we're just going to go to vulnweb.com. And perfect, as you can see, we have an alert message in here telling us JavaScript test. So basically this means the JavaScript code in my alert.js file got injected into this page. So now that we've verified it works against normal HTTP pages, let's go ahead and test it against a page that uses HTTPS, such as stackoverflow.com. Perfect, it's working as expected. Another example would be linkedin.com. Keep in mind, these websites use HTTPS, and as you can see, we're able to load them with no HTTPS in here, so over HTTP only. So even if you log in right here, you'll be able to get the username and the password as shown before. Finally, let's go and test it against a HSTS website using the partial HSTS bypass method that I showed you. So for that to work, we'll need to go to Google first of all, and we need to go to a Google domain that does not use HSTS, similar to google.ie. This is actually the local Google website for Ireland. And as you can see, the code works. This is fine. Google only uses HTTPS anyway. But let's look for Facebook. Now we know Facebook uses HSTS, and because HSTS is used, we should not be able to inject anything on the website because the browser will only load it over HTTPS. But using our partial bypass method, if I click on Facebook from here, as you can see, the code gets executed because what we're loading right now is facebook.corn, not facebook.com. And as you can see, we get a normal Facebook page again that looks identical. And if you log in, you'll be able to get the username and the password. So as you can see, this will work against HTTP and HTTPS pages, and even HSTS if the target searches for that website, not if they put the domain name in here. So if the target comes in and literally types facebook.com manually and hit enter, the browser will force the HTTPS connection, as you can see in here, because like I said, it has a preloaded list of websites that it can only load over HTTPS. And because the browser is establishing a HTTPS connection, the data will be encrypted, and therefore we won't be able to inject anything in it. In this lecture, we're going to talk about a tool called Wireshark. Wireshark is a network protocol analyzer. It's not designed for hackers, and it's not designed for hacking and spying on other people on the network. It's designed for network administrators so that they can see what's happening in their network and make sure that everything is working properly and that nobody's doing anything bad or doing anything suspicious on the network. The way that Wireshark works is it allows you to select an interface and then logs all the packets or all the traffic that flows through that interface. So you're selecting an interface. It could be a wireless card, it could be a wired card on your current computer, and then it'll start logging all the information that flow through that interface. It also has a really nice graphical interface that allow you to analyze this traffic. So it allows you to filter these packets based on the protocol using them, like HTTP, TCP, and all that. It also allows you to look for certain things. For example, if you're looking for cookies, or if you're looking for posts or GET requests. And it also allows you to search through these packets. You can search through the information that's stored in the packets and find the things that you're looking for. It's a really, really big tool, and you need a whole course for it. So in this course, we're actually going to use it in a few lectures, just covering the basics or the things that's related to us. So the main idea here is Wireshark is not a hacking tool. It only allows you to capture the traffic that flows through your own computer, through your own interface. I'm going to use it now and it's going to become more clear to you. So I'm just going to go to Kali and we're going to start Wireshark. You can run Wireshark from the command prompt, or you can just go on all applications and type Wireshark and it'll show up right here. I'm going to click that and that's going to load the program for me. This is just a normal error. Just ignore this error. And this is the main interface of Wireshark. So first of all, you can actually just go to the file and go to the open. And in here, it'll allow you to open a file that you've already captured. So for example, if you captured packets using a different sniffer, using Aerodump or using Man in the Middle F or using T-Shark, which is the command prompt part of Wireshark. So if you captured packets using any of these programs and you stored it in a file, you can just come in here, open it, and start analyzing that file. This is really handy because sometimes you don't really want to analyze the traffic on the fly. So sometimes you just want to capture it. Sometimes you're capturing from small laptop or you're capturing from your phone and you're not even at home, you're in somewhere else doing your pen test, and then you go back home and then you want to analyze what you captured, then you can store that in a file and then just come here, go to the file open and open the file that you want to analyze. So what I want to show you here is the idea that Wireshark is not a hacking tool. It's not going to capture things happening in another device. It'll only capture things that flow through your own interface. So right here, we can see that we have all the interfaces in my computer. So we can see that we have ETH0, we have any, which is just any, and we have all the other ones that some of them are created by VirtualBox. So the main one here is ETH0, which is the virtual interface connected to my NAT network. And you can see that there is no traffic flowing through this. So you can see that this is constant and nothing's happening. So what I'm going to do now is I'm just going to make this a little bit smaller. And I'm going to open my browser here. And I'm just going to go to a normal website. I'm just going to go to google.com. Now, as you can see right here, you can see the traffic in ETH0 is spiking up. So there was some traffic generated through ETH0. So if we're sniffing on this, we'll be able to capture these packets that were sent over ETH0. Now, what I'm going to do is I'm going to go to my Windows machine just to prove that point. And I'm going to browse the website here. And you'll see that ETH0 will not be affected. And the traffic that's generated on this Windows machine, which is in the same network as the Kali machine, it will not be captured by the Kali machine. So if I just go to Google again here, you'll see that nothing happened in ETH0. So there is no traffic flowing through this. It's still constant. And we can only capture packets that go through ETH0. So now you'll probably ask then why Wireshark is so useful. Why are we even talking about it if we can only see things that go through our own computer? Why are we talking about it? Well, we're talking about it because we've seen there is a large number of ways that you can become the man in the middle. We learned how to do this using ARP spoofing, and in future lectures, I'm going to show you how to do it by creating a fake access point. So when we are the man in the middle, if we start sniffing on the interface that's used to become the man in the middle, we'll be able to capture all the traffic generated by the people that we're targeting in our man in the middle attack. So if you started a fake access point, you can start sniffing on the interface that's broadcasting the signal, and you can capture all the packets sent or received to anyone who's connected to that fake access point. If you became the man in the middle using ARP spoofing, then just select the interface that you used when you launched your ARP spoofing attack. So for now, I'm going to become the man in the middle using ARP spoofing. You can use ARP spoof or BetterCap as I showed you earlier, but I'm going to use BetterCap using the exact same command that we used to do. So we're literally just doing BetterCap followed by the interface that is connected to my target network, which is ETH0, and I'm launching my caplet, the spoof caplet, so that it configures the ARP spoof module and runs it for me to put me in the middle of the connection. So I'm going to hit enter. And as you can see, it's working as expected. So right now I should be in the middle of the connection, intercepting anything the target Windows machine sends or receives. Now let's go to the Windows machine and see if I do anything here, if it's going to affect the traffic in ETH0. So we'll see if Wireshark will be able to capture traffic generated by this computer. So let's write anything here. I'm just going to Google, or I'm just going to go to a different website. I'm just going to go to Bing. And if we come back here, you'll see that we have traffic being generated here. And we can see that ETH0 is actually capturing whatever that's happening in a completely different device. This is happening because when we are the man in the middle, all the packets that's generated by the Windows device is actually being redirected to my own computer right here, to the Kali. And then Wireshark is sniffing that from the Kali machine. It's sniffing it from my own local machine. It's not sniffing it from the network. It's not sniffing it from the target computer. So again, if you're doing this with the fake access point, then just listen on the interface that you're broadcasting. If you're doing this with a real wireless network, if you're connected to your home wireless network using LAN 0, then you can just do this with LAN 0. But with ARP spoofing, you have to first redirect the traffic, then you can use Wireshark. Now, this is just to show you what Wireshark is and how it works. And I just wanted to stress the idea that Wireshark is not a hacking tool. It's only a program that allows you to log packets flowing through a certain interface and then analyze these packets. So in the next video, we'll see how we can sniff and analyze packets using Wireshark. In the previous video, we seen how we can launch Wireshark, and we said that we can actually just open a file that contains packets that we already captured, and we can start analyzing them using Wireshark. In this video, I want to start sniffing packets and then generate some traffic in my Windows machine, and then we'll see how we can analyze these packets using Wireshark. So I'm already the man in the middle. As I said, you first have to be the man in the middle to use Wireshark. And then the traffic that's generated in the Windows machine is actually flowing through ETH0, as we've seen in the previous video. So before I start capturing the packets, I want to go to the options, and I just want to show you what options we can set. So first, you can see all the interfaces that you have, and you can see the traffic generated on them. And you can see ETH0 is actually generating some traffic every now and then because it's actually coming from the Windows machine. So in here, you can select the interfaces that you want to start capturing on. And you can actually select more than one interface. And all you have to do is just hold the control and then click other interfaces that you want to listen on. For example, we can just click them like this. But for now, I actually only want to sniff on ETH0. Now, if we go on the output, you'll see that you have an option to store these packets somewhere. So again, if you only want to sniff and you don't want to analyze things, then you can just go on the browse and you can store the packets that you're gonna sniff somewhere, and then you can analyze them whenever you have the time at a different time. You can just open them with Wireshark like I showed you in the previous video. You can just go on File, Open, and then open the packets and start analyzing them. Now, I have ETH0 selected, and I'm just gonna click on Start. And that will start capturing packets. Anything that's going to flow through ETH0 will be captured and it will be displayed in here. Anything. I mean, images, pictures, messages, cookies, anything that computer does on the internet will flow through ETH0 and therefore will be captured by Wireshark. So it's not like Man in the Middle Life where it was only showing us the important information. Right here, you'll see anything, all the traffic that's generated. Now, I want to go and generate some traffic on the target computer so we can analyze it here. But before I do that, I'm going to go back to BetterCap. And I want to start my HSTS caplet so I can downgrade HTTPS to HTTP, because if everything goes over HTTP, we won't be able to see or read anything because, like I said, everything will be encrypted. So I'm going to hit enter. This will work as expected. We'll go back to Wireshark and let's go to the target computer. I'm going to go to google.ie and let's search for something. So for example, let's search for Z-Security. And keep in mind, everything is loading over HTTP in here. So that's why we'll be able to read and analyze everything that we're loading right here. Now, let's go back to Wireshark and see how we can filter this information and discover the website's visit by the target, see the requests, and all that. So I'm going to click on the stop button to stop this. Now, this is the main interface of Wireshark, and you can see that the first thing we have is each one record of this is a packet. Now, you'll see here the columns. First of all, here is the number of the packet. So you have this one is number 1, number 2, number 3, number 4. In the time, you'll see the time when this packet was captured. So 0 is when we first started sniffing, and then the time increases as we go down, and it shows when these packets were captured, when they were sent, basically. You can also see the source. So this is the device that the packet was sent from. And you can see that this one is not sent from our target. It's actually coming from the internet, from a server that has this IP, and it's going to our target computer, which is 10.20.14.206. You can see the protocol. So it's TCP for this one. You can see that it's ICMP in this one, and you can see that it's ARP for this. You can see the length, which is the size, and you can also see info about this packet. Now, you can also notice that these packets have different colors. Usually green is TCP packets, dark blue is DNS packets, and if we go down, we should actually be able to find some of them. And you can see all of these are DNS packets. Light blue usually is UDP, but we don't have any UDP packets at the moment. And you can also see that we have some black packets, and these are TCP packets that had a problem, that had issues. Now, I know what you're thinking. There are so many packets in here, and a lot of them might not be useful to you, depending on what you're trying to get. But don't worry about this. In the next lecture, I'm going to show you how to filter these packets to only display the relevant ones, and then analyze them to extract the useful information. In this lecture, I want to spend more time with Wireshark, showing you how to filter all of these packets to only display the useful packets, how to trace them, what do they mean, and how to display more information about each one of these packets. Now, what we did on the target computer so far, most of the traffic that we generated was HTTP traffic. So to get rid of all this information that's hard for us to read, we're just going to type in here in the filters, we're just going to type in HTTP. Hit enter. And as you can see now, that filtered all the packets to HTTP traffic only. So this is the traffic that was basically sent by the browser and is usually sent by web browsers. They always send traffic over HTTP or HTTPS. And since we're downgrading HTTPS to HTTP, you want to use the HTTP filter to see everything that a target person is doing on the browser, regardless of what they're doing, whether they're browsing websites, whether they're watching a video, whether they're looking at images, whatever they're looking, it will be loaded over HTTP. So, looking at the first record right here, we can see that this request is sent from this IP, which is the IP of my target, to an IP on the internet. So we can see that this is not a private IP, this is an IP on the internet. So it's sent to a server. And if we double click this record, we'll get much more information about the packet itself. So we have the information about the frame, which includes the size of the packet. It includes the interface that it was sent on, the time, and all that. In the Ethernet, we have information about the source MAC address and the destination MAC address. So where did this packet go from and where did it go to? Remember when I first spoke about packets and how they always travel from a source MAC to a destination MAC. So this information is all stored in here. In the Internet Protocol, we have information about the IPs. So in the Ethernet, we had information about the MAC addresses. In the Internet Protocol, we have information about the source IP and the destination IP for this particular packet. In the transmission protocol, we have information about the port. So we can see that this went from this source port to port 80. This is usually the default port used on web servers. So in most cases, whenever data is sent to a website, it will always be sent to port 80. But the most important part in here is the hypertext transfer protocol, which is basically the data sent over HTTP. Clicking on this will give us information on whatever that has been sent over HTTP. And like I said, this would contain everything that was sent to and from a browser. So right here, we can see that this particular packet sent a GET request to a website called google.ie. Now, this is literally when we typed google.ie, we didn't search for anything. We didn't really do anything. You can also expand this to see more information about the actual request. And you can even see the HTTP header sent if you want to get more information about this particular request. Now, this whole method of getting information follows with all types of packets. So you can double click any packet you have and you'll be able to read the data sent within this packet. Now, you can also in here see an arrow, which basically means that this was a request. And the arrow back here marks that this was a response to this request right here. Now, moving down, you can also see requests for images. What you can also do is click on any of these packets. For example, again, back to this GET request, right click it and go to follow HTTP stream. And this will basically follow the stream that this request has caused all the way down to the response. So if I click it, you'll see the response for this particular request was this right here. You can see that this was a PNG, and literally the binary content of this PNG image is right here. So as you can see, we're literally getting the raw data in here. Now I'm going to close this and go back to what we had, which was HTTP. Now, if we keep going down, you literally see everything that has been sent and received by the target. So for example, again, in here, we can see this was a JavaScript file that was loaded by Google. Then in here, we can see another GET request. And this GET request was what we searched for zSecurity. So you can even see the search term in here. So let me double click this to show you in more details. Again, this automatically went to the hypertext protocol part. Like I said, this is the HTTP part, whatever that gets sent to the browser. And you can see that this was sent to google.com, first of all, and the URI, so whatever went after google.com was search, and what we were searching for was zSecurity, which is exactly what we typed in here. Again, in here, you can see the full URL with the search term. This is literally what the user gets in their URL bar in here. So as you can see, Wireshark literally shows everything that flows through the interface. In this lecture, I wanted to show you a quick overview on how we can filter data. And don't worry too much about this. We'll actually be using it more in the next lectures, and we'll see how we can easily use it to filter data and discover useful information. Now, in this lecture, I want to show you how to use Wireshark to discover data sent through forms whenever someone fills up a form. And obviously, this will allow us to get usernames and passwords if people log in to their accounts. So I'm already running BetterCap, so I'm already the man in the middle. And in Wireshark here, I'm just going to start a new capture. So I'm going to continue without saving this one. The filter is already set to HTTP, so it's only going to show me HTTP packets in here. And I'm going to go to a target website in here. So let's go to vulnweb.com. Now keep in mind, like I said, you have to be logging into a HTTP page, but that's fine because we already learned how to bypass HTTPS and even partially bypass HSTS. So I'm going to be logging into a website that just uses HTTP here because it's just simpler, and we've already learned how to bypass HTTPS and HSTS, so there's no point of repeating that. We're logging in with a username that is set to admin. I'm going to set the password to 123ABC. I'm going to click on login, and this should have been captured by Wireshark. Now let's go ahead and actually try this with a website that uses HTTPS. So let's go to stackoverflow.com. Again, as you can see, as long as the website gets downgraded to normal HTTP, then we'll be able to capture the data sent to and from this website. So we're just going to log in, put the username, we'll put it to zaid@zsecurity.org, and then we're going to put the password. So we'll just do 123ABC. And let's go back to Wireshark and see how we can discover the username and the password. So first of all, I'm going to stop the capture. And what we want to look for is post requests. So you see in here, this request right here was post, for example, and here it was get. Now forms are usually sent over post, especially login forms. So if you're looking for login information, you want to look for post in here. So going down, we can see we have a post request in here. Now I'm going to click here to actually show less information so it's easier for us to see. So you can see this post was sent to Google. We're not interested in that. We're looking for stuff that was sent to VulnWeb. So I'm going to keep going. We can see we have a post request here to a login page. So this is definitely interesting. Now if we look down, let me just make this smaller. So if we look down here and look at the HTML form data, you can see that we have a username here submitted to testhtml5.vulnweb.com. The username is admin and the password is 123ABC. Now if we scroll down again looking for post requests, you can see we have a post request for a page called users login. So again, very, very interesting. If we click on this, you'll see, if we scroll down, you'll see we have the email zaid@zsecurity.org and the password 123ABC. Again, this just goes to show you that with Wireshark, you'll be able to capture everything. Now this can actually be very, very useful because I noticed that BetterCap is great at sniffing passwords and it pretty much gets you the passwords all the time. But in the odd cases, sometimes it was failing to filter the username and the password for me. So with Wireshark, you'll actually be able to get everything that passes through your interface. So what you could actually do is you can just go to your caplet that we always use, the spoof caplet, this one right here, open it with the text editor. And as you know, in this caplet, we turn on our sniffer in here. So we set the sniff.local to true, and then we turn it on. But before turning it on, you can actually set the net.sniff.output to a location for a file that will contain everything that BetterCap captures. So you won't actually have to start Wireshark while BetterCap is working. You can just in here specify a place. So for example, let's say root capture file.cap. And then when you run your spoof caplet, it'll turn on the prop, turn on the recon, run your spoofing attack, putting you in the middle of the connection. It'll run the sniffer as well, and it'll store everything that BetterCap captures in a capture file. Then all you'll have to do is come here, go to File, Open, and open the file that you captured and analyze it as I'm doing right now. So this can be very, very useful also if you don't have a lot of resources on your computer, or if you had a small laptop or even a phone and you capture data with it. Store everything in a capture file and then just open it in here in Wireshark and analyze it. Now finally, before I finish this lecture, because all we're talking about right now is filtering data, a really useful feature when filtering data is the Control F feature, the find. So you can just press Control F from your keyboard. This will open this bar right here, the search bar, which you can use to find anything within the captured packets. So first of all, I'm going to set the search to search within the packet details. I'm going to keep this to narrow and wide. In here, I'm going to set this to string so that it looks for normal text. And for example, let's say I'm looking for logins that a person named Zaid has attempted. All I have to do is just type Zaid. And if I hit enter, and as you can see, it's taking us to the login attempt when I logged in to Stack Overflow. Or let's say you're looking for login attempts by a person named admin or for a user named admin. Again, if I hit enter, it's going to take me to the first time an occurrence of the word admin happened, which is in here. It doesn't really contain any useful information, but I can just click on find to find the next packet that contained the word admin. Again, this packet doesn't really contain anything useful. We can go next. We'll actually have to go to the end of the file and go up because that was the first thing that we logged in. So I'm just going to keep clicking on next. And right here we have the post request for the admin. And if we go down again, as you can see, we have the username as admin and the password as 123ABC. So this feature can be very useful to help you find what you're looking for, whether you're looking for a specific login name, whether you're looking for a specific tag, a specific file, and so on. Now, from the previous lectures, we know once we connect to a network, it's game over, because once connected, we can run an ARP spoofing attack to redirect the flow of packets so that they go through our computer. This allows us to become the man in the middle, and once we're the man in the middle, we can run so many dangerous and effective attacks. So we can spy on all the users, steal their passwords, redirect them to different websites, and this is all just a small taste of what you can do. You'll actually see us build on this in the client-side attacks section, where we're going to completely hack into computers connected to the same network as us. And if you go and do my advanced network hacking course, then you'll see more advanced attacks that'll allow us to do so many cool stuff on the network. And again, all of this is possible because once we connect, we can run ARP spoofing and become the man in the middle. Now in this section, I actually want to show you another method that'll allow us to become the man in the middle. And once we're the man in the middle, we'll be able to run all of the attacks that you've seen so far and all of the other man in the middle attacks that you'll learn in the future. So let's go back to the first diagram that we learned in this course. When we were talking about how networks work in general, we said the only device that has access to the internet is the access point, and whenever a client wants to access something, they send the request to the access point goes to the internet, gets the response, and send it back to the client. Now, what if we replace this access point with our hacker computer? So what if we can use our machine to create a Wi-Fi network that actually has internet access, so people will actually try to come in and connect to our network to access the internet, and then when they connect to our network, by default, we will be the man in the middle because we are the router. So we won't really need to exploit anything. We are automatically the man in the middle, and the clients will automatically send us any requests because they want to access the internet, and we will see these requests, obviously, go to the internet, get them what they want, and give it back to them. This way, we'll be able to launch all of the attacks that I showed you previously without the need to exploit the ARP protocol, so without the need to run ARP spoofing. All we'll have to do once our network is running and we have clients connected, we can just start sniffing using Wireshark or using man in the middle F. So, For this to work, you need a computer, and we already have our hacker computer with Kali Linux. You also need internet access, and you need a wireless device that's going to broadcast the Wi-Fi signal and tell all the neighboring devices that I am a network, you can come in and connect to me. So, you will need, first of all, an interface that has internet connection. This interface, it can be a Wi-Fi interface connected to the internet. It could be an Ethernet interface connected to an Ethernet network. It could be a 3G or a 4G dongle. And it even can be a virtual interface. And this is what I'm actually going to do. It's going to be my ETH0, the virtual interface that is connected to my NAT network. So this can be any network device as long as it has internet access. The next interface that you will need, like I said, it's gonna have to be a Wi-Fi interface because it needs to be able to broadcast the signal for the network. And you can't use any Wi-Fi interface. This interface needs to be able to act as an access point. So it needs to be capable of acting like a proper access point, like a router. Now, all of the Wi-Fi adapters that I recommend support this mode, and I've already included a video in the resources before when I first spoke about wireless adapters, but I'm also going to include this video in the resources of this lecture. So if you're going to buy one, or if you're not sure how to pick the right one, then check out this video. It should be helpful for you. So once we have this set up properly, we can use our computer to start an access point, and it's going to act exactly like a router. So people will be able to see the network when they look for Wi-Fi networks. They'll be able to connect to it and get internet connection. But when they connect, they will have to send us all of their requests because we are the router, we are the access point, so by default, we will be the man in the middle. Therefore, you'll be able to execute all man-in-the-middle attacks that you learned so far and any other man-in-the-middle attacks that you will learn in the future. So basically, ARP spoofing is one method of becoming the man in the middle, and what I'm going to show you right now is another method of becoming the man in the middle. Now, you can see that in order to use our computer as an access point, we need a number of components to be configured properly. So first of all, we need our wireless interface to broadcast the signal as if it's a real network. This will allow other clients to connect to it, but that's not the end of the road. The wireless interface needs to know when these clients are requesting websites. It needs to be able to forward these requests to the other interface that is connected to the internet. Then again, it will need to be able to know when the responses come back and forward all of this to the right client. Now you can configure all of these things manually, and I actually cover this in my advanced network hacking course, and I cover a lot of advanced things that you can do with the fake access point, like launching an evil twin attack, hacking into WPA2 Enterprise, and so on. But this would take at least 30 lectures, and this is not a network hacking course. This is a general ethical hacking course. Therefore, that would be out of the scope of this lecture. If you're interested in learning how to do this manually and how to run advanced attacks using the fake access point, then check out my advanced network hacking course in the bonus lecture, the last lecture of this course. For now, for this course, I'm going to show you a great way of quickly creating a fake access point that will allow us to become the man in the middle, similar to what's shown in this diagram. The tool that we're going to use is called Mana Toolkit, and it's basically a set of tools that allow us to automatically create a fake access point, automatically sniff data, bypass HTTPS, and so on. So the tool comes with 3 main start scripts. So the first one, start now upstream, will allow us to start a fake access point with no internet access. So this is not really useful for us, and I will not use this in this lecture. The next one is start not simple. This will start a fake access point with internet access. The third one, start not full, will start a fake access point with internet access, and it will automatically start sniffing data and bypass HTTPS. Now I actually always use start not simple. I never use start not full because this fails a lot of the times, and we already learned how to start sniffing and bypass HTTPS using BetterCap. So you can always start not simple. This will start a fake access point for you with internet access, and then you can open another terminal window, use BetterCap exactly as I showed you before, and you'll be able to sniff data and bypass HTTPS. You can also use Wireshark if you want to sniff the data and analyze them, again exactly as shown before. Now, before doing anything, I want to show you the network settings of my Kali machine. So I'm going to select it here. I'm going to go to Settings, Network, and as you can see, it's set to use a NAT network. So now if I go to my Kali machine and do ifconfig, we'll see we have an interface called ETH0. This interface is a virtual interface created by VirtualBox because we set this machine to use a NAT network. You can also see that this interface has an IP address, which means that it is properly connected to this NAT network, and it will provide the Kali machine with internet access as long as my host machine right here has internet access. So now on my Kali, if I go and let's say if I just go to bing.com on my browser, you'll see that I can successfully go to the website because Kali is connected to the internet through this virtual interface that is called ETH0. Now, if we go back to our diagram that shows what we need to create an access point, you can see that we need an interface that is connected to the internet. We don't care what type of interface this is, as long as this interface has internet access. So in our example, we're going to be using ETH0 to provide our fake access point with internet access. The other interface that we need, we said that this needs to be a wireless adapter that is able to act as an access point. Again, if I go back to the result of my ifconfig, you can see I already have a wireless adapter connected to this computer. It's called LAN 0. Keep in mind that this is in managed mode. It's not in monitor mode, and it is not connected to anything. So you can see it does not have an IP address. This is very, very important. It needs to be, first of all, in managed mode, and second, not connected to any network. So even if we go at the network manager in here, you can see we have wired connected. This is my ETH0, and Wi-Fi not connected. Once we have everything configured properly, you're ready to use Mana. And before we started, we should modify its settings. Mana's settings are stored in a text file. So to edit the settings, we're going to open this file and edit it using LeafPad, which is just a text editor. So I'm going to type LeafPad, followed by the location of the file that we want to modify. And the settings file for Mana is stored in etc mana toolkit hostapd mana.conf. So all we're doing with this command is we're using a text editor called LeafPad to open a file that is stored in this path. So when we hit enter, you'll see we have the text editor here opening the file for us. And all of these are the settings that you can modify for Mana. You can actually get a full list and a full description of all the settings that you can modify in this link. But we don't need this for now. The main thing that you need to modify is the interface. This is the interface that you want to use to broadcast the signal. So basically it is this component, and in my example this is going to be LAN 0. This is my wireless interface. So I'm keeping this the same. The next thing that you might want to modify is the SSID. This is the network name that will appear when people look for Wi-Fi networks. I'm going to keep this as internet, so when people look for networks, they will see my fake access point under this name. So I have nothing to save right now, but if you modified anything, make sure you save the file from File Save and then close it. And the next file that we'll need to modify is the start script. This is the file that will actually start MANA Toolkit for us. Again, we're going to use LeafPad to open and edit this file. So we're going to type LeafPad followed by the location of MANA's start script, which is in user share MANA Toolkit run MANA start not simple.sh. Now, in this file, there are two main things that you need to modify. The first one is the upstream interface. This is the interface that has internet access. So this is this component right here. And as we've seen before, this is ETH0 in my case. So I'm going to leave this the same. The next one, the PHY, is again the interface that is gonna broadcast the signal. So in my example, this is my wireless adapter and it is called LAN 0, not LAN 1. So I'm actually gonna modify this to LAN 0. Then I'm gonna save it, Control S, and quit it, Control Q. And that's it. We're ready to start the fake access point. And like we said before, we're going to be starting it using this script right here, the start not simple. That's why we modified it. So all we have to do is I'm going to copy this because that's its location. So in order to start it, because this ends with a .sh, we're going to do bash followed by the location of the script. So when we wanted to modify it using a text editor, we used a program called LeafPad followed by the path of the file. Right now, we don't want to modify it. We want to execute the code inside it. The code inside it is a bash script code. That's why we're saying I want to run this file using bash. Now I'm going to hit enter. And as you can see, it's telling me that the access point is enabled and I can press enter to kill the access point, so to exit it. Now, sometimes the first time that you run this script, it will not work. It will actually give you an error. So it's a good idea to actually just run the code again, literally the same command. If it fails, if it complains about a specific error, just run the command again and it might work. If it didn't work for the second time, then ask me in the Q&A section and we will respond to you and help you fix this issue. So now let's go and try to connect to this network and see if it actually works. So right here I have a Windows machine. It's another virtual machine, but I have another wireless adapter connected to this machine. Do not test this from your host machine because the fake access point is getting its internet access from the host machine through the NAT network. So if you test this network from the host machine, the network will not work. So either test it from another virtual machine with another wireless adapter, or if you don't have another wireless adapter, then you can test it from your phone or from another laptop or any other computer within range. But do not ever test it from the host machine. So right here, I'm going to search for networks to connect to. And as you can see, I have a network called Internet. It does not use a password, so I'm just going to connect to it. As you can see, I'm connected now, and I'm going to open Firefox just to check if I have internet connection. So I'm going to go to bing.com. And as you can see, bing.com is loading. So now I actually have internet access. So now anything I do on this computer will have to be sent to the access point. If I want to access any websites, if I enter any passwords and usernames, everything is gonna go to the access point. And the access point is the hacker machine. So the hacker machine is already the man in the middle. So now you're at the same position that you would be after running an ARP spoofing attack. So you can go ahead and use Wireshark to sniff packets and analyze them, or you can go and use man-in-the-middle F exactly as I showed you before. The only thing that you need to keep in mind when using Wireshark or man-in-the-middle F or any other tool, you need to set the interface to the interface that is broadcasting the signal. So this is the interface that you set in the PHY option, not in the upstream. So in my case right now, this would be LAN 0, not ETH0. Also, if you're going to use man-in-the-middle F, theoretically, you wouldn't need to use the --ARP --spoof argument, but I noticed that the tool will not work unless you add that argument, so you can add it in and you'll see that it will work exactly as shown before. Right, so let's talk about how we can detect ARP poisoning attacks. First of all, let me show you the ARP table. So in our Windows device, which is the device that we always attack, I'm going to run a command, ARPA, to list all the entries in the ARP table. So each computer has an ARP table, and that table associates IP addresses with MAC addresses. So we can see the IP address of the router, which is 10.20.14.1, is associated with the MAC address 52.54, and it ends up in 35.00. So this is the MAC address for the IP for the router. So the way that ARP poisoning works, like we discussed before, is it works because each request is trusted, and clients accept responses even if they didn't send a request. So what the hacker does is he sends a response to the client telling them that they are the router. So the client will accept that, it will trust it, and it's going to accept the response even though it didn't send a request. Then we'll send another response to the router telling them that we are the client. So what this is going to do, it's going to modify the entries in the ARP tables in both in the router and in the client. And for the client, it's going to contain the hacker's MAC address, and it's going to associate that with the router's IP address. So what's basically going to happen is it's going to modify the MAC address here, and it's going to change that to the attacker's MAC address instead of the router's real MAC address. So when that happens, then the hacker will be in the middle of the connection, and they'll be able to read, analyze, and modify the packets because they're going to be flowing through the hacker device. So let's run the ARP poisoning, a normal ARP poisoning attack like we always do it. And when I go back here, I'm going to execute the same command. So I'm going to do an ARPA again. And note how the MAC address is going to be different. So the MAC address for the router, it used to be this one. And when we ran the command, then the MAC address changed to this one. And this MAC address right here is the MAC address of the network card that the attacker is using. So if I come here and just do an ifconfig, you'll see that this is the MAC address, the same MAC address that is displayed in here. So this is the easiest and the simplest way to discover ARP poisoning attacks. It's not the handiest way though, because you're going to have to keep doing this command and keep comparing the entries if you really wanted to check if you're being ARP poisoned. So there's a tool called XARP, and it does that automatically for you, and it's available for Linux and Windows. So I already downloaded. You can just Google XARP and you can download it. Very easy to download and install. And I'm just going to run it. I'm actually going to stop the attack first. And then I'm going to run the tool. Now notice when you stop the attack, the IP address is going to go back to what it was. So you can see that the MAC address of the router is back to its default write value of the router. So I'm just going to run XARP now. And you can see that everything is good. And you can see that the entries are very similar to what we did when we did ARPA. So we have the IP addresses and the MAC addresses associated with it. What the tool basically does, it's just going to automatically monitor this. And whenever something changes, it's going to know that something's wrong is happening because each IP address should have a unique MAC address. There should be no duplicates in the network. So I'm going to do another ARP poisoning attack exactly like we did it before. And when we come here, you'll see that XARP is giving us a notification and telling us that something's happening. It's telling us that the MAC address for the router, which is the 10.20.14.1 IP, has changed from this to that. And if we look here, I'm going to click OK. And if we look here, we can see that the affected machines are the router, my own machine right now, and the attacker. Sorry, that's me, and that's the attacker. So basically, we know that the machine at 10.20.14.203 is trying to do an ARP poisoning attack because it's the one that the router's MAC address has changed to. Therefore, we know this is the attacker machine. So this tool is really handy because it does the monitoring automatically for us, and it will tell us whenever someone is trying to ARP poison the network. Okay, so now let's see how we can use Wireshark to discover suspicious activities in our network. And before I do anything, I'm going to go to the preferences. And I'm going to go to protocols, ARP. And I'm going to enable the option to detect ARP request storms. What this will do, it'll actually discover if anybody is trying to discover all the devices on the network, and it's going to give me a notification. So I'm going to click on OK, and I'm going to start my capture. And now I'm going to go to my Kali machine, and I'm going to use NetDiscover. So I'm not going to do ARP poisoning. I'm only going to try to discover all the connected devices to my network. So we're using exactly the same command that we used before, NetDiscover, interface, and the range. I'm going to hit enter. And we can see that NetDiscover finished. It discovered all the devices that we have. So if we come here, even before we look at the output of the notifications, let's just look at the packets that have been generated. You can see that there's a device here. This source is broadcasting, so basically it doesn't have a destination. It's asking all the other devices in the network, and it's inquiring about each possible IP. So it's basically asking who has this IP and tell the 67 IP, and then it's asking who has the 241 IP, tell the 67, who has the 251, tell the 67. And it's doing this for every possible IP. So it's basically checking if any possible IP in the range exists. And it's asking to return the response to the IP at 10.20.14.67. So from this, we can deduce that someone's trying to discover all the connected devices. And that someone is at 10.20.14.67. Now, if we go on the analyze and expert information, you'll see that we detected an ARP packet storm. So basically it means that there was a single device sending a very large number of ARP packets. So they're probably trying to discover connected devices or trying to discover connected ports. So it's telling us that this person is trying to do something suspicious. Now let's go, and I'm going to do a ARP poisoning attack, and we'll see if we can get any notifications or warnings in Wireshark. Now I'm going to go to Analyze, and expert info again. And if we look, we'll see we have a warning here. And the warning is telling us that there is a duplicate IP address configured. So again, this is telling us that the IP address of the router had two different MAC addresses. What this means, basically, it means that someone was tampering with this and tampering with our ARP table, trying to place themselves in the middle using an ARP poisoning attack. Now, we've seen a number of methods to detect ARP poisoning. Let's discuss how we can prevent it or protect ourselves from it. Now, I'm just going to run an ARPA, and we're going to look at our table. There is switches that will monitor this for you as well, and they'll notify you or even prevent ARP poisoning attacks. Another way to do that is, if you look at here, if you look at your router, you'll see that this entry in the table is dynamic. So the type of this entry is dynamic. What that means, it basically, this can change. It's the system allows this value to be changed. You can see right here, you have static values, which basically means the system will never allow these values to change. So you can use static ARP tables, which basically means that you'll have to configure each IP address. So you have to actually configure your ARP table and map each IP address to the MAC address, to the relevant MAC address. But once you do that, even if someone tries to send a response to your computer trying to change it, the system will refuse to change anything because you configured your ARP table to be static. The only problem with that is every time you connect to a network and every time there is a new device connecting to your network, you'll have to manually configure that device to work with your network. So it's not a very useful solution if you're in a big company or if you're in a big firm, but maybe in a small house or in a small company, then this would be a really good solution to prevent ARP poisoning attacks, because everything is going to be static. You're going to have to set it up manually. But when someone tries to do an ARP poisoning attack, even if their attack is successful and they use the best tools they can, your table is set up in a way that it's fixed. It can't be changed. So the system will always refuse to change the values of the MAC addresses, which will basically mean ARP poisoning attacks will never work against you.
In the previous lectures, we learned how to detect ARP spoofing attacks by manually analyzing the ARP tables. We also learned how to install tools such as XARP to automatically detect ARP spoofing attacks without having to manually check the ARP tables. And we even learned how to detect other suspicious activities using Wireshark. Now, this is really good, but still has a few problems. First of all, we're only talking about detection. So even when we detect that someone is intercepting the connection, we can't really do much. All we could do is simply disconnect from the network, maybe change its password if we can, if we own the network, to something that's more difficult, or if this is a public network such as an airport, a hotel, or a college network, then all we can do is simply just disconnect and use a different network because we can't change its password. The other problem with the previous methods, like I said, they're only detection methods. Therefore, they'll only work if the target managed to become the man in the middle using ARP spoofing. But what if someone is able to intercept the connection using another method? For example, if someone is running a fake access point, like I showed you earlier, and you connect it to this fake access point. Or if you connect it to a hotel, a college, a public Wi-Fi network, a cafe network, and the admin of that network is actually collecting data, or someone or a hacker gained access to the admin's computer and again is analyzing the data. Because by default in fake networks and in any network, the admin is able to see the traffic because the traffic will have to go through their server or through their router. So the detection methods that I showed you earlier won't even work against this. Therefore, in this lecture, I want to discuss two solutions to this problem. So the idea is you use these solutions if you discover that you're being attacked, or if you're connecting to a network that you don't own and manage yourself. So if you're connecting to a college network, an airport network, a cafe network, or any other network that you yourself don't have control over. The solution to all of this is to encrypt your traffic. If you encrypt your traffic, we don't really care if somebody is able to intercept this traffic, because our traffic is going to be encrypted, therefore it'll be gibberish and it won't be useful to anybody that is intercepting our traffic. So there are a number of ways to do this, and I'll explain how they work as we go through it. So let me show you this in action. Right here, I'm already running BetterCap, and as you can see, it's already getting information. And right here is my target, and we're already on VulnWeb. And if we just click on anything just to show you, you'll see the domain is going to be detected in here. And then let's just quickly log in. You'll see this login attempt will be detected. So we have the username is admin and the password is test. Again, if we try, I'll just open a new tab and go to Stack Overflow. You'll see it'll load over HTTP, not HTTPS. So again, if I go ahead and log in, I'll be able to log in and detect the password. And the HSTS method that I showed you earlier, again, it'll work and we'll be able to bypass that and steal the password. So right now, this Kali machine is able to intercept all the data that is sent to and from my Windows machine right here. So the first method to prevent these attacks, so we don't care if we're being attacked. Again, I'm not running XARP. I'm not managing my ARP tables. I don't care if someone intercepts my data. What I'm going to do is I'm going to install a plugin on my browser called HTTPS Everywhere. So I'm going to be installing it on Firefox. I'll include its link in the resources of this lecture, but there is an equivalent of this plugin for most browsers such as Chrome and others. All you have to do is simply click on Add to Firefox or Add to Browser, whatever browser you use. We're going to click on Add in here. And that's it. The plugin is added in here. As you can see, we're going to click on OK, and we can manage it here from its icon on the top right. So as you can see right now, it's set to off. And if I click this, I will turn on this plugin. And basically what this plugin will do, you can think of it as if it adds HSTS support to more websites, pretty much to any website that uses HTTPS. Therefore, for example, when I tried to access Stack Overflow in here, I was able to downgrade it because my browser does not know that this website should be loaded over HTTPS, and BetterCap was downgrading the HTTPS requests to HTTP, like I explained in previous lectures. What this plugin will do, similar to HSTS, it has a list of websites that support HTTPS, and therefore, when we try to downgrade the HTTPS connection of this website to a HTTP connection, it'll tell the browser, no, don't do that, and it will upgrade it again back to a HTTPS connection. So let me show you. I'm just going to delete the history, and I'm going to load Stack Overflow again. And perfect. As you can see, it's loading with HTTPS in here. Therefore, now if I go and log in, my information will be encrypted, and therefore the hacker won't be able to see my username and password. So that's really, really good, but not perfect. Let me tell you why it's not perfect. First of all, if we go back to a HTTP website, again, similar to what we have in here in VulnWeb, so I'm just going to log out. And we'll log in again with another password. I'll just put the password now to 12345678890. We'll log in. And if we go back here to the logs all the way down, you'll see we are still able to detect the username and the password. So this plugin is really good for websites that support HTTPS. It'll force us to load HTTPS on websites that support HTTPS. But if you access a website that only uses HTTP, such as VulnWeb, I know there aren't a lot of websites that do that, but they still exist. So if you access any website that uses only HTTP, then that website is still open to the hacker. So the hacker can still see this information. They'll still be able to steal usernames and passwords. if you send usernames and passwords to them. Not only that, but they will also still be able to replace downloads, serve you fake updates, or inject JavaScript code like we seen earlier and get you hooked to beef. HTTPS Everywhere also does not prevent the hacker from seeing the websites that you access and running DNS spoofing attacks. Let me show you. So if I just go to bing.com, for example, and then let's go to duckduckgo.com. Keep in mind, HTTPS Everywhere is still working. And let's go to the hacker machine and just look at our logs. So as you can see, we can still see that our target went to DuckDuckGo. We can still that the target went to Google. We can see that the target went to Bing. So we can still see the domain names, but we can't see the data that gets sent because that will be encrypted with HTTPS. So there is still some data that the hacker is able to get. If you want to take your security to the next level and completely encrypt everything you send and receive, then you should think about using a VPN. Therefore, in the next lecture, I'll explain to you what a VPN is, how it works, and how it can protect us from hackers or anybody that intercepts our connection. In the previous lecture, we discussed a good solution to protect us from man-in-the-middle attacks, and that solution was to use HTTPS Everywhere plugin. With this plugin, as seen earlier, we were able to force all HTTPS websites to always load over HTTPS. Therefore, if anybody intercepts our data, it'll be useless because it'll be encrypted with HTTPS. So this solution is really good. It's free. The only problem is, as you know, it only works with websites that use HTTPS. So we seen earlier, if you log in or use a HTTP website, your data is still exposed. Hackers or anybody that intercepts your data is still able to read your usernames, your passwords, or inject JavaScript code, serve you fake updates, and so on. Also, as seen earlier, with this plugin, the hacker or anybody that intercepts your data will be able to see the websites that you visit. Not only that, but they'll also be able to manipulate DNS requests, and therefore they'll be able to run DNS spoofing attacks. At the end of the previous lecture, I said if you want to take your security to the next level, then you should think about using a VPN. Let me show you what happens when we use a VPN, and then I'll explain it in more details to help you understand what's happening. So I'm back here at my hacker machine. As you know, it's already the man in the middle. I'm going to clear the screen, and I'm actually going to even turn off HTTPS Everywhere. Now, it's a good idea to use both at the same time, but I'm just going to turn it off just to show you the difference. You can use any VPN provider you want. It really doesn't matter. Most of them use more or less the same technologies. We at Z Security provide our own VPN service called ZSVPN. So I have it right here. It comes with no logs. We support all operating systems, Linux, Windows, OS X, Android, and iOS, and even Tails, which is a privacy-focused Linux distro. So, like I said, you can use anything you want. They all use more or less the same technology. What I want to highlight right now is what happens when you actually go ahead and use a VPN. So, I'm going to open my client and I'm going to connect to a server, one of these servers right here. And what this will do is it will establish an encrypted tunnel between my computer and the VPN server that I just connected to. Therefore, right now, let me show you. Let's just start. I'll delete everything. And let's start by going to some websites. For example, we'll go to google.com. Then we'll go to bing.com. And then let's go to Stack Overflow and make sure it loads over HTTPS. Now, keep in mind, I am not using HTTPS Everywhere, but you'll notice that it'll still load over HTTPS. As you can see, we're not able to downgrade it. And let's take this even one step further. Let's go to vulnweb.com. and just log in. So again, this is a website that only uses HTTP. It simply does not support HTTPS, but let's log in and see if we can still capture the data. So I'll just put my password now, 0987654321, log in, and let's go back to our Kali machine to see if we detected anything. Now, as you can see, we're not able to read any of the traffic sent to and from the target. So with the case when we used HTTPS everywhere, we were able to see at least the domains, the websites that the target visited, and we were able to see data sent over HTTP when we logged in to vulnweb.com. But in this case, as you can see right now, we can't see the username and the password even if they're sent over HTTP to vulnweb, and we can't see the domain names that the target visited. And the reason for this is because we are using a VPN, and like I said, a VPN creates an encrypted tunnel between our computer and a server, and all of our data will be sent through this encrypted tunnel. Let me explain this to you with diagrams to make it simpler. So, in general, let's say you try to go to google.com. Your connection will pass through a number of hops, but at the end, it's going directly to google.com. Hence the red arrow indicating that this connection could possibly not be encrypted, therefore your data might be at risk. Now, when you use a VPN, you connect to a VPN server in a certain country, and when you do that, you create an encrypted tunnel between your computer and the VPN server. So let's say you want to go to google.com. That request will first be sent to the VPN server. Now, the VPN server will be able to read this, but the data is sent in an encrypted tunnel. Therefore, if anybody intercepts this data, they will not be able to see what you are sending to your VPN server. That's why we don't even care if someone manages to intercept our connection, because our data is simply gonna be gibberish to them, as you can see in here. Then, once the VPN server receives your request, it will forward it to the destination that you're requesting, and the response will follow a similar route. Now, because of this structure, because of the way that the data is always encrypted between you and the VPN server, using a VPN can be useful in so many scenarios, because it adds an extra layer of encryption. Therefore, it improves our privacy and anonymity in general. It allows us to bypass censorship, because let's say your internet service provider is preventing you from accessing certain services or certain websites. They will not be able to know what these websites and these services are, because again, the connection is encrypted and they won't even know what you're doing. All they'll see is that you're connecting to a server in some country. And last but not least, it'll also protect us from hackers or anybody that intercepts our connection, again, because all of our data is encrypted. Therefore, we don't really care who intercepts this data. The data will be gibberish. Now, also because of this structure, you need to be careful when you pick a VPN provider, because this structure introduces the VPN provider as a man in the middle. So as you can see, we send everything to the VPN server first, and then it goes to the internet. And the VPN server is able to decrypt this data, because the tunnel, the VPN encryption, is only used between our computer and the VPN server. So if the admin of the VPN server wanted to analyze your data and see what you send and receive, they will be able to do that. Therefore, you need to make sure that you pick a reputable VPN provider, a company that you can trust. You want to stay away from free providers, because providing a VPN service is very expensive. Therefore, if someone's able to give it to you for free, they must have another angle or another reason of why they are giving this for free. You want to make sure that the VPN provider keeps no logs, and with all of that, you can use HTTPS Everywhere plugin with the VPN. If you do that, you will actually fix the problem of the data leaving the VPN server, because your data will be encrypted between your computer and the VPN server with 2 layers of encryption. First, using the VPN encryption, and second, using TLS because of HTTPS everywhere. Then, data leaving the VPN server will be encrypted with 1 layer of encryption, which is the encryption enforced by HTTPS everywhere. Therefore, even though the VPN provider is able to see your data and able to decrypt the encryption used in the VPN tunnel, they will still not be able to see your data because it will still be encrypted with TLS. So this basically solves the problem of the VPN server being able to see your data, because at the VPN server, your data will still be encrypted with TLS. So, to summarize the 2 methods that we covered to protect our data from man-in-the-middle attacks, with HTTPS everywhere, it's great, it's free. The only problem is it only works with HTTPS websites. The person intercepting the data will still be able to see the websites we visit, and they will still be able to run DNS spoofing attacks. Then we spoke about using a VPN, and with using a VPN, everything gets encrypted, so that's even better. None of the attacks that we talked about and that we covered in this course will work because everything gets encrypted. The only problem is it's not free. There are free services, but like I said, they're not great, so you shouldn't use them. Just don't use a VPN if you don't want to pay for it. The other problem with the VPN is that the VPN provider can see your data, so you're introducing a man in the middle. But we can take this one step further and use HTTPS everywhere with a VPN. And with that, we're getting all of the benefits of using a VPN, so everything gets encrypted, protect us from all man-in-the-middle attacks, but without the problem of the VPN provider being able to see our data, because our data will be encrypted with 2 layers. Therefore, even the VPN provider will not be able to see what we send or receive, because it'll still be encrypted with TLS. So the only downside to using HTTPS everywhere with a VPN is the fact that you have to pay for the VPN service.
Now you have enough information to go ahead and try to gain access to other systems, to computers, servers, web servers, and stuff like that. And in this section, we're going to be talking about gaining access to computer devices. And what I mean by computer devices is anything. And the reason behind this, I want to get this through, I want to get this idea through, is that any electronic device you see is a computer. So a phone, a TV, a laptop, a web server, a website, a network, a router, all of these things are computers. All of them have an operating system, and they have programs installed on these operating systems. And usually, in most cases, these computers are used by a user. So you have an operating system, they have programs installed on that operating system, and they have a user who uses and configures this system. So I'm going to be talking about how you gain access to computers in this example, an actual personal computer. So the name that people call it usually, a computer. So it's going to be, we're going to have a target of a Windows device, and we're going to have a target of a Linux device. But the concept is always the same. Getting access to computer devices is always the same. So you can apply the same concepts if you are targeting a phone, if you are targeting a tablet, if you're targeting a web server. And we will be targeting web servers as well. But I will be talking about it just like a normal computer. This is very important to understand. Every device you see is a computer, and it works just like your personal computer. So I can set up a web server on my computer. I can make it look like a website and act as a website. I can make it act as a TV, and I can make it act as anything I want. And literally TVs and all these things are just simpler computers with less complicated hardware in them. So we're going to be talking about attacking these devices from 2 main parts, or from 2 main sides. The first approach that we're going to use is the server side. So in this side, it doesn't require any user interaction. We're going to have a computer, and we're going to see how we can gain access to that computer without the need for the user to do anything, for the user who uses that computer to do anything. This mostly applies to web servers and applications and devices that don't get used much by people. So people basically configure them and then they run automatically. So all we have is going to be an IP address, and we're going to see how we can test the security and gain access to that computer based on that IP. So our main way of getting in is going to be the operating system that target runs and the applications installed on that system. The second approach that we're going to try is the client-side attacks. So this approach will require the client or the person who uses that computer to do something. To do something, that something could be a number of things. It could be installing an update. It could be opening a picture. It could be opening a Trojan. So we're going to learn how to create a Trojan, how to create backdoors, how to use social engineering to make the target person do something. And when they do that action, we will gain access to their computer. Information gathering is going to be crucial in this case because we actually need to know the person that we're targeting. After all of that, I'm going to talk about the post-exploitation. So what you could do after you gain access to this computer, regardless of the method that you gained access to it. So you could have used a server-side exploit, you could have used a client-side exploit, or you could have just got a physical access. The person left their desk and you got in. So we're going to see what can you do once you have access to your target, how you could further exploit that target and increase your privileges or target other computers in the same place.
Now, in the next lectures, we're gonna start talking about server-side attacks. I'm gonna teach you what a server is, and we're gonna talk about that in details. But before we jump into this, we need to have a computer or a machine that acts as a server so that we can try to hack into it. So similar to the way that we had a Windows machine to practice attacks that we can launch against normal users, we need to have another virtual machine that behaves like a server so that we can practice server-side attacks against it and see how we can hack into servers. So the machine that we're going to use is called Metasploitable, and it's a virtual machine that's built on Linux, and it contains a number of services that's typically used by servers. It also contains a number of web applications that act exactly like normal web applications and use the same technologies used by normal servers and normal web applications. So we're going to install this machine, and then in the future, we're going to use it as a target to learn how to hack into servers and how to hack into websites. You can download this from the following link. Now, I've also included this link in the resources of this lecture, which you can access from the top left of each lecture. If you click on this link, you'll get this page, which will allow you to download Metasploitable. Before you can download it, you're going to have to fill your information in here. So I'm just going to fill up anything for a company and anything for a phone number. Now, one thing I'd like to note, when it asks you for your email, if you use a normal Gmail account like this one and tries to download, you'll see that it's going to say this must be a valid company email. So if you do not have a company, you can use a fake email in here. All you have to do is just write a name at any company name you want. So I'm just going to say zaid@imaginarycompany.com. Now don't use imaginary company as well, because I don't want a lot of people using the same fake email. But the idea is you just want to use a name at someothername.com, and this will allow you to bypass all of this. And once you click on submit, you'll go to the download page, and if we click on download Metasploitable now, it'll download it for me. Now once it's downloaded, you're gonna have a zip file, and I've already downloaded this, so I have the zip file right here. Sorry, not this one, like this one. So once you uncompress it, you'll get this directory. Double click it, and you'll see the following files. So we're gonna create a new machine here in virtual machine. And I'm going to call it Metasploitable. And this is going to be a Linux machine. And I'm going to hit continue. And I'm only going to give it a gigabyte of RAM, should be enough. And then I'm going to use, remember with Kali Linux, we created a new virtual hard disk. With this, we're going to use an existing one. The reason for that is because the image that we have right now is actually, it's designed for VMware Player. So what we're going to do is we're going to import the hard disk file or the hard disk image in here so that we're going to have a ready installation without having to install it the way we installed Kali Linux. So we're just going to use an existing virtual hard disk file. And I'm just going to navigate to select what it is. I'm going to go into the Metasploitable directory and I'm going to select the .vmdk file. So it's this file right here. I'm going to click on open and create. So we're going to start this machine right now. Okay, so the machine has run now. It's completely installed. As I said, you don't really need to install anything. We just imported a ready installation, a ready hard disk. So it's asking me for the username. And the username is msfadmin. And the password is the same, so it's msfadmin as well.
Now you might notice, once you start typing the password, you'll see nothing displayed on screen. This is a security feature so that the password is not visible to people beside you. So once you get asked for the password, type msfadmin and then hit enter. Now I've actually already typed it, so now when I hit enter, you'll see it's gonna log me in. Now this machine only has a terminal interface, as you can see here.
And it's giving you a warning that you should never expose this machine to external internet connection because it is a vulnerable machine. It is designed to be vulnerable. Now, right now, it's only inside our lab. It's only installed as a virtual machine. So literally nobody outside our lab can access it. So this is a really good way of using it. Now, this is it. The machine is installed. As I said, in the future, we're going to talk about how we're going to try and hack into this machine. Again, don't be intimidated by the terminal. We're going to be using it a lot and we're going to learn how to use it step by step. So at the moment, we have this installed and we're going to move on to the next step. And we will talk about this once we actually need to use it in the future. So if you want to turn off this machine, all you have to do is just type in power off and hit enter. And it's telling you that you need to be root. So again, I'll talk about this later. For now, sudo power off. So just run the command like this. And it's asking you for the admin password. And that's it. It's going off now. And here we go. The machine is off. So the first thing we're going to look at is the server-side attacks. And again, these are the attacks that don't require user interaction. You can use these attacks with servers, so web servers and stuff like that. And you can also use it against normal computers that people use every day. The reason why I'm going to be using it against an application, against my Metasploitable, which runs Unix and which is more of a server than a normal personal computer, is because if your target uses a personal computer and if they're not on the same network as you, then even if you get their IP address is going to be behind the router. So they'll probably be connecting through a router. And therefore, if you use the IP to try and determine what operating systems run on it and what applications are installed, you will not get much useful information because you're only going to be getting information about the router and not about the person because the person is hiding behind the router. Whereas when you're targeting a web server or a server in general, then the server will have an IP address, and that IP address, you can access it directly on the internet. So this attack or these ways of gathering information that we're going to look at now will work if the person is on the same network and if the person has a real IP. So if you can ping the person, even if it's a personal computer, if you can ping it, then you can run all of the attacks and all of the information gathering methods that we're going to explain now.
So in my example, I'm going to be targeting my Metasploitable machine here. And before I show you anything, first of all, I want to show you the network settings. So it's set to NAT, and it's on the same network as my Kali machine. So the Kali machine is going to be my attacking machine. And again, on the network, it's set to NAT network, and it's on the same subnet. Now, this is very important. So in here, if I do ipconfig, or if I do ifconfig, sorry, you'll see that my IP is 10.20.14.204. And if I go to my Kali machine, I should be able to ping it. Now, if I can't ping it, then we won't be able to do anything. And as you can see, we're getting responses back from the machine. So we are connected to that machine and we can get responses from it. Therefore, we can try and test its security. So again, you can use these attacks and you can use these approaches against any computer that you can ping. So if it's a personal computer or if it's a server of any kind, as long as you can ping that direction or you can ping that person, then you can use these attacks and these methods that we're going to talk about in the server-side attacks. So it's going to work against websites, web servers, people, normal computers, as long as you can ping them. And just to convey this idea, now we see the Metasploitable machine right there. So it's just a normal machine. It's a normal virtual machine that I can use right here to do anything I want. I can list, I can even install a graphical interface, and then I'll be able to do, just use it just the way I use my Kali machine. But at the same time, it has a web server. So if I try to navigate to it from here, you'll see that I actually have a web server here, and it has websites that I can actually read and browse. And we're actually going to have a look on these websites and see how we can pen test them in the future. So everything is a computer. If you can ping that IP, you can use the server-side attacks. It mostly works against servers because servers always have real IPs. And also, if the person is in the same network as you, then you can ping them and you can do all of these attacks as well. Right, so the first step into the server-side attacks is information gathering. Information gathering is very important because it will show us the operating system of the target, the installed programs or the running services on the target, the ports associated with these services. Now, from these installed services, we can try and get into the system. We can do this by trying the default passwords, and we've seen this before in the network penetration testing part, where the iPad had a SSH service installed, which basically give you full access to the computer if the person still uses the default password, which was Alpine. So we can do this with any other service, and we'll see another example here today. Another thing that we can do is there's a lot of people install services and misconfigure them. So we'll have another example of this. So sometimes a lot of these services are designed to give some remote person some access to that computer, but they obviously need to have some security implementations. People often misconfigure these services, so we can take advantage of these misconfigurations and gain access to these computers. Another problem with these services, some of them might even have backdoors, and we'll see an example of that. And a lot of them would have vulnerabilities such as remote buffer overflows or code execution vulnerabilities that allow us to again gain full access to that computer. Now, the simplest way on doing this is something that we've seen before, which is using ZenMap. So we use ZenMap using the IP. We get a list of all of these services and then Google maybe each one of them and see if they contain any vulnerabilities. Now, we've seen how we use ZenMap before, but I just want to convey the idea of anything is a computer, and we've seen before how the Metasploitable device, this device is actually a website. It has a web server running, so websites are nothing different than this. If you want to get an IP of a website, all you have to do is just do a ping. So, for example, if we're targeting Facebook, so all we have to do is do ping facebook.com. And we'll get their IP right here. So we have Facebook's IP, and we'll be able to run ZenMap against it and get a list of all the running services on Facebook. Now, obviously, I'm not going to do that because I'm not allowed to do that. What I'm going to do is I'm going to run ZenMap against this Metasploitable device, which basically is a computer device, and that's what we're interested into testing. So Again, I can't really stress this anymore. Anything is a computer, whether it's a website, a server, any online service, a phone, anything is a computer. So you can go about penetration, anything the same way. So I'm going to run ZenMap just the same way that we did before. So I'm going to go on my activities. I'm just going to look for ZenMap. And here's ZenMap. And I'm going to put the IP of my target of the Metasploitable device, which was 10.14.04. So remember, in the network penetration testing part, we used to put the base IP and put it over 24 to cover all the IPs around us in the network. In this case, you might be testing a remote IP. So for example, in the Facebook case, all you have to do is just put the Facebook target IP in there and test it. Now that's granted that you have permission to do that. Now I don't have permission, so I'm not going to do that. What I have permission to do is test my own device, which is installed on the same network as me. So that's why I'm putting that IP. But you can literally put any IP you want in there and test it. So I'm going to hit on scan. And this will give me a list of all the installed applications. Okay, so the scan is finished now. And we have a lot of open ports, a lot of services. What I advise you to do in this case now, if you want to do a simple test, is you literally go on ports, port by port, read what it is, and Google the name of the program. So for example, we have port 21 here. That's an FTP port. FTP is a service that it's installed to allow people to upload or download files from the remote server. So we can see usually FTP services use a username and a password, but you can see that this service has been misconfigured and it allows anonymous FTP login. So unlike the SSH that we used before in the network penetration testing, we used the default password. With this, you'll be able to log in without a password. So all you have to do is download an FTP client such as FileZilla, and you'll be able to connect using this IP address on port 21. Now I'm not going to explain this because it's very simple. You literally download the application and connect to it. What else you can do is you can Google this. This is an FTP server. You can literally Google this and see if it has any issues, if it has any misconfigurations, if it has any known code execution exploits. So I know if you Google this now, this particular application has a backdoor installed with it. So it literally came with a backdoor when it was released. For now, I'd like to show you something simpler, just so that we make this shorter. So, as I said, you need to go in one by one, Google in the services, and check in if they have any misconfigurations or any exploits installed, or if any known exploits. So what I'm going to do now is I'm going to have a look on the 512. So let's assume we went on them one by one. We couldn't find anything and we reached the 512 TCP port. So I'm going to copy this. This is the service that's running on this port. So literally, I don't know what's this. So I'm going to copy it, go on Google and Google it. Okay, so we're going to have a look on the first result that we got here. And we can see that this is a remote execution program. So that's very nice. That's very cool. So if we manage to log in with this, we'll be able to execute commands on the target computer. And it uses the RSH RLogin. That's a program that ships with Linux that allows you, similar to SSH, in a way that lets you execute remote commands on the target computer. So let's go back and see how we can connect to this. So this is all cool. So let's see the package, what comes in with this package. So, and you can see this is Ubuntu. So the target computer system was running on Ubuntu. If we go back. So it's running on Ubuntu here. And you can see that in here, it uses the RSH client service to connect. So this is the package that you need to install to connect to the service. So, and as you can see, it says client program for remote shell connection. So go back and let's install RSH client. So we usually, as we did before, when we need to install something, we do apt-get
and we do install, and we'll write the name of the program that we want to install. So it's rsh. Now apt-get is going to install it for me and configure it. And once it's installed, we're going to use rlogin to log in, because remember the first page told us that it uses the rlogin program to facilitate login process. So I'm going to do rlogin. And again, I don't know how to use this app, so I'm going to do the help to see how to use it. And we can see that the format is rlogin. You put the options that you want. So what's important here is the username and the host, which is the target IP. So this is what we're going to do. We're going to do rlogin. We're going to put the username as root. Again, we said root is the user with the most privileges on the system. And we'll put the target IP, which is 10.20. Now, as you can see, now we are logged into the Metasploitable machine here. And if I do ID to get my ID, you can see that I am root. If I get where I am, pwd, I'm in the root directory. I can list stuff. If I do a uname a, that'll list the host name and the kernel that's running on the machine. And as you can see that I am in the Metasploitable machine with the root access. So this was a manual way, a basic way of gaining access to the target computer only by a misconfiguration of an installed service. So the rlogin service was not configured properly. All we had to do is just Google what came with that port, and we managed to find, or we managed to log in and gain full access to the target computer. Now, again, the key point here is you do a Zenmap scan, and then you go on each port that you find, you Google that port, and you'd be looking for misconfigurations, default passwords, if this target service came in with a backdoor, or code execution. Maybe it just wasn't programmed properly, or it had a flaw that can be used to gain access to that computer. Now, we'll have examples of these things in future videos as well. So far in the server-side attacks, we've seen how we can use a default password or use a misconfigured service to gain access to the target computer. Today, we're going to have an example on a very simple thing, which is a backdoor. So some programs or services were shipped or come in with backdoors embedded in them. So we're going to exploit that today. And I chose this very simple exploit because I want to introduce you to a framework called Metasploit. We're going to be using that framework a lot. So I wanted something simple to start with, and then we're going to go deeper into that framework. Now, first, let me show you how we find that exploit. So again, using the same method that we've always been using, I have my nmap scan. And as I said, we're going to go on each port and Google them looking for exploits. So I'm going to Google the service name here. And I'm going to go to my browser, go to Google. And I'm going to type in exploit. So the service name and followed by exploit. And as you can see, the first result comes in from a website called Rapid7. Now, Rapid7 is a company that makes Metasploit framework. So that's why I chose this particular exploit to show you today. So let me go back and let's talk about Metasploit for a second. So we're going to exploit this service or this problem using Metasploit. And as you can see here, Rapid7 is telling us that this version of FTP has a backdoor command execution. So it allows us, we can basically execute commands on the target computer if it has this program installed. And from nmap, we know that this program is installed, which means that we can execute commands on the target machine. So I'm coming back here and I'm going to go to the next slide, which talks about Metasploit. Now, Metasploit, as I said, is made by Rapid7. It is a huge framework that contains a large number of exploits. So it allows you to exploit vulnerabilities or create your own exploits. If you are an expert and you know how to discover and make exploits, then Metasploit will help you do that. Now, for today, we're doing a very simple use of an existing vulnerability.
So the commands on Metasploit are very easy. They might seem a bit complicated now, but once you get used to it, it is very easy to use. And a lot of them are generic commands. So here I'm showing you the basic generic commands, and then there are other commands that you get used to them in time. So the first command is MSF console, and this basically just launches Metasploit program. You can always type in help at any stage, and you'll get help of the commands and their description on how you can use them. You can use the show command to show something. So you can show the available exploits, you can show the available auxiliaries, the available payloads, and we'll talk about what each of these mean in the future. You can use the use command to use something that you've shown. So, for example, you showed exploits and you picked a certain exploit that you want to use. Then you use the use command and then you type in the exploit name to run it. Then you can use the set option or the set command to set specific options for the exploit. For example, if you wanted to set the IP address of your target, so you set the IP and then you put the value of the IP that you want to set it to. And then at the end, once you finish configuring your exploit, you can type in exploit to execute that exploit. Now, I know this might look a bit vague, but once I use it, it's going to become very clear to you. And we're going to be using these programs a lot, these commands a lot, so they're going to become very easy and simple to use. So we're coming back here. So we went on Nmap, we Googled the name of the service, and the first thing that came up is that this service has a backdoor command execution. Because this is on Rapid7, the vulnerability is exploitable using Metasploit. And the module name that we're going to be using is this. So it made our life much easier with this. So I'm going to copy the name. This is the name that I want to use to exploit this vulnerability. So I'm going to go to my console and I'm going to launch Metasploit using the command MSF console. And we're going to do a use and then put the name of the exploit that we just copied from Google or from Rapid7. So we're going to use that certain exploit. And as you can see now, the name here changed to exploit and then the name of exploit that we're using. Then we're going to use the show command to show the options that we need to set. So as I said, show is a generic command that you can use it in a number of cases. So in this case, we're doing a show options to see all the options that we can change for this particular exploit. And as you can see now, the second option is the port that the service is running on, and it's already set to port 21. And this is correct. If we go back to Nmap, you'll see that our target FTP client or server is running on port 21. So this is good. We don't need to change any of that. What we need to change is the rhost. So the rhost is the target IP address, as you can see here. And to change the value of this, as I explained before, we're going to use the set option or the set command. So our command is going to be set, and we're going to set the rhost, and that's the IP address of my target Metasploitable machine. So we use set, and after set you put the option name. So for example, if you wanted to change the port, you set rport. We are changing the host, so we set rhost to 10.20.14.204, and I'm going to hit enter. And as you can see now, this is the rhost is set to this. Now what I want to do is show the options again, just to make sure that everything is configured correctly. And as you can see now, the rhost has been changed to 10.20.14.204. So everything is ready now, and to execute the exploit, we just type in exploit. So it seems like the exploit ran, but nothing has happened. We didn't gain anything. So what I'm going to do is just run it again, and this happens sometimes. And as you can see now, the exploit was run successfully. And now I have access to the target computer. If I do an ID, you'll see that my ID is root. Now basically I'm running Linux commands here. So if you do a uname a, you'll see that this is my Metasploitable machine. And if I do ls, Then it'll list the files for me. If I do pwd, it'll show me where I am, and I can use Linux commands to do anything I want on the target machine. Now, this was a very simple use of Metasploit. In the future, we're going to be using it for more advanced stuff. So far, we've seen how we can use a service with a default password, or a service that has not been configured correctly, or a service that came with a backdoor to gain full access to the target computer. We also seen how the basic use of Metasploit using to connect to a backdoor that was installed on the FTP service. Today we're going to have a more advanced look on Metasploit, and we'll see how we use it to run a vulnerability that exists in a certain service. It's a code execution vulnerability, which will give us full access to the target computer as well. So, back to our results here with Nmap, and we're going to do the same thing that we've been doing for a while. We copy the service name and see if it has any vulnerabilities. So for today, we're having a look on this particular port 139, which has a Samba server version 3.x. So 3 point anything really. So we're going to go to Google just like we did in the previous videos, and we're going to look for Samba 3x exploit. Now, as you can see, there's a number of results. The one that we're interested in, the ones that come in from Rapid7, because as I said, these are the people that make Metasploit. So the exploits that you see there can be used through Metasploit. So we have two examples here. Now, I've actually tried both. The first one doesn't work, so there is a bit of trial and error in this. And the second one is the user map script. It's a command execution vulnerability, as you can see here. So the name of the vulnerability is this. So it's the same thing that we used before with the evil backdoor in the FTP service. This is just a different name that we're going to use. So I'm going to go to Metasploit, and I've already run MSF console. So you can see that the console is running here for me. So I'm going to do a use like we did before yesterday. And then I'm going to put the name of the exploit that I want to use. Then the next thing that we usually do is show options like we did yesterday. So I'm going to do show options. So using these exploits is always pretty much the same. The only difference is the options that you can set for each exploit. So you always do use and then you put the exploit name, and then you do a show options to see what you can change to work with this exploit. So in the future, you probably will get different exploits than what I have. So every time you want to run an exploit, you do a use exploit name, and then you do show options to see the options that you want to configure. But using the exploits and setting the options and running them is always the same. So I'm showing you a few examples that should cover pretty much everything that you want to do in the future. So again, we need to set up the rhost, which is the IP of the target computer. And we're going to do it the same way that we did before. As I said, it's setting the options is always the same. So we're going to do set rhost, and then we're going to put the IP of the target computer, which is 10.20.14.204. So exactly like we did before, we're using the set to set an option, which is the rhost. So we're going to do a show options. And as you can see now, the rhost has been set correctly. What we need to do now is, here is where things differ from the previous lecture. In the previous lecture, we used a backdoor that was already installed on the target computer. So all we had to do is connect to the backdoor, and then we could run any commands, any Linux commands on the target computer. In today's video, the target computer does not have a backdoor. It has a normal program that has a buffer overflow or a code execution vulnerability. So the program doesn't have any code that allow us to run Linux commands. It has a certain flaw that will let us run a small piece of code. These small pieces of code are called payloads. So what we need to do, we need to create a payload and then run it on the target computer using the vulnerability that we found. that piece of code will allow us to do different things. So the payload is what allows us to do things that are useful to us. Now the payload might let us do Linux commands, and there is other type of payloads we'll look at in the future. So to see the payloads that you can use with this particular exploit, all you have to do is run show payloads. And these are the different type of payloads that you can use. Now, I'm going to talk about this again. So payloads are small pieces of code that will be executed on the target computer once the vulnerability has been exploited. So when we exploit the vulnerability, the code that we're going to pick here will be executed. And depending on the type of payload we choose, that payload will do something that is useful to us. So right now you can see that all the payloads are CMD. So that's short for command. So they let you run commands on the target computer, just like Linux commands. And all of them only run on Unix, and that's okay because our target is Linux. And there is two main types. There is bind payloads and there is reverse payloads. The bind payloads, all they do is they open a port on the target computer, and then we connect to that port. The reverse, they do the opposite. So they open a port in my machine, and then they connect from the target computer to my machine. This is useful because the reverse allows us to bypass firewalls. So the firewall will filter any connections going to the target machine. But if the target machine connects to me and I don't have a firewall, then I'll be able to bypass the firewall. So I'm going to use the CMD Unix reverse, or actually I'll use the CMD Unix reverse netcat. The last parts of these payloads are the programming language or the tool that's going to be used to facilitate the connection. So for example, you can see there's payloads written in Perl, in Ruby, or in Python, PHP, or using Netcat, which is a tool that allows connections between computers. So this is the one that I'm going to use. And I'm going to use it the same way you use an exploit. So I'm just going to say, I'm going to use it using the set command. So the same way you set an option, we're going to set payload. So just like an option to the payload name that we just picked. Now I'm going to do a show options to see if there is any other options that I need to set. And yes, because we picked a payload now, there is more options. So there is an option called lhost, and it's the listening address, which is my own address. So I'm going to get my own IP address using ifconfig. And my own address is 10.20.14.203. So I'm going to close this. And I'm going to set the lhost. So it's like the same way that we set the rhost before. We set the lhost to 10.20. So before we used to do set rhost to set this option. Now we're setting the lhost to set this particular option. So set is really simple. Set, you put the option name and then the value that you want to set it to. Then I'm going to do show options. And now everything seems fine. So we're using this exploit. The rhost is set to this, which is okay. And then the lhost is set to this, which is perfect. And then you can also set the port that you're going to be listening on your current computer. You can actually set it to 80 if you wanted to. That's the port that is used by web browsers. So if you set the L port to 80, the target computer will try to connect to you using port 80, which is never filtered on firewalls because that's the port that web browsers or web servers use. So whenever you access a website, you actually access port 80 on that website. So if you open port 80 on your machine and the target connects to you on 80, then the firewall will think that the target is only browsing the internet. I'm not going to do that now because I have a web server running on port 80 and that will conflict. So I'm just going to set the L port to 555, just for example for you, just to see that you can change any option using the same way, which is set, the option name, and then the value. So I'm going to do show options again. And as you can see, this has been changed to 5555. And I'm going to do exploit to run the exploit. Now, as you can see, it's telling me that session 1 has been opened
and the connection is between this device and this device, which is the target and my device. So I'm going to do a PWD, or I do an ID. You'll see that I'm root. If I do a uname A, you'll see I'm in the Metasploitable machine. And if I do an ls, I'll be able to list the files and so on. I can use any Linux command just like we did before in the other videos. In this lecture, I'd like to talk about a tool called Nexpose. Nexpose is made by Rapid7, so it's made by the same people that made Metasploit and Metasploit Community. And it's similar to Metasploit Community in a sense that it has a web GUI and it allows us to discover, assess, and act on discovered vulnerabilities. It also maps these vulnerabilities to existing exploits, but the difference is Metasploit Community only showed us exploits that can be used within Metasploit. Whereas with Nexpose, it actually shows us exploits that have been published somewhere else other than Rapid7 and Metasploit. So it works on a larger scale, it shows us more vulnerabilities, and it also helps us to create a report at the end of the scan so that we can share it with the technical people, and a small report which is of a high level that can be shared with the managers. It also helps us create scheduled scans so that, for example, if you have a company or if you're working on a big infrastructure and you want to do regular scans every week or every month, then you can do that using this tool. Let me show you how to install it and run it, and the differences will become more clear. So Nexpose doesn't come installed in Kali Linux. We have to install it manually. To download it, you need to download it from the following link. It'll ask you to fill up your name and address and all that. Fill it up and download. I downloaded the community version, which is free. So I have it right here. Now what I'm going to do before we can install it, the first thing we're going to do is stop the PostgreSQL service that comes installed with or that is running in Kali Linux. So I'm going to do service. Post. Stop. That will stop the service, the SQL service. Now, I'm actually already at the downloads folder. So usually when you run your Terminator, you will be here. So if you do an ls, you'll see all the directories, and you'll need to change your directory to the downloads directory by using the cd command. So cd and type in downloads. Now, once we're in the downloads, we can list all the available files, and we can see that we have Nexpose right here. Now, usually you'll need to change the permissions of this to an executable. Now, I've already changed it. That's why it's in green. So for the first time, you need to run a command, the chmod command, to change the permissions so that we can execute that file. So the command will be chmod +x. And you type in the file name that you want to change the permission. And for us, it's Nexpose. And that's it. The permissions are changed. Now, to run this installer, to run any executable in Linux systems, all you have to do is dot and /, then type the file that you want to run. So for us, it's Nexpose. Now, as you can see, you get a nice installer for it. So I'm going to click next. Now it's asking me to accept the agreement. And I'm going to install the console with the scan engine. Now, as you can see, one of the problems that I have here is that it's not supported with the Kali Linux version that I have. I have the latest rolling version of Kali Linux, and Nexpose is not compatible with it, so it's not going to let me install it. Now, it's only compatible with Kali 2, so if we want to proceed and go ahead with this, we're going to modify 2 files on our local system to make our system look like Kali 2. So that the installer will let us install it on our system. Now, hopefully, in your case, by the time you watch this video, there will be a supported version, so you can just click next in this step. But for me, I'm going to have to go in and modify 2 files to make my system look like Kali 2. So
follow the steps that I'm going to do now only if you get this error. So I clicked on finish, and I'm going to go here. I'm going to attach a file that contains the instructions that you need to do to fool or to change the version of your system to Kali 2. So I have it here in the documents. The two files that need to be changed are the LSB release and the OS release. So I'm going to open two tabs in here, one for each file. And the first one is in etc. And it's called LSB release. And we can see that the file here. Now, before I modify this file, I'm actually going to copy it and store a backup of it, because after we finish this step, I'm going to restore it to the way it was. So I'm going to create a new folder and I'm going to call it backup. And I'll paste this file here. And after I do that, I'm going to modify the file according to the instructions. So I'm going to open it with LeafPad. And I'm going to copy all of this. I'm going to save it and quit it. Now I'm going to do the same with the next file, which is the OS releases, which is stored in user lib OS releases. So I'm going to copy this and put it in my backup. Then I'm going to modify it according to the instructions. Okay, now everything is done. I'm going to go back and run the installer again. And it should think that I have Kali 2 installed and let me proceed through the installation. So again, scroll down, accept, next. And as you can see that it thinks I have Kali 2, so it's letting me proceed through the installation. Now I'm going to put my name, my last name, and the company. And now it's asking me to put the port for the database that's going to be used with Nexpose. Now that port has already been used with an already installed database, so I'm going to make the port 5435. And as you can see, it's telling me that the port is valid and can be used. So I'm going to go next. Now it's asking me to make a username and a password for login. So I'm going to make a username and I'm call it Zaid. And then I'm going to select my password. And make sure you don't check this box. Now I had a lot of issues when I was checking this box while installation, which basically should start Nexpose once the installation is over. But I'm not gonna check it. I'm just gonna install it and then start it later when we want to use it. So I'm not gonna check this box. Make sure it's unchecked. And that's it. Now it's going to install it for me. I'm gonna pause it and resume once the installation is complete. Okay, so the installation is successful and we didn't start Nexpose yet. So if you go on this link, nothing's gonna work. You need to run this command first, and then you can access it. So we're going to talk about that in the next lecture. For now, that's it. I'm going to click on finish and we're done. Now we're going to go back and make sure we set our files back to the way they were. Now, if you didn't need to modify them, then again, skip this step. If you did modify them like myself, then make sure you go back and you set them back to the way they were. So I'm going to go on my backup and I'm going to open these files. So we're going to do the OS release first. I'm going to copy it. And modify the existing one
and make sure it's the same as it used to be, the rolling one. As you can see, it says Kali 2 here. I'm going to set it back to 2016. And then I'll do the same for the next file. And that's it. Everything is done. We restored our files the same way they were, and we installed Nexpose on Kali 2016. Okay, now that we installed Nexpose successfully, let's see how we can run that tool and see what that tool is. I know we spoke about it a lot and we went through the installation process, but you still haven't seen what the tool does. So the first thing before we can run the tool, we need to make sure that the database that comes in with Kali Linux is turned off, because Nexpose uses its own database. So if we have both of them running on the same port, they'll conflict with each other. So the first thing we're going to do, we did that in the previous lecture as well before we installed Nexpose, but I just want to make sure that you have it in your mind that every time before you run Nexpose, you turn off your database. So you do it using the same command that we did it in the previous lecture. So it's service host stop, and that will make sure that the service has been stopped. Now we're going to navigate to the location where we installed Nexpose. So unless you change the location during the installation process, it should be installed in, so we're using the cd command to navigate, and it should be installed in opt rapid 7 Nexpose, and then the file that runs the server is stored in the directory called NSC, and the file that you want to run is called nsc.sh, this file. So we run it just the same way we ran the installer before. As I said, to run an executable, you always use the ./ and then you write the name of the executable. So it's nsc.sh. Now, running this for the first time might take some time, so just let it do its thing until it runs. And once it finishes loading the framework, we'll see how we can access it and use it. Okay, so the tool has loaded successfully, and as you can see that it's telling us that we can browse it using the following URL. So what we're going to do now is launch our browser and just paste the URL that it just gave us. Now, it's asking us to log in. So log in using the username and password that you created when you installed the tool. So my username was Zaid, and I'll put my password. Okay, and we logged in successfully. And you can see that the first thing it asks us to do is to enter the product key. Now, as I said, this is a free version, and when you downloaded the tool, you had to fill out a form. So in that form, you put your email address, and then they send the product key to your email. So I'm just going to go to my email and get the product key and paste it here. Okay, so I'm going to paste it, and click on activate the key. Now, as you can see, the activation is successful. It's going to refresh now. Now, I actually paused and resumed the video because the activation takes some time as well. I just don't want to make the video boring. Now, as you can see, this is just showing us information about the license. So everything is activated and we're good to go. So I'm going to go to the home from here, from the left menu. So this is the home page of the tool. And as you can see now, everything is empty. So before I start talking about what everything means, let's go ahead and add a target, and then we'll do a test and we'll see, because this stuff will be filled after we do a test. So the first thing I'm going to do is go on create and go on a site to add a target. And I'm going to call this target Metasploitable. And I'm going to go to the assets, and we're going to add the target. So the target can be arranged the same way we added it when we were doing the network penetration things with ZenMap. So you can add a range, or you can add a specific IP. So in this, we're actually targeting the Metasploitable machine. So we're going to add our target, which is 10.20.14.204. Confirm this here. This is our Metasploitable machine, 10.20.14.204. And we're going to add this to a group, and we call that Metasploitable as well. Or we'll call this test. So this is our group name. Now, in here in the authentication part, if the target uses some sort of authentication, so nobody can access the target unless they need to authenticate with some sort of a service. For example, if it's an FTP service or a web HTTP authentication, a telnet, or an SQL server. So you can pick it from here, put the domain, username, password, confirm your password, and that way the framework will be able to authenticate with that service and test the security of your server. Now, our server doesn't use any type of authentication, so we don't need this. Also, if you're targeting a web application and the web application has a login page, for example, for users, for example, Facebook, let's say you're targeting Facebook, then you won't have access to most of Facebook's features unless you log in with using a certain username and a password. So again, using this feature here, you can log in and then test the security of your target. And the templates is where you select the scan type. So it's very similar to the scan type with ZenMap. We've seen in ZenMap we had a quick scan plus, and intense scan. This is the same. So each one of these profiles is different. It scans different things. For example, we have the full audit here, which takes a lot of time, but pretty much checks for everything. Then you have a full audit, enhanced logging, without Web Spider. So a Web Spider is a tool or a script that finds all the files and directories in your target. And the default one is a full audit without Web Spider, so that's the one we're going to be doing. And you also have network specific profiles, you have web audits as well. So I really encourage you to try all of them or most of them and get yourself familiar with them. Now, we're only going to try this one because using them is the same, which will be scanning for ICMP, TCP, and UDP ports. So I'm leaving that the same. I'm going to leave the engine the same as well, which means it's going to use our local engine, which we installed, instead of using the one that is provided by Rapid7. And the alerts, you can set up custom alerts so that when a vulnerability is found, you get a notification. And the schedule is a really, really cool feature. Now, say you're working for a company or for an enterprise that keeps pushing new code every day. Or, for example, maybe your code, you do a test today and everything you're working on is good. Your web servers, your programs, your applications, everything is up to date and there's no vulnerabilities in them. Let's say tomorrow you pushed a new vulnerable code, or maybe tomorrow someone discovers a new vulnerability with a program that you're using on your web server. So you're not secure anymore. So this feature allows you to schedule this test so that it runs every week or every hour or every month, depending on how critical it is. So all you have to do is just go in to create a schedule and create the schedule. So you can put a start date and an end date, and you set up the frequency from here for every day, every Thursday, every 26th, or depending on what you want really. You create that schedule, and then every interval that you specify, the scan will run, and even you can get it to produce a report for you, so you can go over the report and see what's changed or what has been discovered. So everything's good now. The most important part today, or what we did here, is you put your target here, and the next thing is you select the template. So we have both of them selected, and we're going to do save and scan, which will save this configuration and start a scan for us. Now, as you can see, our asset discovery is in progress. I'm going to pause the video, and after that, we will talk about the results that we got. Okay, so my scan is over, and I'm here now at the assets page. And as you can see that we have one asset has been scanned,
we can see that the asset is running Ubuntu, and the skills that you need to hack into this asset is novice. Now, already from this, you can see that Nexpose show us much more information than Metasploit Community, and it's a much more advanced vulnerability management framework. We can see that we scanned one target, it's Metasploitable, and the site is global. Let me zoom in. It's running on Ubuntu Linux 8.08.04. We discovered no malware, and 177 exploits, 308 vulnerabilities. Remember, with Metasploit Community, I think we only discovered 8, only one exploitable vulnerability and 8 modules that can be used. Here we discovered 308 vulnerabilities, so we discovered so many more vulnerabilities and exploits. You can see that there is a risk factor assessed to this, and the last time that the scan was done. Now, if we go down, we can see that the operating system that we discovered, again, it's Metasploit. We can see the software that is installed on the target computer. So not only the services that's running on ports, we can see actual software installed on the target computer. This can be very useful after we hack the computer. So after we manage to hack into it, it's very useful to find local exploits that can be used to increase our privileges. For example, if you got a normal user and you want it to become a root, then you can use a local buffer overflow to increase your privileges or to do other kind of stuff. So these are very useful in terms of post-exploitation. If we go down, we'll see the services that's installed on the target computer, just like Nmap gave it to us. We can see that HTTP is running, DNS, and so on. If you click on any of these services, you'll see that it'll give you more information about it. For example, it's a HTTP service, a description about it, and the ports that it's running on. So we can see that HTTP is running on port 80 and on port 8180. Now let's go up, and if we wanted to have a closer look on the vulnerabilities, we can go to the vulnerabilities page here, and you can see we have a graph here about the vulnerabilities categorized based on their risk factor, and here they're categorized based on the skill level needed in order to exploit these vulnerabilities. And in here, you can see a list of all of them, and we can switch between them using this right here. Again, this, if there's any malware, you'll see it in here. And if there is an exploitation, you'll see it in here. Now, all of the top vulnerabilities here don't have an exploitation using a tool, but they are ordered based on their risk. So these are very risky vulnerabilities. And then as we proceed through them, the risk will be a bit less. So you can see here, it discovered that VNC password is password. So we can go in and try to connect using VNC. Now, VNC is a service very similar to remote desktop. Basically, it will show you the desktop, and it'll allow you to gain full access to the target computer, just like remote desktop. I'm not going to show you how to do that. Very simple. But it's telling you here the password is password. Now, it's also telling you that there is a backdoor running, and we use that already. It's telling us that it's running an old version of PHP that can be exploitable. Just an old version, actually. Now let's look at something that can be exploitable. So I'm gonna click on this to order them by the exploit, and you can see that all of these have an M logo, which means that they can be exploited using Metasploit. You can see here we have the remote shell service that we use, and there is the rlogin service here that can be used as well that we already had a look on. So let's click on something that we haven't seen before. And here you can see a description of this vulnerability. Again, you can see the port that it's running on, and you can see why it thinks that this particular target is vulnerable to this exploit. If you go down, it will show you how you can exploit it. So there's 3 different modules that can be used to exploit it. It doesn't really have to exploit it. Sometimes you just see modules that can be used to verify the existence of this exploit. But basically, these are modules associated with it. And if we click on this, it'll take us to the Rapid7 page that we always used to see when we Google stuff. And we see the module name where we can just copy and paste it in Metasploit and show the options and then use this exploit the same way that we've seen it in previous videos. Again, when you go down, you'll see references to this particular exploit. And at the bottom, it'll show you the solution on how you can fix this exploit. So for this one, all you need to do is just change the administrator password and not use the default configuration. Another useful thing is the reports. So this framework allows you to generate reports for each scan that you do. And there is different types of templates for the report. So if you go on create report, you can see that there is an audit report that contains a lot of information, detailed information for the programmers or for the technical people. Or you can use an executive report, which has less information and it's made for the managers or for the top level people that don't have much experience with technical stuff. You can select any template you want, call it anything. So I'm going to call this Metasploitable or Metasploit. And you select the format that you want. So it's set to PDF here. Then I'm going to select the target scan that I want to generate a report for. And I selected my Metasploitable. And then you save and run the report to generate the report. You can also get this to generate reports automatically every time, because as I showed you, you can schedule reports, you can schedule scans, and you can also schedule an automatic report after each time a scan is done. So for example, if you're scanning every week, you can also generate a report every week, every time that scan's done. Now let me just download the report and show you what it looks like. As you can see, it has the date, it has the title, it has all the exploits that have been found, but this is the executive report, so it has small details about the exploits and more graphical stuff to show the executives the risks that has been found and how critical they are. So as you can see, Nexpose shows you much more detail and it's much more advanced. It's directed towards bigger companies, bigger infrastructures where you need to always make sure everything is up to date and everything is installed and does not have any exploits. In this section, we're gonna start talking about client-side attacks. So most of the time, it's better to try to gain access to your target using the server-side attacks. So try to find exploits in the operating system and in the applications installed. If you tried that and it didn't work, or if your target is hidden behind an IP, so if the target person is not in the same server as us, on the same network as us, and if the target person is using a network, so if you ping their IP, you won't be able to reach it because they're hidden behind the router or behind a network, then your next resort is going to be the client-side attacks. So these attacks require the user to do something. So the user is going to have to open a link, they're going to have to install an update, they're going to have to install a picture or open a picture, or they have to interact, they have to do something. And once they do it, we will be able to run code and achieve our goal. Therefore, because it requires user interaction, information gathering is very important in this case, and we don't only need to get information about the installed applications, we also need to know the person. We need to know their friends, we need to know the networks they use, the websites they use, if there's any websites that they frequently use and trust. Therefore, the information gathering section in here is going to be focused on the person rather than focused on the applications and on the operating system. So I also want to show you my lab for this. So obviously we're going to be using the Kali machine for the attacking, and the victim or the target is going to be using the Windows machine. So again, I'm just going to go over the networks just to show you that they're both on the same network. They're both using the NAT, the 10.20.14 NAT. And if we go here, we have a NAT network as well. and it should be the 102014 as well. So both devices are on the same network, but it really doesn't matter. Even if they're on different networks, these attacks will work anyway. Where we're going to be using reverse connections in most of them, so you don't really need, the target doesn't really need to have a separate real IP address.
Okay, now that we have VIL loaded, you can see it show us the main commands that you can use with VIL. So the first command is you can do exit to exit. You can do info to get information about a specific tool. You can do list to list the available tools. You can do update to update VIL, and this is very, very important because you always want to be up to date when it comes to bypassing antivirus programs. And then you can do use to use a tool. Now, let's start using VIL evasion, and as we do it, it's going to become so easy and you'll be able to understand it more. Now, VIL has two main tools, and if we do list, you'll be able to see them. So, we have the first one, which is the one that we're interested in, which is called evasion, and that's the one that generates undetectable backdoors for us. And then there's the second one, which is called ordnance, and this tool generates the payloads that's used by evasion. So you can look at this as a helper or a secondary tool. Now, what I mean by a payload is the part of the code of the backdoor that does the stuff that we want, that does the evil stuff, if you want to say. So it's the part of the code that gives us a reverse connection. It's the part of the code that download and execute something on the target computer. It's the part of the code that allow us to achieve what we want by executing that file. And this is going to become more clear as we start using VIL. Now, for now, we're interested into using evasion. So we're going to do use 1 because that's the first tool. That's number 1. And as you can see, we have VIL evasion loaded now. And as I said before, this used to be a standalone tool that you just downloaded on its own. But now they have it all combined together. Now, as you can see, the first thing that we get when we load VIL evasion is the commands that you can run on this tool. So the first thing that we want to do is we want to list to see all the available payloads. And as you can see, we have 41 different payloads. And all of these payloads follow a certain naming pattern. And you can see, for example, let's take this example right here because that's the payload that I'm going to be using. You can see the payload is divided into 3 parts. The first part right here refers to the programming language that's the payload is going to be wrapped in. So we have the evil code, and then the evil code is going to be wrapped into a certain programming language that the target computer understands. And right here, you can see that this payload uses Go programming language. We can see this one uses C. We can see these ones use CS. We have Python, we have PowerShell, and we have Ruby if we scroll down. The second part of the payload is really important. This is the type of the payload, the type of the code that's going to be executed on the target computer. In this example, we're using Meterpreter, which is a payload designed by Metasploit. Metasploit is a huge framework for hacking and it allows you to do a lot of things. But in this lecture, we're focusing on creating a payload called Meterpreter. And what's really cool about Meterpreter is it runs in the memory and it allows us to migrate between system processes. So we can have the payload or the backdoor running from a normal process like Explorer, for example, and this payload will allow us to gain full control over the target computer. So we'll be able to navigate through the file system, download, upload files, turn on the mic, turn on the webcam, even use that computer to hack other computers, install a keylogger. You can literally do anything you can think of. And all of this will be running from the memory from a normal process on the system. So it's very hard to detect and it doesn't leave a lot of footprints. That's why it's a really, really cool payload and we'll be using it a lot. The third part of the name is the method that's going to be used to establish the connection. So in here you can see that this is called rev HTTPS.
So rev stands for reverse, and HTTPS is the protocol that's going to be used to establish the connection. So we can see that this payload will create a reverse HTTPS connection. You can see this one right here, for example, it creates a reverse HTTP connection. And we have this one in here that creates a reverse TCP connection. Now, what I mean by reverse is the connection is going to come from the target computer to my own computer. So I won't be connecting to the computer that I want to hack. What's going to happen is once the person double clicks the backdoor will connect back to me from the target computer. What's cool about this is I'll be able to bypass antivirus programs because the connection is not going to the target computer, it's coming back to my computer. So it's literally as if the target person is just connecting to a normal website. I'm going to use a port that websites use, which is 80 or 8080. So again, if the person analyzes the connection, it'll look as if they're literally just connecting to a normal website. Also, if the target computer is hidden behind a router or behind a network, again, this is gonna work because the connection is coming from the target computer to me instead of me connecting to the target computer. So using a reverse connection is really handy, and I think this is really the only practical way of gaining access to a computer because there is a lot of things that can stop you from connecting to a certain computer. Now, this is the general naming pattern. You'll see some payloads like this one right here, which doesn't follow that general naming pattern. And basically what these payloads do, for example, you can see this one is called shellcode inject. So what it's going to do is it's going to create a payload that injects your other payload. So it's going to create a normal payload, and that normal payload injects an interpreter payload, for example. Now it does this to try to bypass more security, but usually they won't bypass more things than the normal payloads would bypass. So that's why I usually just use one of the normal payloads in here. So this is it. This is all about the payloads. Sorry I took a bit of time, but I wanted to make sure that you guys understand the naming pattern. I wanted you to understand what a payload is and the difference between a reverse and a bind and a TCP payload. This way, the rest of the course will become more clear to you, and I can just use the payload that I want without explaining what it is. Now, in the next lecture, we're going to be generating a payload, and we'll be testing it against antivirus programs. Okay, so in this video, we're going to be using Vil to create a backdoor. So the first thing I'm going to do is I'm going to do list to list the available tools, and I'm going to use number 1 because we want to use evasion. And then I'm going to list my payloads. And like I said in the previous lecture, I want to use Go Meterpreter Reverse HTTPS. So that's number 15. So I'm going to do use 15. And that's going to list first of all, it's going to show me information about this particular payload. And then it'll show me the options that I can set for this payload. So the main option that you want to set, and the most important one, is the IP address. So this is the IP address which you're going to be receiving the connections on. As we said, we're going to have a reverse connection, and we need to set the IP address which the payload or the backdoor will try to connect back to. And in our case, we want to receive the connection back to this Kali machine. So we're going to set the IP lhost to the IP address of the current Kali machine. Now, to get the IP of my Kali machine, I have to run ifconfig. So I'm going to split the screen by doing right click and click on split horizontally. And I'm just going to bring this down a bit. And we're going to run ifconfig. Now you can see the IP address in here is 10.20.14.213. This is the IP of my Kali machine. This is the IP of the machine that I'm using as the attacking machine. So this is where I want the connection to come back to, so I can hack the target computer once the backdoor is executed. So I'm going to set lhost to 10.20.14.213. So you can set any of these options using the set command. So all you have to do is write set followed by the option that you want to change. So in this case, we want to change the L host, and we want to change that to 10, 20, 14, 213. Now, the L port is set to 80, which is really good because that's the port that's used by web servers. So as I said, the connection will look as if the target person is connecting to a website, and it's not going to be suspicious. But I don't want to use that port because I'll have a web server running on this, and we'll talk about that later. So I'm going to change that to 8080. 8080 is another port that's used by web servers, so it's still not suspicious, and it should still bypass firewalls. So I'm just going to do set. Same way that we did it before with the L host, we're going to do L port to the value that we want to set this option to, and we're going to set it to 8080. Now, if I do options again to list all the options, you'll see that the L host changed to 10, 20, 14, 213, and the L port changed to 8080. Now, if you generate the backdoor like this, you will bypass all antivirus programs except AVG. I've already tried this, that's how I know this, and that's not good enough because we want to bypass everything. Now, the way antivirus programs work is they have a very large database of signatures. These signatures correspond to files that contain harmful code. So what they do is they compare the signature of your file, of your backdoor, to all the files in this huge database. If your file matches any of these files, then they'll flag it as a virus or as malware. If it doesn't, then they'll think that it's a normal file and it's not malware. So the main point in here is we're going to try to modify the file, our backdoor, as much as possible to make it more unique so that it bypasses the signature database and will be able to bypass antivirus programs. Now, as I said, Vil is already doing that for us. It's encrypting the backdoor, it's obfuscating it, it's injecting it in the memory so that it doesn't get detected, and it's doing a good job at it. It's bypassing pretty much everything except for only one antivirus program. So just to bypass this last antivirus program, I'm going to set some optional options that really won't do much of a difference. They'll just make the backdoor look a bit different. So the first thing that I'm going to modify is processors. And that's the minimum number of processors to be used by the backdoor. I'm not going to set a huge number because that'll just make my backdoor not work. I'm just going to set it to 1, which is pretty much nothing really, but I'm just going to set this option to make the code look a bit different. So I'm going to do set. Again, the same way that we are setting the L port and the L host, we're just going to put the option name, which is processors. And we're going to set that to number 1. And I'm also going to set another option, which is the sleep option. And that basically lets the backdoor sleep for a number of seconds that you set before it executes the evil code that you have in there, before it executes the payload. So I'm going to set this to 6. Again, no real reason for this. I'm only doing this to make the backdoor look a bit different. So I'm going to do set sleep to 6. So I'm going to hit enter. And I'm going to do options again to make sure that all the options are set the way I want them to be. So I have my IP address set properly. I have my L port. I have my processors. And I have my sleep. So I'm going to generate the backdoor. And now it's asking me to name this backdoor something. So I'm going to name this backdoor rev HTTPS 8080. Just so that we can remember which payload and which port to use for this backdoor in the future. Now the backdoor is generated, and you can see it's telling us the module that's used, and it's telling us where the backdoor is stored. So the backdoor is stored in this path right here. So I'm going to copy that. Let's go ahead and check to see if the backdoor is detected by any antivirus programs. Now you can use the built-in feature by Vil using the check VT command, but this feature only uses the signature of the file and it's not 100% accurate. Sometimes it tells you that the file will bypass all antiviruses, but it'll actually be detected. You can also use VirusTotal, but I don't recommend that, and please don't do that, because if you do that, your backdoor will become less effective, because VirusTotal share the results of their scans with antivirus programs. What we're going to do is we're going to use a website called NoDistribute. So we're going to go to it now. So I'm just going to Google for NoDistribute. And what this is going to do, it's similar to VirusTotal. The only difference is it's not going to share the scan results with antivirus programs, so it won't affect your backdoor. So I'm going to click on Browse to navigate to my file. And I'm just going to copy where the file is stored. So Vil is telling me now it's stored in this location in user share Vil output compiled. So I'm going to copy this. And I'm going to come here. I'm going to click on the pen. And I'm going to paste the location. I'm going to click on Open. And scan the file. Now, as you can see, I've already scanned this file, and it's telling me that this file has been scanned before. So I'm just going to click on View Previous Results. And as you can see, the file is actually scanned on the same day as today, which is the 29th of March, 2017. And as you can see, the file is bypassing all antivirus programs. So we can use this backdoor against any device, and we'll be sure that the device or the computer will not be able to detect this file as a virus. Now, there's a few things to keep in mind. Antivirus programs always update their database, and Vil always update their code as well. So you want to always make Vil up to date. Also, sometimes with the same exact backdoor, it might get detected and it might not get detected, because depending on the way the backdoor is getting encrypted and it's getting generated. I've actually generated this backdoor before with no sleep, and as I said, it got detected by one antivirus program. I generated with 10 seconds and it still got detected, and then with 6 it was able to bypass it. So you want to keep playing around with the options, you want to keep playing around with the payloads until you manage to achieve the best results so that you can bypass as much antivirus programs as possible. Now, the backdoor that we created uses a reverse payload. So, like I said before, it does not open a port in the target computer. It actually connects from the target computer to our computer. And by doing that, it'll bypass firewalls and it'll look less suspicious. So, for this to work, we need to open a port in our computer so that the backdoor can connect from the target computer to us on that port. So if you remember, when I created the backdoor, I set the port to 8080. So I need to open that port in my Kali machine so that when the target person executes the backdoor can connect back to me on port 8080. So I'm just going to write the name of the payload that we used, because that's very important when you're listening for incoming connections. So we used a payload that's written in Go, and that was a Meterpreter Rev HTTPS, which is a reverse HTTPS payload. Now, this is not a command. I'm just going to write it in here, so just that you keep this in mind. And we used port 8080 for the reverse connection. So these are the most important things to keep in mind when listening for incoming connections. So I'm going to split the screen. And I'm going to listen for incoming connections in here. And to do that, I'm going to use the Metasploit framework. Now, to run Metasploit, all you have to do is just run MSF console. Now, Metasploit framework is a huge framework for penetration testing. So the Meterpreter backdoor, or the Meterpreter payload that Vil created for us, is actually programmed by the people who made Metasploit. That's why we're using Metasploit to listen for incoming connections. So Vil Evasion actually uses Metasploit to generate the backdoor that we chose in the previous video. So to listen for incoming connections, we're going to use a module in Metasploit. Now, Metasploit, as I said, is a huge framework and it has a lot of modules. So the module that we're interested in is a module that allows us to listen for incoming connections from a Meterpreter payload. To use that module, we're going to do use to use a module, and then we're going to specify the module name. And the module name is exploit multi-handler. Okay, so the command we're using is use to specify the module that we want to use, and we're using a module called exploit multi-handler that allows us to listen for incoming connections. I'm going to hit enter. And I was already in that module, so you can see that nothing changed for me, but for you, you should navigate to that module. And I'm going to do show options to see the options that I can set for this module. And you can see that you can specify different options for it. The most important thing that you want to specify is the payload. So you can see in here, for me, it's set to Windows Meterpreter Reverse TCP. And if you remember what we used a Meterpreter Reverse HTTPS, not TCP. So you want to change this. The first part is fine because our target is going to be Windows, but you want to change the reverse TCP to reverse HTTPS. And you can change that exactly the same way that we did with vil evasion. So you type in set, you put the option name that you want to change, and we want to change the option for the payload. So we're going to say payload. And we're going to set that to Windows Meterpreter Reverse HTTPS this time. Okay, so we're doing set to set an option. We're setting the payload to Windows Meterpreter Reverse HTTPS. Now this payload should correspond to the payload that you chose in the backdoor. So in the backdoor we used Meterpreter Reverse HTTPS. That's why in here we're using Reverse HTTPS as well. If you chose Reverse HTTP, then set this to Reverse HTTP. If you use Reverse TCP, then set this to Reverse TCP, and so on. So I'm going to hit enter for this, and that's going to do it for me. And if I do show options now, you'll see the payload changed to Windows Meterpreter Reverse HTTPS. Now the same concept applies for all the other options. So you want to set the lhost to our IP address, and you can see that this is already set to the right one. So if it was wrong for you, all you have to do is just do set lhost and put your IP address. So you can get the IP address using ifconfig like I showed you in the previous lecture. So for me it's 10.20.14.213, and again this is the same IP that I used when I created my backdoor. And same goes for the port. You want to set the same port. So we're going to do set lport to 8080. Because that's the port that we used when we generated the backdoor. So again, the main idea with this is you want to set the payload, the lhost, and the port to exactly the same options that you chose when you created the backdoor. Once done with that, we're going to do show options one more time. And you'll see that I have my payload set properly, Windows Meterpreter Reverse HTTPS. I have my lhost, and I have my lport. And all of that is done properly. So all we have to do now is just do exploit. And now Metasploit is waiting for connections, as you can see, on port 8080 and on my IP address, which is 10.20.14.213. So now if anybody opens the backdoor that we created in the previous lecture, because it's a reverse backdoor, the backdoor will try to connect to the IP that we set when we created the backdoor, which was 10.20.14.213, and it'll try to connect on port 8080. It's going to come to this computer, and this computer is already waiting for that connection from this multi-handler module. So the connection will be established, and then I'll be able to control the target computer, and I'll basically hack it and have full control over it. Now in the next lecture, I'll show you a very basic way to deliver the backdoor to the target computer and how to test the backdoor and make sure that it works properly. Now we're ready to receive connections from our backdoor. So we created the backdoor, we set a payload, and we're listening for incoming connections here from any connection that comes in from the same backdoor on the same port on the same IP. So now if a person runs that backdoor, we'll receive the connection back in here on this computer. What we're gonna do now is we're gonna test the backdoor to make sure that it works. And to do that, we're gonna use a very basic delivery method. Later on in the course, we're going to talk about smart delivery methods that will trick the person into opening the file that we're sending to them. For now, we're just doing a very basic example just to test our very basic backdoor. So to do that, we're just going to put the backdoor on our web server and then download it from the target computer. So there's nothing smart about this, and you probably can't use this way to deliver the backdoor to a real person. So we're only doing this for testing to make sure our backdoor works. So Kali comes in with a web server, and what that means basically you can use Kali as a website. So what we're gonna do is we're gonna put that backdoor in that website and then just download it from the target Windows machine. Now the website directory where you should store the website files is var www.html. So I'll show you where it is now. If you just click in here on the path and then put a /, it will allow you to manually type the path that you want to go to. So we want to go to var www.html. And this is the location where the website files are stored. Now for you, you'll probably only have index.html. You won't have all of that stuff, but that's just stuff that I created while I was testing a few things. So the index is the main page that people usually see when they browse to this website. So what I'm gonna do here is I'm gonna first of all create a directory, and I'm gonna call it evil files. So every time we create a backdoor or a keylogger, we're going to put it in here and then download it in the Windows machine to test it. And again, later on in the delivery methods section, we're going to talk about smart delivery methods. For now, we're only going to be creating the evil files and test them to make sure that they work as expected. So I'm going to call this directory evil files. And inside it, I'm going to put the backdoor that we created before. So the backdoor that we created was made using Vilevasion, and Vilevasion actually gave us the full path of it when we created it, if you remember, or you can go back now to the lecture and have a look on it. So I'm just going to press Ctrl-T to open a new tab. And then again, I'm going to click on the path in here. And I'm going to put / to manually enter the path. And then we're going to go to var lib Vilevasion output compiled, hit enter. And you'll see the backdoor that I created right here. And we named it rev https 8080. So I'm going to copy this and paste it in here. And that's it. Now we can download this file from the website that Kali uses, that Kali has. Now to start the web server, to start the website, we have to start its service from the command prompt. And to do that, we're going to do service Apache2 start. So the command is service to start the service. Apache2 is the name of the web server. And then we want to start this web server. I'm going to hit enter. And because we didn't get any errors, that means the command got executed properly. Now everything is done. So the IP of the Kali machine was 10.20.14.2.13. It's the same IP that we're listening here, and it's the same IP that you'd get if you run ifconfig. So I'm going to go to my Windows machine, and I'm going to navigate to my IP address of the Kali machine, which is 10.20.14.2.13. And this will open the basic index.html that I showed you. And it basically just says it works, telling us that the web server is working and the website is working. This is all inside var www.html.
So if I wanted to go to the directory where we put the backdoor, then we're just going to go to evil files because we called it evil files. I'm going to hit enter. And you can see the backdoor that we created in the previous lecture, and we called it rev https 8080. So if I click on that, it's going to download it for me. And like I said before, this is not the smartest way to deliver the backdoor, but right now all we want to do is just to test the backdoor and make sure that it works. So if I click on the downloads and run the backdoor, it's going to tell me that this is an executable, so be careful when you run it, but this is not detecting a virus. It's literally just saying be careful when you run exes. I'm going to run it anyway. And once we come back here, you'll see that we received a connection from the target machine. So we didn't connect to the target computer. The target computer connected back to us. So you can see the IP of the target computer, which is 10.20.14.206. And that IP connected back to us on port 8080. Right here. So basically now we have full control over that computer. Right here, you can see that we have a Meterpreter session. And what Meterpreter allows us to do is literally do anything that the user can do on their computer. So we'll see how we can use the Meterpreter later on in the post-connection attacks. For now, we can see that the backdoor is working. And if we do sysinfo, you can see that we are inside the MS Edge Windows 10 machine. It's Windows 10 right here. It's x64. It uses English US, and it uses a Meterpreter x86 for Windows. So as I said, now we can do anything we want on the target machine, and we'll talk about how to use the Meterpreter later on in the post-connection section. But again, basically right now we hacked the target computer and we have full control over it.
Previously, we learned how to create an undetectable backdoor, which is great. But we delivered this backdoor by simply downloading it at the target computer. Now, this will probably not work in real life. Your target will never just download an executable and run it if you ask them to do that. Therefore, in this lecture, I want to show you a smarter delivery method where we will spoof an update. So when a specific program at the target computer checks for updates, it will say that there is an update, and when they install that update, they will actually be installing a backdoor. The only limitation to this method is you need to be the man in the middle. It doesn't matter how, but you need to be able to intercept the connections. So you can do this using ARP spoofing, or using a fake access point, as I showed you before, or using any other method that will allow you to intercept the connections. So usually, programs have a specific domain that they use to check for updates. So let's say we have the user here that has a specific program. It wants to update something. It'll send a request to a specific domain. And let's say this domain, in this case, it's updateserver.com. This will be sent to the DNS server. The DNS server will respond with the IP of the update server, which we have right here. And then the user will send a direct request to the update server looking for updates. If there are updates, then the update server will respond with the updates. Now, if we are the man in the middle, if we're able to intercept all the requests and the responses, then when we get a request for updateserver.com, instead of giving the IP of the update server, we can actually give the IP of a hacker server. This server is running a special program called EvilGrade, and EvilGrade will tell the user that yes, there is an update, and instead of serving them an actual update, it'll serve them a backdoor. So when the user agrees to install this update, they'll actually be installing a backdoor on their system. Let's do this practically and it'll become even clearer. Right here, I have my Kali machine. This is the custom image that I made for this course. Therefore, it has EvilGrade pre-installed in it. So first, we'll need to navigate to the location where it's installed. We're going to use the cd command to do that. And it is installed in OPT EvilGrade.
And then to run the binary, the program itself, we're going to do ./evilgrade. Now, using evilgrade is very simple and very similar to Metasploit. So, to get a list of all the programs that we can hijack their updates, we're going to do show modules. And as you can see, you have a lot of famous programs such as WinZip, VMware, Skype, Safari, and so on. Now we're going to be doing this on a program called DAP, Download Accelerator Plus. So we have it here. So to configure a specific module, all we have to do is just type configure module name, which is DAP. So you can replace DAP with any module that you want to configure with any program that you want to hijack. So I'm going to hit enter. And as you can see, it's saying now I'm inside the DAP module. And I'm going to do show options to see all of the options that I can set. So as you can see, we get a list of all the options that we can set. And the main option that we want to change is the agent. This is the path to the program that will be installed as an update. So in our case, we're going to be replacing this with the backdoor that we created in the previous lecture. So to change this option, we're going to do set agent, the option name, to the location where I have my backdoor. And my backdoor is in var www html backdoor.exe. So as you can see, the format of changing options is very similar to Bettercap and Metasploit. We do set, followed by the option that we want to change, followed by the value. So I'm going to hit enter, and that's done. The next thing that I want to modify is the end site, which is the website that will be loaded once the update is successful. Now, I know this will return a not found error. That's why I'm going to change it. You don't have to change it with every module. So again, to change this, we're just going to do set end site, and I'm just going to set it to just the basic domain, which is speedbit.com. And finally, before we run everything, I'm going to do show options one last time to make sure that everything is set as I want it. So I have the agent set to var www.html backdoor.exe. That's perfect. And I have the end site set to the way I want it. So I'm ready to go. And all we need to do now is just type start to start evilgrade. So right now, if evilgrade gets a request for an update, it will say, yes, there is an update, and it will serve the backdoor.exe as the update. The only problem is, it will never get any requests right now, because I am not intercepting connections. I'm still not the man in the middle. Therefore, we're gonna become the man in the middle using Bettercap. Like I said, you can use any method you want to become the man in the middle, but we're just gonna do it using ARP spoofing right now. So I'm going to use Bettercap using the exact same command that we've been using before. So we're just doing Bettercap, giving it the interface connected to the network, and giving it the spoof caplet so that it runs an ARP spoofing attack, putting me in the middle of the connections. I'm going to hit enter, and this will run with no errors, so that's perfect. We also need to use Bettercap to run a DNS spoofing attack and spoof any request to update.speedbit.com. This is the domain that the target program uses to check for updates. And we want to spoof DNS requests to this so they return the IP of the Kali machine right here, which is running evilgrade. So evilgrade gives them the fake update. Now, I covered how to do DNS spoofing in details in a full lecture before, so if you don't remember how this works, please go back and revise this lecture because I'm going to do it a little bit quickly right now. So, I'm going to copy this domain, and I'm going to clear the screen here, and we're going to set the DNS spoof all to true, and we'll also set the DNS spoof the .domains to the domain that we want to spoof. Finally, we're going to start the DNS spoofer by doing DNS spoof on. And perfect. Now it's working, and it's telling us that it's going to spoof any request to update.speedbit.com to the IP of my Kali machine. The IP of my Kali machine is running EvilGrade. EvilGrade will say, yes, there is a new update, and it'll serve them the backdoor that we have right here. And that way the backdoor will be automatically executed on the target computer. The only problem is the backdoor will get executed, but we're not listening for incoming connections here, so we won't really get access. Therefore, we need to listen for incoming connections using Metasploit, as I showed you before. Now, I've already configured my multi-handler. Again, I covered this in details, so if you don't remember how to do it, please go back to that lecture. Right now, I'm just going to do show options to show you the options that I set right here. And you can see that I am using a Windows Meterpreter reverse HTTP here because I'm actually using a different backdoor in my EvilGrade, this backdoor right here. It's not a reverse HTTPS as shown in previous lectures. It's actually a reverse HTTP backdoor because for some reason I noticed the HTTPS backdoors are not working with EvilGrade. That's why I created a reverse HTTP backdoor specifically for this lecture. So I'm setting my payload to the same payload that's used in my backdoor. I'm setting my IP in here. I'm setting the L port to 8080. So everything is perfect. I'm going to run exploit to listen for incoming connections. And now we're ready to go. So now let's go over this one more time. When we go to the target computer and check for updates, right now this computer is intercepting connections because of Bettercap, and it's also going to spoof any request for update.speedbit.com to this IP. This is the IP where EvilGrade is working. EvilGrade is going to say, yes, there is a new update. The update is this executable. The target computer will take this executable, it'll run it because it thinks it's an update. When this gets executed, it'll send a connection to us in here in our multi-handler. So let's go to the target computer and see if this will actually work as we expected. So I've already downloaded Download Accelerator Plus, the program that we're trying to hijack its updates, and installed it. So I'm just going to double click it to start the program. Now it's just asking me to set it as the default download manager. I'm going to say no. And I'm going to go to help. And I'm going to click on update now. We're going to say yes. Check for updates, please. I'm just going to uncheck this. Click on next. It's checking for updates now. And it's telling us that there is a new update. So we're going to say next. And it's telling us right here, it's a critical update. So I'll be like, yeah, I want to install this. This will download the update for me and install it. And it's telling us that it's done. Everything is done. We're going to say next. Thank you very much. And finish. Now, if we go back to the Kali machine, you can see we got a reverse connection here from the target. And just to confirm this, we can do sysinfo to see more information. And perfect, as you can see, we're inside the target computer, and now we have full access to that computer and can do whatever the normal user can do on their system. Now, I will talk more about post-exploitation and how to control the computer using this Meterpreter access in the post-exploitation section, but right now we managed to hack into a computer using a fake update.